Hi everyone, hope you're all doing great. In this course, we'll learn everything necessary for you to start from level 0, where you might not have any idea about coding, to a stage where you can directly implement your data science skills in real life scenario. But before we move forward, we need to understand the role of coding in data science. So, coding is merely a tool that helps us execute the process of data science. The most important part here is our sense of logic and our business acumen. But to get started, we need to learn coding and we need to implement those codes to exercise our visualizations and logic. Well, that said, let's dive into the course. Before starting with anything, let's understand, why do we need to learn programming at all? The most basic important thing for it is that it teaches us to think in a structured manner, to let go of the declutter and make everything in a channelized way. Now, computers, as we all know, are built to make our lives easy. However, they can only be communicated to via their own language, which is codes. For example, in this course, the medium of learning is English. Amongst all of you, someone might be speaking Hindi, someone might be speaking Bengali, some other might be speaking Gujarati, Punjabi, and all. But there needs to be a common ground through which we can communicate. And here, that is English. Same for computers. They learn the language of codes. Now, coding can have different languages as well, like C, C++, Java, Swift, Python, R, etc. Codes are basically nothing but stored instructions, a sequence of stored instructions that basically directs the computer what to do. They're written in their own form, and we need to learn this particular form and communicate with the computer. And now, with advent of different programming languages, Python, for example, it's very similar to our English language. Again, it also provides many facilities for which the ground language of our this course would be Python. So let's understand the facilities that Python provides. Python is basically a very simple language and is therefore very easy to understand and learn for beginners per se. Even for people coming from other programming background, it would be just a jiffy that you learn Python. It provides some excellent packages of AI or machine learning, whatever you want to call, some of which are Matplotlib, Seaball, Plotly for visualization. Plotly provides a dynamic visualization. We will learn all of this in this particular course. NumPy and SciPy for scientific computation. Scikit-learn, which helps immensely in machine learning. Scikit-learn is such a package which has developed machine learning. We just need to import those particular machine learning models and run them. And now, for deep diving into the machine learning process, we need to learn how those machine learning models were created. We'll learn everything in this course as we go. TensorFlow for deep learning processes. Most importantly, Python has an extensively used big community. So what is the role of a big community? Let's say it is something that is certain of. When you learn through this course, when this course ends, you might have a basic or a mid-level understanding of what data science is. You might be able to contribute to real-life scenario data science projects, but the more you learn, the more you go forward, you will definitely come across different barriers which needs to be cleared. You might find yourself crossed in some confusions and everything. That's when the role of the community of data science or Python per se comes into play. There are different websites, Stack Overflow, for example, where you will find enormous people posting questions and these questions being answered by your peers. Whenever you find yourself in some trouble, Google it or post your questions in such kind of websites, Stack Overflow, for example, and you'd instantly find those questions being answered because of the presence of such a wide number of people using Python. That's a very beneficial part that Python has. Now, Python is basically a general purpose. Again, I'll be making you understand what these terms are. So general purpose, what do we mean by that? General purpose means that it is not specific for any particular domain. Python can be used for, let's say, analytics, web development, app development, gaming, and many more. Robotics, for example, AI, IoT, many more. It's also high-level programming language. What do we mean by high-level? High-level means it's very near to the human language. As we learn Python, we'll understand it's nothing but simply understanding English language. If you have coded in any language, or if you know about the languages used in the 1900s, you would understand how difficult they were compared to Python. Those were called low-level languages. All right. It is also an interpreted language. By interpreted, we mean that the script can be executed without any compilation. People coming from any other background like Java or C, C++ would understand that a compiler is must for these languages. For Python, we need no compiler. It is executed without any compilation. And finally, it is also a dynamically typed programming language. What do you mean by dynamically typed? It means that it automatically identifies the type of the variables. For example, in other programming languages, we need to define that this particular variable is a int variable. Int means integer, or a string, or let's say a float, or something else. But in Python, we did not explicitly define what kind of variables we are using. By the value of the variables, it would automatically identify what kind of variable it is. We'll understand everything. And it was created by Guido van Rossum in 1991. That's a brief about Python. Now, the advantages that Python brings is that, first, it is an open source software. That is, it is free to use. We do not have to pay any money to use Python. It is a cross-platform library. That is a software, not a library. That is, it can be run on different OS, not specific to Windows or Mac. It can be run in others as well. It is integrable with other programming languages like C, C#, etc. Now, this is a very important point. Why? Because Python, being a high-level language, is pretty slow. And you would find this enormously in the industry, that Python is very slow. Why not use C or C#? Because these are fast languages. Especially if you know that in gaming, C# is widely used because of the fast reflexes. Now, Python has done an amazing thing, which is it can be integrable with other programming languages. So NumPy, for example, is a library in Python which is integrated with C, therefore making the process quite faster. Python has its own advantages, and being integrable with the faster programming languages makes the execution process much faster as well. All right. It is also an object-oriented language. Object-oriented language is nothing but uses of class. It creates a blueprint of the entire thing. We will learn everything about what object-oriented programming language is. It's very difficult to answer this particular thing in a couple of lines. We'll have a definite chapter for what object-oriented programming is. Just understand, it makes our code much easier. All right. Next, it has a rich library and community that I already have explained. And my favorite part, it uses fewer lines of codes. To the best of my knowledge, I've found Python using the least lines of codes to any other languages in the world right now. Now, applications of Python. It can be used in web applications, GUI, that is graphical user interface, for mathematical computation, data science and machine learning, that is analytics in short, game development, automation, where it finds it's another important use, and many more. There's literally many more applications of Python. Now, to get started with Python, we need to install some particular software so that we can actually use it. See, the first thing that we need to do is we can install Python right away and start using our command prompt to handle all of those stuff. But since this course entails learning the data science process all in all, what I recommend is we install a software called Anaconda. There we'll get many small softwares, one of them being Jupyter Notebook. And Jupyter Notebook is the bread and butter of data scientists. We'll understand. Let's now understand the process of installing the same. And with the course, as it progresses, we'll understand everything that I'm telling about. So, quick notes. Preferably the version 3.6.8 should be installed because it handles all the data science libraries pretty well. But however, the latest version that I have installed now entails handling all kind of problems pretty well. So I recommend using the latest version. I'll just show you the particular process of installing the latest version. If not, I have already given the links of the version 3.6.8 for Windows and Mac as well as Linux, both for 64 and 32-bit. One more quick note that if your laptop or computer per se has poor processing power, that is, you're using an old laptop or a computer, consider using this particular website called Google Colab, because you will need nothing except your good internet connection for that, and everything will be running smooth and efficiently. Okay, so let me go to the internet and show you all the process, right? We are now in my Chrome. So let's say you want to install Anaconda. You have a decent laptop and you want to install Anaconda. Just type in Anaconda, A-N-A-C-O-N-D-A, Anaconda. Go to the first link over here. Press on the download button. It would start downloading. Based on your internet speed, it would take some amount of time. It's a relatively larger file, 621 MB. Now, while it downloads, I've already downloaded this particular file. I'll show you. So once you've downloaded Anaconda, go to your download section, the folder where you have actually downloaded it. You'll find this exe file. Double click on the same. It would take a while to load. Now, as instructed earlier, click next, I agree, next, just me, and then choose your destined folder. Advisable, use the C folder as it is, and go on clicking next. I won't be doing the same because I already have it installed. But for you guys, just go on and install it. Now, once you install the same, there would be asked if you want a startup icon. So click yes if you want it. If you don't, just click it no. How do you get access to it? If you have this icon on your start menu, then you can just double click on it. If you do not, click on the start bar, click here Anaconda, and open. All right. I would highly recommend it. You pin it somewhere down here so that you can get a quick access to it every time you use it. Now, once you click on this particular icon, this particular UI opens. You have a lot of other software here, but what we'd be using is the Jupyter Notebook, this particular thing. So go here, click on launch. Let it launch. Okay. So now it says localhost 8890. That is, it's running from your PC. This is the entire thing of the place where the folder has been installed. Now what I have done is I've created a random folder. So that, and I have numbered it 1, 2 like that, so that I can get use into that. You can use this particular technique, or if you just want to create anywhere here, create a folder and start using the file as it is. So I'll be clicking on here. Now let us create a Jupyter notebook. What I'll do is, you'll get this interface, click on new. Here you get all these options. Python 3 IPy kernel. It means a Jupyter notebook itself. Text file is something that is .txt that we use in Notepad. Folder is this kind of things when you wish to preserve your files in a folder in a particular name. Terminal, you don't need to use it right now. When and where we'll be using, I'll let you know. What we'll be doing here is clicking on this particular Python 3 IPy kernel. Separate tab opens over here. All right. You see this particular tab here, untitled as it is called. Now, you might want to change the name. Let's say I change the name to demo. How do you do that? Click over here, demo, and click on rename. That's all. Now you might want to write your codes, whatever it is. So let's say I write a basic Python code. I'll explain how it is done just for the sake of understanding. Let's say I'm writing b equals to 12, a equals to 3, and let's say I'm adding all these 3. So sum equals to a plus b, and I'm printing the addition of a plus b, that is 15. Okay, so what did I do? You might want to create on run. Then what happens? Your file gets executed. Or if you want to use your keyboard keys, what you do is you press Control plus Enter. That is, again, can be done. Control plus Enter. One more key that you should be aware of is Shift plus Enter. What it does is same as Control plus Enter, but it also creates a next cell below it. Now let's say you are not comfortable of using the keyboard, then you can use all the commands over here. So for executing, create on run. For new cells, create on this plus icon over here. For deleting a cell, press on that particular cell and click on this particular Caesar icon, and your cell gets deleted. Okay. There are many more features to be used. We'll understand as we go along coding. For now, let's get our knowledge limited to this particular part. All right. Okay. One more thing, if you want to change the name from the outside, what you can do is click on this particular tile. First, shut it down. So the green icon gets closed and it's converted to a black icon. Now click it again and then click on rename. And you can put your name, whatever you want. Let's say demo2 and then rename. So your file gets renamed as demo2. That is something you can also do. All right. Now let us learn the basics of Python. Start with it and we'll understand how to use the Jupyter Notebook with time. Those were the basic things that I let you know. All right. Now, let me grab my PPT very quick. All right. So the Python fundamentals. The first thing that I want you guys to know is that the concept of variables. Okay. So contrary to a lot of concepts that we have learned in past. Maybe if we belong from a coding background, that variables are containers wherein all the variables, all the values are stored. This does not really apply to Python. So how does people make you know the concept of variable? It is a container and you put some value, let's say 42 inside it. This container, we call it as A, which is a variable, and it contains the value 42. While it is true for many other programming languages, this is totally false for Python. In Python, variable is nothing, merely a pointer to a particular memory location. So let's say you have some data stored. Let's say I have a data stored. This is my memory location. Let's say 42 is the value. And A is the variable. When we assign A equals to, we'll also learn how to assign values. So let's say we assign the value A equals to 2. Or let's say, sorry, A equals to 42. So what happens? A pointer A is created and it points the value to this particular memory place. Let us assume that we again create another variable called B, having the same value 42. Then what necessarily happens is another pointer B is created, which points the value to the same memory place, that is 42. Therefore, we cannot actually call it a container. This is a container A containing value 42. This is a container B containing the value 42. No. Basically, these were pointers pointing at this particular memory place where the value 42 has been stored. This is very, very important, this particular concept, because this is how we reduce the time and space complexity. We'll understand much of it as we move forward. All right. Now, also one more thing to note is here. Let's say we again assign A to be 5. What happens then? This particular pointer gets destroyed, this arrow. Another memory place where 5 has been put gets assigned, and A now points at this particular memory place. That is how Python actually works. I hope you get this point clear. Now, so basically, a variable is a location in memory used to store some data. They are given unique names to differentiate between the different memory locations. Now, reserved words are something that you should never use as variables. Python contains some reserved words which have been listed over here. These are something that can never be used as variables. We can use A as variable, but we cannot use AND as variable, or for that matter, none of what has been mentioned over here. All right. Why do we restrict ourselves from using these particular keywords? Because these keywords have other usage. And once these are called, the computer itself, Python itself, understands that some different tasks needed to be performed. So it cannot actually recollect that what you exactly want it to do. Therefore, we generally restrict ourselves with very common keywords, or X, Y, A, B, C, and other stuff. We'll again understand all these things. These are not very difficult to understand. Okay. So let's move to the next slide. How do we declare a variable? Python doesn't need explicit declaration of variables. The declaration happens automatically as we assign value to it. What it means is, if A is a number which is equal to 42, what we do is A equals to 42. It understands that A is a number, is an integer. Again, if A is a string, that is a letter, a group of words, let's say hello, Then what we do is we write a equals to hello inside the parenthesis, which may be double parenthesis or single parenthesis, whatever works. Both are same. Now, note, we never actually declared that a should be an integer or a should be a string. The Python language itself understands that when you write 42, it understands the user needs a to be a integer variable. When you write something inside the parenthesis, it understands that you need it to be used as a string variable. You can also write 42 inside a parenthesis, and in that case, it would treat 42 as a string, not as a number. And do remember, in that case, you cannot use it as a number. You cannot add, subtract, or perform any mathematical operations. It would only mean a simple string. All right. So the equal sign is used to assign the variables as I have shown. All right. Now, so I have given an example. Here x is the variable and equal to is the assignment and 1 is the value over here. All right. So the rules for naming variables. There are some rules that needs to be followed. A variable name must start with a letter or underscore. So this is correct. It is started with a letter, and this one is starting with an underscore. So both are correct. However, it cannot start with a number. For example, this particular thing here, a number has been given at the preface, and it cannot be a particular form of a variable. Either you started with a letter or an underscore. Both are correct. You cannot necessarily start with a number. The third and most important point, that no variable can contain any characters other than alphanumeric characters. It can either contain a number or an alphabet, nothing else, except an underscore. Underscore is something that a variable can use. Other than that, any numbers or any string or alphabet, whatever you want to call it, nothing else. So at the rate, for example, is incorrect. Here, had you used an underscore, it would have been absolutely correct. You cannot rather use any other symbols inside, let's say this d at the rate ATA. This is again wrong. So no symbols can be used other than an underscore. All right. Now, having learned this, let's perform some lab assessments. So let's start with the Python fundamentals part. All right. So the first thing that we want to do is check our Python version in the Jupyter Notebook. For that, you need to type these two particular commands: import sys, sys, sys.version. So when you press Control and Enter, this is what it shows for me. If you have downloaded the latest version, it would be showing the same for you. Otherwise, let's say if you're using this particular course at a much time ahead in future, it might be showing some future versions as well. All right. Now, let's get into this particular topic of Python variables. So as I've already mentioned, variable is a location memory used to store some data. They are given unique names to differentiate between the different memory locations. Now, what happens over here is, I have assigned x to be 3 and y to be 3. I've only told you in theory what happens. Now let's check if I were right or if I was just playing. So one good function in Python is id. So when I write id of x, it gives me, as I told, that this is a memory place. And here the number 3 has been located. Now x is, as I said, is pointing over here. Y is pointing over here. Correct? Now when I write id of x, what it necessarily does is, it gives me the location where x is pointing. Alright? Similarly, when I write id of y, it gives me the location where y is pointing. So let's check. Alright? Now let's see. Now id of x is showing 12172202745444. id of y is showing the exact same. Both are exactly the same. Just check it out. Why? Because both x and y points to the same memory location, that is where 3 has been stored. Now, in the next step, what I do is, I have changed y to 2. Therefore, what necessarily happened was, previously, there was this memory location, x and y were pointing to it. Now, what has happened is, there came another memory location where 2 has been stored, and y is now pointing at this particular memory location. Therefore, id of y after the memory location has been changed is, see, it has changed. 121722027445. Up to that, it is same. While the first two has 44, this one has 12 in it. So it has changed. Now, we do not really need to go deep into it, that why, what, how the numbers are created. These are simple RAM memory spaces, and this is how the values are assigned. The thing that needed to be noticed was that these are not containers. Had it been containers, the numbers would have been same for y and same for all the x, and different for x and y. However, here the numbers are same for x and y, but different for the values that has been stored. Hence, the theoretical part that I had been saying is proved to be true. All right. Now let's understand the keywords that I was talking about. So keywords, what are they? They are reserved words in Python. We can't use a keyword as variable name or function name or any other identifier. Keywords are also case sensitive. All right. Now, you do not need to really understand what this code is. Just understand what I'm doing is, I'm importing a library called keyword, and I'm just giving you out the list of keywords that are present in Python. So these are the list of keywords that we have in Python. And how many keywords are there? These are 36. So there are 36 keywords that cannot be used as variables, function names, or anything. All right. Also do understand that Python, the language Python, is case sensitive. That is, capital A and small a has different meanings. All right. Now coming to the next part, where we are declaring variables. So as I said, to declare variables, we use this particular symbol equal to. So a equal to 3, b equals to Python, c equals to 5.7. Print a, b, c. This is how we print. When we printed it, it says 3, Python, 5.7. Now, an efficient way to declare all the variables, if we have multiple variables and we need to declare them, what we do is, we line up the variables one by one. Here what I have done is a, b, c equals to 3, Python, 5.7. And I've printed them. The same result is what we get. Now for beginners, this is not something that I will be recommending. But as we go ahead, as we progress, this is something that we can use to save some amount of time. All right. Now, let's understand what scope of variables means. So I'll be pulling my, so scope of variables. Scope is basically the part of the program where the variable is accessible. There are basically two types of scopes, local and global. Local scopes are, okay, let's understand in this way that when we create a function, we do declare some variables inside it. We'll understand what functions are basically, but for now, functions are pieces of code which perform collectively a particular operation. Let me make you understand this by practical exposure. Okay. So what is happening over here? I have written this particular function, def. I've given a function name. We'll be understanding how we create a function. And I have given this name, the variable, that is var equals to 4. Now I'm calling this function, all okay. And now I'm printing, print var. It is giving me an error. Why it is doing so? If I called it, let's say if I call the same thing over here. Okay. See, the value 4 is being called. Why is it so? Because this is a local variable and it can be called locally inside the function. But when I'm not calling it locally, when I'm calling outside the function, it is giving me an error. The reason is very simple. Everything that occurs inside the function is a closed, consider it as a closed room. You cannot access this particular room. And everything outside is the global space. All right. So what is a global scope? A global scope is when the variables created inside the main body of Python code. All right. So what happens over here is I have created another variable called var2, which is equals to 6. Now I'm creating another function, var equals to 4. And now what I'm doing is I'm also creating, I'm calling this particular function and I'm printing var2. Now when I'm calling var2, it's printing 6. So this is how it prints. Why? Because now it does not really needs to enter this particular room, this concealed room. It can find var2 outside this particular concealed room here. That's why it can print. Now let's say var, okay, let's make you understand it even more. Let me put the same value outside, var equals to 4. All right. If I had done this, what is your expectation? What would have we got? Nothing but the same thing. Okay, let me change it over here as well. So we would have got 4 as the answer. This 4 is coming from this part, not this part. If var equals to 5, we will be getting 5 as the answer. All right. Now, one very important thing to understand over here is the priority of scopes. So local scopes has more priority than global scopes. How do we understand it? See, here we have written var equals to 6. And here, inside this closed concealed room, we are given var equals to 4. Now, when we print var, it actually gives me 4, the value 4. That's what happens. See, 4. And for the second print, var, it gives me 6. Let's say I commented it. So putting a hashtag in front of any line gives me comments that particular line out. That is, it becomes non-executable. So see, when I stop this from execution, the value we get is 6. That is this one. Because this is a closed concealed room, var equals to 4 cannot be accessed. var equals to 6, that is outside the room, is getting accessed. However, when we conceal this particular print and open this one, what we get over here is a 4. Why? Because inside this function, both var equals to 4 and var equals to 6 is getting registered. However, since the priority of local scope is greater than global scope, between var equals to 4 and 6, it chooses var equals to 4 because var equals to 4 is a local scope, the local function. To understand it more clearly, if had we commented this var equals to 4, we have got a var equals to 6. As I said, inside this particular function, both var equals to 4 and var equals to 6 is accessed. However, since local scope is greater than global scope, it chose var equals to 4. Now that var equals to 4 does not exist anymore, it chooses the global scope. Alright? I hope you understand each and everything because it was really very important for you guys to understand. Alright? Now, one more important thing that we can do is declare global variables inside a function. How do we do that? Once we call the function, and before declaring the variable, we write global and the name of the variable. So the name of the variable is var. Before that, we have introduced another keyword called global. So global var. It now creates the var not as a local variable, but as a global one. How do we know about that? So inside this closed room, var has been declared. And we are calling this function outside. Still, we are getting the value 22. Only because we have declared it as a global variable. So these were the tits and bits. What did we learn? The scope of local variable and the scope of global variable. How can we declare a global variable inside a function? And the priority of local variable is more than that of global variable. All right. Now let's come into the part where we deal with the data types. So every value in Python has a data type. Data type is nothing but, as I said, string, integer, and everything. Now, one important thing that we need to understand is everything. And I repeat, everything in Python is an object because Python is made in such a way that it is an object-oriented program. So everything inside a Python is an object, and every data types are actually instances of these objects. All right. And that is the reason you find here class integer, class float, class complex. So since everything is an instance of an object, what we'll be considering is the second half. That is integer, float, string, boolean, and everything. All right. Now let's understand how it actually works. So I've declared a equals to 5. And we very well know that 5 is an integer, right? Therefore, when we print the type, and how do we know what kind of a data type it is? We know by the keyword type. What we essentially do is, let's say we have declared a variable a equals to 5. To know the data type of a, we write type of a. And we get class, because it's an object-oriented programming, and what kind of instance it is, that is int. So I've written a equals to 5. The type of a is integer. B is equal to 5.5. 5.5 is not an integer anymore. It is a decimal number, which in Python we call as float. C equals to 1 plus 2j. For people belonging from mathematics background, you must have heard about complex numbers. A plus IB, this is the form it takes, or x plus IY. So in Python or in electrical engineering for the engineers, we write it as 1 plus 2, x plus IJ, x plus YJ. So that's how in Python it is written, 1 plus 2j. This is the real part and this is the imaginary part. And the type of C is complex. We can also extract the imaginary and the real part as well. D equals to hello, which is a string. And that is the reason it is giving me str. Str stands for string in Python. There's another important data type which deals with true and false only. Okay. So it deals with true and false. These are called Boolean. And is represented as BOOL, bool. So true is a Boolean data type. All right, moving forward, what is typecasting? Now, let's say I have introduced a variable x, which points to 5, which is an integer, right? So I can know that this is an integer by printing the type. Yes, it shows it is an integer. Now, let's say I want this 5 to be a string. How can I do so? There are basically two ways. One is that what I do is I write x is equal to 5. In this case, it would be taking 5 as a string. But what if I have already declared x is equal to 5 and I want to change it to a, let's say, string? We do something called as typecasting. What I do is I write str of x. And I can enclose it within another variable, that is y. So y is equal to str of x. Now, when I print its type of y, it should give me a string. So that's what has happened over here. Firstly, I had introduced x is equal to 5, which is an integer. That's what it shows. Now I had typecasted it to string. So y is equal to string of x. Now print type of y gives me string. All right. Now typecasting has different methods. Not only we can typecast an integer to string, we can typecast a string to integer as well. For that, we do have the minimum requisition. That is, it should be somewhat like an integer. We cannot necessarily typecast a string called 5.5 to integer. Then it can be typecasted to a float maybe. All right. Now, let's go to the next section called operators. We have a total of 6 operators in Python. Now, there is nothing to be overwhelmed of. All the 6 are very easy if we bring our logic into being. The first one is called arithmetic operator. The second is called assignment operator, comparison operator, logical operators, identity operator, and membership operators. Now, starting with arithmetic operators. This is nothing but contains all the arithmetic operations inside it, like addition, subtraction, multiplication, division. Is something called as float division, exponent, and modulus. So let's understand each one by one. All right. So I've taken 2 variables, that is 5 and 3. Addition is simple. We write x plus y. Again, let me clear it out, you might have been seeing all these things all along. What is this? Let me create another cell for you. So for addition, what we need to do is essentially, first we need to call it. First, let me assign x, the value of x and y. Then if we need to add, what we do is x plus y. It gives me 8. If I do a subtraction, x minus y, it gives me 5 minus 3, that is 2. If we do a multiplication, x into y, it gives me 15, that is 5 into 3, 15. What if I want to do a division? 5 divided by 3, we'll get the quotient. I'm sorry, we'll get the entire thing. That is 1.667, right? Now, float division or integer division, this particular thing, is nothing. We put 2 division signs or backslash, whatever you want to call it. And then in that case, it gives us the quotient. That is 1. 1 point something, so it will be giving us the quotient part, 1. The remainder, it won't be giving us. All right? And there's something called as exponent as well. Exponent is to the power. So 5 to the power 3 is 125, I guess. 5 into 5 square is 25, and 25 into 5 is 125. Okay, so there should be 2 stars for that. 5, and it's giving us 125. What is modulus? Modulus is basically taking the remainder part. So 5 divided by 3 gives us a remainder of 2, right? Quotient is 1 and remainder is 2. That's what it does. So I hope you understood the arithmetic operators. Now, this is something I'll let you understand this as well. What it does is, when we write the print statement, print, print, we need to put the brackets, and everything we want it to print inside should be done inside a parenthesis. So what I've written, addition, 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 and it prints the addition. All right. What if I want to print a value of 5 with it? After addition, I put a comma and then x. Now it would print addition 5. I hope you got the point. So that's what it is doing over here. X plus y is the sum, that is 8. Addition, after that an arrow sign followed by a comma and x plus y. That's what it has done. Addition is 8. Subtraction is 2. Multiplication is 15. Division is this. Integer division is 1. Exponent is 125 and modulus is 2. All these things I have written. I hope you get an overview how I have used the print statement. This is something that we'll be using widely in data science as well. All right. Now coming to the assignment operators. As I've already let you understand that this is how we assign. Let's say we want to add 2 numbers, x and y. So I have what I've done is I have assigned them. X and y is 5 and 3. X is equal to x plus y. That is 8. Print x. So x is equal to 8. What we could also have done here, instead of x is equal to x plus y, we could have written x plus equals to y. So let me grab the pen real quick and explain. So x equals to x plus y can also be written as x plus equals to y. What does it do? See, if you're a beginner and you do not quite understand it, or you feel overwhelmed by this particular form, no problem at all. Use this one instead. This is absolutely good. But this is something you might be seeing in other people codes, or you need to understand what it is. And in later, I can assure you that you'd be using this particular format, x plus equals to y. But for beginner, you can use this to start with. So let me make you understand what it is basically. So x plus equals to means, okay, plus equals to means x plus. It actually means equals to x plus something. That's what I've done. X equals to x plus y. X plus equals to y. So instead of x plus, I've used plus just before this equal to sign. It is meaning x plus. Did you get my point? So basically, x is equal to x plus y. We can write it as x plus equals to y. Whenever you see any variable plus equals to any variable, it can be 2 as well. Let's say a constant number 5. It means x is getting added every time by a constant number 5. X is equal to x plus 5. So x equals to x plus 5. That in short can be written as x plus equals to 5. That's what I've done. X is equal to x plus 5. Here I've done the same thing. X plus equals to y. Print x, that is 8. Alright? Now, comparison operators. What are these? Comparison operators basically consist of, they are used to compare values with one another. And the result is in Boolean. It is either true or false. The following are the basically comparison operators. Double equal to, which means it compares if this particular value is this particular value, equal to or not. Not equal to, we put a exclamation mark before equal to, and that means not equal to, greater than, less than, and greater than equal to, less than equal to. So let's understand one by one. So equal to, print 2 equal to 2. Is it true or not? Yes, 2 is equal to 2. So again, do note one thing. We do not write 2 equal to 2. Why? Because equal to in Python is basically assignment. X is equal to 2 means x points to the memory location 2. But x equals to 2 means it is a logical operator which checks if x equals to 2 or not. Alright? So here 2 equal to 2 is true. Again, 2 not equal to 5, it is true. 2 is not equal to 5 and hence it is true as well. Greater than, 4 is greater than 2. Again, it's true. Greater than equal to, we put a equal to sign after the greater than sign. So 4 greater than equal to 4. Is it true? Yes, it is also true. 4 is not greater than 4, but 4 is equal to 4. So it falls in the same range. That is 4 is greater than equal to 4. Next, less than. 2 is less than 6. This is correct as well. And 6 is less than equal to 8, which is again true. 6 is not equal to 8, but 6 is lesser than 8. So, okay. Now we come to the logical operators, which consist of only 3 things: and, or, and not. So we'll understand how to use it. It is again very, very important. So we use this to combine things. In English, as we call it as conjunctions. So and, what we do? I have assigned x to 5. So x equals to 5. Now I'm giving a condition. Is it true or not? X greater than 2 and x less than 10. Is it true? Yes, it is definitely. Because 5 is definitely less than 10 and 5 is again definitely, 5 is definitely greater than 2. So x is greater than 2 and x is less than 10. It's correct. And it's therefore giving me as true. For or, it's saying x equals to 5. X is greater than 2 or x is less than 4. Is it true? Is x greater than 2? Yes, x is greater than 2. Is x less than 4? No, x is not less than 4. X is greater than 4 as well. But since one of the condition has fulfilled, that is x is greater than 2, it gives me true. Now note one important difference between and or. For and, both the condition needs to be satisfied. For or, any one of the condition is satisfied, it gives us true. And not is simply the opposite of what has been mentioned. A is equal to true, not A will be false. That's what. Okay, now moving to identity operators. There are only two identity operators, is and is not. So is evaluates to true if the variable on either side of the operator points to the same object. Okay. And is not is just the reverse of that. So what I've done is x equals to 10 and y equals to 10. X is y. Is it true? Yes, it is true. As I have explained that this is the memory location, x and y. Both points to this particular memory place. And therefore, x is y is true. Yes, x is y. X is nothing else than y. And when I put y is equal to 20, so now y points to 20. So is x y? No, x is not y. So yes, x is not y is a true thing. Now you might have a little bit of confusion. If not, if you have been paying attention properly, you might have a confusion. What is the difference between x is y and x equals to y? This thing. Right? What is the difference? We'll come to that at the last. Let me make you understand once more. X is, okay, let us reserve this for the last. The very last operator is membership operator, which consists of two things, in and not in. In evaluates to true if it finds a variable in the specified sequence. And not in is just the opposite of that. So let us consider a list. List is nothing but a storage sequence. It consists of all these numbers, 3, 6, 4, and 1. 3 in Li. So this list I have named as Li. Now my question is 3 present in Li? So I'll be writing it as 3 in Li. Yes, 3 is definitely present in Li. And therefore it gives me true. Now let's see, is 7 present in Li? No. And I've written 7 not in Li. Is it true? Yes, obviously 7 is not present in Li. And therefore, we get true for that as well. Now coming to the most important doubt that you people might be having, what is the difference between equal to and is? Basically, equal to checks the equality. And is checks the identity, that is the IDs. Now, when I write A equals to A, I consider two lists, A and B, both having 1, 2, 3 as the elements stored in it. Is A equal to B? Yes, A is equal to B. Why do I say so? Because both the lists are exactly same, containing 1, 2, and 3. But is A and B having the same ID? I doubt that. No. How do we know that? What we do is we check their IDs. So what I've done is I've checked the ID of A, 760, while the ID of B is 8160. 160 and this is 760, and the numbers before that is also different. So they do not have the same ID, as a result of which A is B is a false statement. Alright? So that's all for today. This was a brief introduction about the fundamentals of Python. We'll be learning more in subsequent classes. Hello everyone. Today we'll be learning about strings in Python. So what are strings? A string is basically a sequence of Unicode characters. Now, Unicode characters are basically a type of characters used especially in coding. Let's just understand this terminology particularly as of now. We'll deep dive into it later on. Now, it might contain numbers as well as alphabets. As I said, A is a variable. If it is a variable containing strings, it can have the word hello in it, which is an alphabet, which is a word necessarily. It might also have numeric. For example, 4. So it might contain numbers as well as alphabets. It is written within single or double quotes. All right. For multiline strings, we use triple quotes. We'll see that in the lab session itself. One important thing to notice is that for strings, the plus icon does not necessarily mean addition, because obviously strings cannot be added as such. It means concatenation. So for example, let's say, understand the difference between these two codes. So let's say A is equal to 4 and B equals to, let's say, 6. And let's say A1 equals to 4, while B2 equals to 6. So what does A plus B give us? So right answer for the cases, it would be a 10. But what does A1 plus B2 give us? It does not give us 10. It gives us 46. So what it necessarily does is, here it performs the arithmetic operation. Since Python knew that it were integers. But in case of A1 and B2, it understood that these were strings. And therefore, the plus operator here did not mean addition, rather it meant concatenation. What is concatenation? Concatenation means adding the two, let's say, strings side by side. So that's what it did. 4 and then 6 put together. That's what the entire thing was, 46. It appeared to us as 46, rather it was a concatenated thing. All right. That said, let's understand the formatting techniques present inside strings. So there are basically two kind of formatting techniques that we generally use in strings. One is the dot format method, another is the if strings. We'll learn about it as we move towards the lab sessions. One more thing, when I keep saying the lab sessions, I generally refer to it as the practical applications inside the Jupyter notebook. All right. The next topic that we'll be learning would be the operations in string. There are broadly 12 operations that we'll be deep diving into. So you can have a look at what this would be. We'll be taking one by one and understanding each concept in detail. All right. So that's it. Let's move to the lab session itself. So we start with the basics of string. As I said, that strings use double quotes or single quotes to be written. So here S1 is a variable which contains the entire string. That is, this is a string. Now when we print S1, we get the same line, this is a string. The same thing has been written inside single quotes. That gives us the same string, this is a string. Therefore, we conclude that even if we use single or double quotes, we get the same output. Then why do we necessarily have both the types? Well, the answer is very simple. Let's say there is this particular string S3 where we have written Rams, let's say Rams. How do we write them? Rams ball. How do we write that? How do we put this apostrophe? In that case, it would consider Ram to be the string, and S ball would give us an error. This is the time when we use double strings. And we continue to write whatever it is. Then it takes the entire thing as a string. Also, we do have another way out for that. That is using the backslash, which is written quite like this. So if we do not want this apostrophe to be taken as the end of the string, what we do is take a backslash, give the apostrophe. In that case, it is called an escape character. But we do not necessarily need to use these things because we have a single and double quotation for our help. And let's use this purposely to mitigate our needs. Alright? Now, one more important thing that I mentioned, use of multi-line strings, that is triple quotes. So when we want to print, let's say, multi-line strings, like the one I have done here, this is a multi-line string, and the next line it should print, it is contained within the triple quotes. The entire thing needs to be encoded within triple quotes. And when I print S3, this is what I get. This is a multi-line string. It is contained within triple quotes. If we use this multi-line quotes, even gaps would maintain its originality. Let's say I give a tab space over here and now print it. I'll get the tab space over here as well. So whatever I want, how I want, I can do that using triple quotes. So that's the beauty of it. All right. Now coming to the formatting technique, it's often what happens is we give some variables, we assign some values to some variables, and we need to print them inside the print statement. And it's difficult for us to get the values, to understand what the values were. And in that cases, we use the format technique. So let's understand how we use it. Now what I've done over here is I've taken the name to be John, the age to be 23, and its height, his height, to be 175.5. Now, if I want to print that John's age is 23, or John is 23 years old, how do we do that? Let's understand step by step. I think till the knowledge that we have right now, if I ask you to print a statement saying John's age or John is 23 years old, how do you do that? We'll necessarily use print, then write the entire statement over here. John is 23 years old, right? And we get the output. But what if I want to create a loop? So we'll be learning about loops and everything in the next, along as we move forward. I cannot say in which lecture, but we're learning about that. So the entire thing is, if we want to print the same structure, the same blueprint, that let's say there are 100 people and they have 100 odd years or ages. So how do we do that? In that time, we cannot write 100 print lines, correct? It is not possible. 100 may still be possible. What if I'm talking about a country? Can I really write for India? India has a population of 1.3 billion. Can anyone really write 1.3 billion print lines? No, right? In that case, we'll be using a loop. The computer will help us to automate the entire structure. So what we'll be doing in that case is using the formatting technique. Now let's understand what we do over here. Instead of the name John, I create a variable. Let's say name. You can give whatever you like. And I've written that to be John. The age I give is 23. Now I know what kind of a line I want. What I do over here is print. This is the structure that you need to maintain for dot format method. A second bracket wherein John will come out. So John is 23 years old. Okay. Now what I need to do is, this has already been done in the print statement. Now let's once check. How does it behave? Right? So I want John over here and 23 over here. What I essentially do is use the dot format technique. I put a dot here, write format, this is a function, and write what I want in this bracket. So the first name will go. So I write over here name. And in the second gap, age should go. So I write age. Voila. We get John is 23 years old. You get that? In the same way here, what I have done is John's. So I've put the second bracket, apostrophe S, height is this, dot format, name and height. And therefore I get John's height is 175.5. So it's a beautiful technique to leverage the use of automation techniques and reduce the manual labor. Now, one much more easier technique to use these formatting methods is the f-string method. What you necessarily need to do here is, instead of writing all these things, what I could have done here over here is use the f-string. So how does it work? Instead of writing dot format, name, age, which might also get repeated, what I can do is I necessarily copy the variables. All right. Now what I do is print. After that, I just put F and the inverted comma and write within it whatever I want to do. So I want to write John's, or if I am creating a loop, I just want to enter the variable name. So name, which here would be John, is age, years old. Correct? For age, it would come as 23. Now let's see what actually happens. Voila, John is 23 years old. So you might want to use the dot format technique or the f-strings. Personally, I use the f-strings because it's much more user-friendly and it gives a proper visualization. So I can actually write name is age years old, and I get that here the name will come, here the age will come. And it kind of becomes easy for me. So yeah, that's what all about f-strings and the dot format method. One more important thing for f-strings is that we can even use the different functions inside the f-string. So the functional parts we'll learn in the next lecture. Just to show you how you can use it is, let's say John is written with J capital and OHN in small letters. If let's say you want to create all the letters in caps, what you can do over here is what I've done, name.upper. So this particular function .upper creates all of the letters in upper form. That's what has happened here. So by using f-strings, we can actually play along a lot. I'll be using f-strings a lot in this course. So practically you will grasp the use of f-strings by the end of this particular course. All right. One more important thing is the user input and print. Now, I have used the print statement a lot, but I have never used the input statement. So how does it occur? The input is the same as, we gave a variable. Here I have taken name as the variable, and then equal to. After that, we put this particular function called input. So what do we do? Take any variable for that instance. Let's say x. X is equal to input. Please enter your name. And now when I run it, it asks us to enter our name. So let's say I enter some random name. Let's say Harry Potter. That's all. Now you might be wondering what just happened. I just entered a name, nothing happened. Yes, nothing actually happened because I did not do anything with this particular variable. Now x is the variable that takes the input. And if I use x anywhere in the function, it can actually work for us. For example, let's say, okay, so before that, I need to let you know one more thing. When you put this particular function input, it converts whatever the value you enter as a string. So let's check it out. What is the type of x? It is a string. In order, if you want it to be a, let's say, integer, what you do is, again, I'll be taking x. X is equal to input. So please enter a number, right? Let's check it again once more. So let us put any number like 45. Let's again check what is the type of x. Obviously, it would be a string. Just writing something here does not necessarily change the type. So how do we do that? We typecast it. And how do we typecast? We put an int before, right? And a parenthesis. Now what happens? It asks for the same thing, please enter a number. I enter 45. And now, when I actually put the type, it says it is an integer. Now, what can I do with it? Okay. So let's say I want to add, let's say I just want to add 5 to it. So let's say, okay, let me take another variable, which is 5, and let me print x plus 5. This is a very niche problem that I'm holding. It has different uses, obviously. So it asks me to enter any number. I enter 45, or let's say I enter 9. And it gives the sum to be 9 plus 5, that is 14. All right. So here, what I've done is, I've taken a variable name in the form of string, obviously. It says enter your name. I've taken another variable, which is an integer, which says please enter your age. And the resultant would be, I've used a f string. My name is this, and I am this years old. So let me just run this particular code. Please enter your name. So let's say my name is Urbayan. So what I do over here is this. What is my age? So I am 26 years old. And voila. It says my name is Urbayan and I am 26 years old. I hope you get the test of what is string, the different formatting techniques in string, and how user input is taken and print is done. All right. I will be learning more about the different operations in string in the next lecture. Hello everyone. In this lecture, we'll learn about the different operations present in a string. All right. So as we have already learned that there are basically 12 operations in a string, in this particular lecture, we'll be deep diving into each and every one. So the first is accessing elements. The second is the finding elements. Third is slicing of elements. Then comes repetition counts. Here we'll be learning how to find the number of repetitions of a particular element given. Next, we have the case changes, the glimpse of which we got in the f strings itself. If you remember, dot upper. Then we'll be learning about the is method, dot is method. Then we'll be learning about starts and ends with function. We'll be learning about the replace function and an advanced form of it, that is make trans and translate. This is basically an advanced version. We'll be also learning about the partition and split methods and strip and join method. Both of them are opposite to each other. Strip basically partitions a string, while join joins the partitioned strings into one. With that said, let's understand one important thing about string. That is, let's say S is equal to hello. There is something called as indexing. And in general case, Python starts its indexing from 0. So if I write S of 0, I shall be getting H as the output. That means H here would be 0, E here would be 1, and so on and so forth. Also, let's say I just want to get 0. I would be writing S of how much? 1, 0, 1, 2, 3, 4, right? S of 4. ISO, which is also equals to S of minus 1. That would also give me a O. Now, how does it basically work? So, I can go across a string from left to right by 0, 1, 2, dot, 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 or from right to left by minus 1, minus 2, minus 3, dot, dot, dot. That's up to us. How do you want to go? Now, that said, let's check this particular example. So here, S has been given as hello world. So what should S of 0 give? Obviously, H. S of 1 would be E. And that's what has been given. S of 7, let's count it. 0, 1, 2, 3, 4, 5. Remember, a blank space is also given an index. 5, 6, and 7. So O would be the 7th element. All right. S of minus 1 would be D. That's what has been given. All right. Moving to the next operation, that is finding elements. Here we generally use two functions or methods, whatever you want to call it. The first is dot find method, and the second is the dot index method. So both finds the starting point of the required text. The only difference is that dot find returns minus 1 if the substring is missing, while index throws an exception error. Therefore, dot find is a better option to use. So let's take this particular example. Here, S is equal to hello world. Now, s.find or gives us 7. Same, s.index gives us, s.index of or gives us 7. But why? O is the 7th element, as we already got. S of 7 is O. You can count it over here as well. And R would subsequently be the 8th element. So why does OR gives me 7, not 8 or 7 and 8? because of this particular line. Both the methods finds the starting point of the required text. So the starting point of OR is O, and that's the index it's giving us. All right. Now there is a an extension of this find as well as index method, that is R find and R index. What does it do? So index or find, as we know, finds the leftmost part, right? So take, for example, okay, let me give you a good example. Here, S is equal to hello world, correct? Now tell me, what would be S dot find O? What should be the answer? Okay, before you answer, let me tell you, O exists here as well as here. What is your guess? Either it would be 0, 1, 2, 3, 4 or 7. What should be the answer? 4. And why not 7? Because both index and find starts scanning the string from left to right. And as soon as it finds the required element, it ends its search and gives us our result. And that's the reason we got 4 and not 7. Therefore, comes into existence something called as rfind, which finds the last match. All right. So had we given here rfind, it would have given us the 7th element. Same occurs for index. Okay. And had we removed the R, it would have given us 4. That's an example that has been mentioned over here. So s.find L would be giving us this particular value 0, 1, 2, and that's what it has given. And rfind gives us the last, that is 9th element. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9th element. Same for index, 2 and 9. Now we come to the part where we learn about slicing of elements. So slicing is basically returning a range of characters. So we know what is S. S is hello world. What is S of 0? It would be H. What is S of, let's say 10? That should be D. And what is S of -1? It should be D again. Now, what does slicing do? Slicing gives us a slice of that element. And how do we understand what do you want to take? So these are basically the operations that can be done in slicing. Let's understand again one by one. So when we give it a colon, we get the entire string, hello world. If you want to reverse it, okay, so let's learn from here and let's take the example. So S colon gives all the elements. S colon -1 prints the elements in reverse order. Let's check it. Yes, it does. If we read from right to left, it says hello world. Okay. 2 to 5. What does this do? 2 colon 5. It prints elements having indices 2, 3, and 4. That is of 2 to 5 prints all the elements 2, 3, and 4. Basically, it means S of first element that to be printed and last -1. Rather last +1. So if you want to print from the first to last, you should write first and last +1's index. Therefore, when it was written 2 to 5, the second, third, and fourth was printed, not the fifth. All right. Now, when we give 2, 5, 2, what does it mean? Yet this means it will print from 2 to 4, skipping each element. That is, instead of 2, 3, and 4, it would only print 2 and 4. -5 to -3. What does it mean? It would print all the elements from -5, -4, and nothing, because last -1, it would print one less. Is of -5 to all. So in this case, it would be printing all the elements from -5 to the end. That means not in a right to left direction, but from left to right direction. So what essentially it means is, if this particular string is taken from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, -5 to end means this is -1, -2, -3, -4, -5. So 5 is -5. -5 to end means it would print 5, 6, 7, 8, 9. Let's check it once. So that's what it prints, 5, 6, 7, 8, 9. Now, -5 colon colon -1. It means it would be printing in a reverse order. That is, from 5 to up to 0. Let's check it. That's what it does. All right. So hope you get an overall idea of what slicing is and how slicing is done. So basically, in short, what slicing does is, it has 3 parameters. Some element here, colon, some element here, colon, and some element here. This particularly indicates the first element to be printed. This indicates the last +1 element to be printed. The last element to be printed is the last one, and it indicates the +1th element. And this particular position over here indicates whether it would be in a reverse order or not. If it's -1, the print would be in a reverse order, that is right to left. If nothing is mentioned over here, the print would be normal, that is left to right. If nothing is mentioned over here, the print would be from the first position, the element mentioned over here, to the end. If nothing is mentioned in any of the blanks, that is S of colon, the entire string would be printed. Also, if you want to reverse a string, what you do is this. So nothing over here, and reverse it. I hope you get the point. This is for the first element, this is for the last +1 element, this is for to make it understand whether a reverse string would be printed or the string printed would be a normal one. All right. Now we move to the repetition counts. So what basically happens over here is, we use the function .count, which counts the number of occurrence of that particular letter. Here, what we have done is, we have taken the string s is equal to hello world, and we are printing count the number of occurrence of L. So we know that L occurs thrice, 1, 2, and 3. And that's what our answer is. Now we have taken another count function when we have found the count of LL together. This we know occurs only once, and therefore the answer is 1. This is the basic utility of the count function. Now we'll be moving to the case changes. So there are basically 5 kind of cases. The first is the upper one that makes all the letters capital letters. Next is the dot lower function, which converts all the letters to its lowercase alphabets. Then comes the capitalize function, which capitalizes the first letter. That is, for hello world, H would be capitalized. Then comes the title. What it does is it increases, it capitalizes the first letter of each word. So the difference between capitalize and title is that for title, only H here would be capital, rest would be small. For title, H and W both would be capital. So the first letter of each word is capital for title. Swap case is very simple. It swaps the cases. That is, upper to lower or lower to upper. Or if it was a title form, it would be just the reverse form. So let's understand that with this particular example. So S over here is given hello world. S dot upper converts it, the entire thing would be in capital case. S dot lower, everything would be converted to lowercase. S dot capitalize. So the first letter would be capital and rest all would be small. S dot title, H and W over here would be converted in capital and the rest would be small. Now S dot swap case. So here H and W were in capital. So this would be in small and the rest ELLO and ORLD would be in caps. That's what has happened. So this was all about case changes. Now we learn about the dot is method. This is an extremely important function and has many utility. After learning all the dot is methods, we'll be performing a short problem to enhance our expertise in the same. All right. So what I've done over here is I've taken 4 variables and 4 values corresponding to each variable. Note every of them are string. All right. So the first thing that we'll be doing is learning the first is method. That is alnum. What does alnum stands for? Alphabet plus numeric. That is, it should contain either an alphabet or a numeric, nothing else. So is a alnum? Yes, it contains letters, alphabets and numbers. So it is an alnum and that's what it says. Is B an alnum? Yes, it is, because there might be no numbers, but it falls under the category of alnum as well, because only alphabets. Is C an alnum? Again, yes, because it is all numbers, no alphabets, but still alnum is the superset over here. Is hello at the rate an alnum? No, because at the rate is a symbol, does not fall under alphabet or numerical. So that is given a false. All right. The next thing that we learn over here is alpha. So here it would contain only alphabet and nothing else. So is A an alphabet? No, because 5 is a numeric. Is B alphabet? Yes, because it's only alphabet. C is not, clearly false, and D is also not, because it also contains symbols. Is digit? It should only contain numbers and nothing else. So here we can see only C would be true and all else should be false. That's what it is. So alnum takes into account alphabets plus numeric. Is alpha takes into account only alphabets, and is digit takes into account only digits. Okay. So now, what's required for us to find is we are required to write a program to print the number of consonants, vowels, and numbers in a given string. Okay, so we'll come to this problem. I thought I can take this problem up now, but it involves some superior concepts. We'll be taking up this problem at a later stage of this course to enhance our learning. Only after we learn about loops and conditional statements and everything. But till now, we should understand all the functions that we have gone through. All right? Right. Now we come into being with starts and ends with function. These two are very simple. So I've taken the example as s is equal to hello world. The ends with function checks if this particular word is the ending word. So yes, it is correct. S ends with world, therefore true. Again, S ends with LD. That is also correct. Had we written S ends with D, that would also have been correct. Basically, what it actually means is you take any string, let's say X, Y, Z, and you write S ends with XYZ, that would be given a correct. S ends with YZ, that is also correct. S ends with Z, that is also correct. But if you write S ends with Y, that is incorrect. So let us try that. So let us say S ends with hello, which we know is incorrect. So it is given false. Similarly, S starts with hello is correct. S starts with HE is also correct. And S starts with hello world will also be correct. So I hope you get an overall idea what starts with and ends with actually does. It basically checks if the given text ends with this particular given text, or if it starts with this particular given text and gives us the result in a Boolean form. Next, we come across the replace function. So I've taken a string as hello, and I just want to replace the HE with YI. So instead of hello, I want the result as yellow. How do I do that? S.replace HE with YI. It takes two arguments into account. The first one is the one that needs to be replaced. So let me write it over here. So dot replace two arguments. The first one is the one to be replaced, and the second one is the one to be replaced with, or the replacing characters. So here HE is to be replaced and YI are the replacing characters. So S.replace HE with AI gives us yellow. All right. Now what if I want to replace two characters simultaneously? Let's say I want to replace E with O and L with X. What I write is S.replace E, O, and I extend it with dot replace L, X. So what happens is E has been replaced with O, HE, LL, O. So E over here has been replaced with O, and all the L has been replaced with X. LLXX. We can keep on extending it as further as we want. So let's say I also want to, let's say I want to replace, let's say H with K. I'm sorry, forgot to write the replace function. Okay, again I have done a mistake. The mistake is this particular parenthesis has to be put, the print parenthesis has to be put at the last. So now it's correct, if you understand. So we gotta extend it again and again. We can extend more if you want, but I hope you understand what's happening. All right. Now next we come into place with, okay, so if it was asked that please replace E with O with L, and L with X, that is hello should be HOXXL. I hope you understand. E is replaced with O, so HO, O with L. So this O over here should be L. So HOLLX. Okay, let me write it down so that you are not confused. So first it was hello, right? So after the first replacement, that is E with L, E is replaced with O. It gives me HOLLO. The next replacement is O with L. So O is replaced with L. It gives me HOLLL, right? Now, please understand, this O has not been replaced with L. Why? Because this is not what I want. I want E to be replaced with O. That's why E was replaced with O. And I want all the O's that was present from the commencement to be replaced with L. That's the reason I wanted this O to be replaced with L and not this one, because this is something that I have done after operation. Now I also want all the L to be replaced with X. So L to be replaced with X, not this L, right? This 2L only. So it should be, okay, let me write it over here. So it should be HOXXL, correct? So it should be HOXXL. What we are getting instead is H 4Xs. That is, what is happening over here is, from hello, for the first replacement, it's becoming HOLLO. With the second replacement, it is becoming HLLL. All right, because O is replaced to L. We did not wanted this to happen. We wanted the remaining O's to be converted to L. But here it converts all the O's to L. And for the last conversion, it is giving us all the L to X. H 4 times X. That's what has happened. So if our goal was to have this as the output, we could have easily used replace function. But if our goal is to find, as I have actually mentioned, what could I have done? We could have used another advanced form of replace, that is make trans and translate. All right. So what basically happens is, as I mentioned already, that output is H 4 times X instead of HOXXL. This is because each replace method operates individually from left to right and not simultaneously. Had this replace method occurred simultaneously, that is E to O, O to L, and L to X occurred simultaneously, then this problem would not have been faced anytime. But since it occurs one at each time, we are facing this particular problem. And to mend this, we use the make trans and translate method. So let's understand how we use it. So what I've written is is equal to hello. Now, I've taken a dictionary. Dictionary as in D equals to S dot make trans. So dot make trans is the function. And I've taken all those that I want to replace with all the replacing elements. So I want E, O, and L to be replaced by O, L, and X. That's why what I've done is EOL replaced by OLX. All right. Now what I've done is, just let me comment it out. It's not useful at this point. What I've done now is s.translate D. So always understand that make trans and translate are two pairs. If we use make trans, we need to use translate to get back the string. So I've written D equals to s.make trans, EOL to OLX. So all the E, O, and L would be replaced by O, L, and X respectively and simultaneously. And then I'm writing print s.translate D. And it's giving me HOXXL that I had actually wanted. The second method to use this make trans and translate is typically use a dictionary. Instead of EOL, OLX, what I could have done is D is equal to S dot make trans. Dictionary again is a data structure which we'll be learning in the course as we move forward. But as of now, just understand this is a key value pair storage. So here what happens, S dot make trans, E is changed to O is changed to L, and L is changed to X. And we do the same thing, that is print s.translate D, it gives us the same result. So if you want to use EOL, OLX, that does the trick. If you understand dictionary well, when we come to this particular data structure, you will be understanding it more clearly, and you might prefer to use dictionary as well. Again, both does the same thing. All right. Now, one important thing for make trans and translate is that the actual syntax for this particular pair is string.make trans, elements to be replaced, comma, replaced elements, comma, elements to be ignored. For example, here, D is equal to s.make trans, EOL, comma, OLX, that is E to be replaced with O to be replaced with L, and L with X, and ignore the element H. Now when we run this particular command, s.translate D, we get OXXL, that is H has been ignored. All right. All right. Now coming to the next operation, that is partition and split method. Again, both does kind of the same thing. There is a little bit of difference though. So partition splits the string based on the text, but also keeps the text. While split, splits the text based on the text and does not keep the text. So what essentially is the difference is that partition keeps the text, while split does not keep the text. So S is hello world, s.partition E. What it would do is, it would partition the entire string based on the E part. All right. So H, after that, let's scan the text as the computer would do from left to right. H, E is found? No. E, yes, E is found. So what we would do is, it would write H, and then E, then again continue with its search. L, L, O, no E is found. Then gap, no E is found. W, O, R, L, D, nothing is found. So it would again take another string in which it would write L, L, O, gap, and fold. This is how partition works. Then how does split works? Split does the same thing. It checks H, E is not there. E, yes, it is there. So it writes H over here. And as I said, does not keep the text. So it would not keep E. And then what it would do is check again L, L, O, W, O, R, L, T. Nothing is found. So it would actually take this particular string into account. And that's what it does. Okay, I hope you understand. Now, for string, for split, the max number of elements to be splitted can be mentioned. So let's say we want to split S, that is hello world, with respect to L. There is basically 3 L's. So there should be 3 splits. More than that because, there should be 3 splits, right? So one is H, E, correct? Then there should be nothing because between L and L, there is nothing. So nothing. After that, an O and gap and WOR. That should be 1. After that, L and then D. So D. What we can also do is s.split L, 1. That is, we want only one split. So whenever it encounters the first L, it splits, and after that, it does not split anymore. That's what I have done. S.split L, 1. So what it does is HE, and for this L, it has split and has not split anymore. So LO and fold. That's how it does. And again, like find and index, it can have R split, that is splitting from the right side. Since I've written s.rsplit L, 1, the rightmost side, that is the L for world, would be split, and there would be 2 splitted elements, the hello world and D. Again, same works for partition. There is something called as R partition, which partitions from the right side itself. So that is all about split and partition. Now, there comes something called as strip. So what is strip? Strip removes the mentioned elements from the beginning and the end of the string. So here, X is equal to exclamation mark 3 times, hello world, and exclamation mark 4 times, if I'm not mistaken, yes. Hello world, and then again 4 times exclamation mark. Now when I write print X, the same thing is printed. When I write X.strip exclamation mark, all the exclamation marks get splitted. So only hello world comes into being. Now, when I write X.rstrip, then all the exclamation marks present in the right hand side would get split. So that's what happens. The left side exclamation marks remains and there is no exclamation mark to the right of hello world. And when I write X.lstrip exclamation mark, the leftmost exclamation marks gets stripped away. Now, the strip function takes an argument. That is the element that needs to be stripped. If nothing is passed inside, it would split any white space if present. So here, X is hello world with some white space, both on left and right. When I write X.strip, all the white space is stripped away. Similarly, rstrip would strip away all the exclamation mark, all the white space to the right, and x.lstrip would strip away all the the white space to the left. So that's what a strip function does. Now let's come to one of the most important operation, that is join. What join does is, join is basically the opposite of split. So it is used to concatenate the number of strings with a given element. So let's say I want to join Python with a white space. I write print white space dot join Python. What happens is, after every element, a white space has been used. Had I written underscore dot join Python, instead of white space, an underscore had been printed. Similarly, we could have used any other character instead. Now, again, list is something that we will learn in the chapter of data structures. Just to give you a brief, what we can do is, this is a list, and I can join this list with this particular hyphen. A.join list1 would basically convert the list like this. And if I use a dot instead, it would, introduce this dot before all the elements. Now, how do I see that split and join are exactly opposite in nature? So let's say there is a statement. Okay, let me make you understand it pretty well. So let's say there is a string s equals to this. This will split all the words in a list. All right. So when I print s, I'll get this will split all the words in a list. When I split it actually in a list, this is what I get. All the string. So split occurs with respect to white space over here because nothing has been mentioned. Had I mentioned any character, let's say S, then split would have been done differently. But since nothing has been mentioned, so it splits all the white characters. So this will split all words in a list, are all different elements. All right. Now, if I want to join it again, so let's say S1 is equal to S.split. So S1 is basically this. Now let's say I want to join it again. So what I do is I join the white space of this particular list. And I soon get this particular string again back, which is basically nothing but the string S. So S can be splitted by the function split, and that splitted function can be joined by the join function again. That's how split and join work. Both are exactly opposite in nature. And we would be using this tremendously in this data science course altogether. All right. So that's all for today, guys. Hope to see you in the next lecture. Hi, everyone. In this lecture, we'll be learning about conditional statements in Python. So what are conditional statements to begin with? Well, let us think in this way. Let's say we design a remote-controlled, self-driven car, right? Which has only one functionality, that it keeps on moving through any direction that it has. It might take all the turns and bends depending on the obstacles provided. So let's say we have this kind of a road ahead. So this is our start point, right? And let's say this is the end point. Now, the car has to travel all the way from start to the end. How does it do so? Let's say these are the obstacles present, this letters, this arrow and stuff. So obviously it cannot move just forward. It has to take a right turn over here and go through this path, then probably take another turn and move up to here, right? So how do we design this particular thing? A very simple command, we can give a condition that if you find any blockade ahead, please take the immediate right turn. And therefore, the car, when it finds the blockade, it would take the right turn and it would move so. Now, this is the very basic of a conditional statement. Now, it might so be that the car should not, when it moves forward, it finds a blockade in the front. So I tell, if you find a blockade in the front, please take a right turn. What if the right is also blocked? Then I'll write another condition on top of the previous given condition that if your right turn is also blocked, please find the left turn. And it will find another path and so on, move to the end position. What if the left is also blocked? Then I might say that I might give 2-3 conditions and then write a last statement saying else, that is, if none of the conditions above satisfies, please stop where you are because there is no point to go. So do you understand the point? Now let's look at the syntax and let's try to rebuild this particular game. All right. So in Python, the system fully depends on indentation, and which is essentially white spaces at the very beginning of the line. Unlike the curly braces that you find in other programming languages, Python doesn't have any curly braces. So in Python, conditional statements may be of the following 3 types: if and else, or it can be only if also satisfies. Normally we put an else followed by if, so that if this particular condition is not satisfied, we go to the else part. There might another way called nested if, wherein there would be if given a condition, followed by another if, followed by another condition, and so on. And there is also nested elif. If else in Python is written as elif. So we'll see all of them as we move to the lab session. All right. Now, an if statement in Python is written using the if keyword. Elif is an abbreviation for else. That is, if the if condition is not satisfied, we can give another condition by writing simply the keyword elif. Else, this is the last keyword that we would want to use if none of the conditions above is satisfied. All right. Now let's move to the lab session. All right. So let's look at this very particular problem. It says x equals to 40. So we have assigned a variable x containing the value 40. Now if x is greater than 10, this is the if keyword followed by the condition, right? So essentially, let me grab the pen. So essentially, this is our keyword. This right here is our keyword. And this particular thing is the condition. So if x greater than 10 followed by a colon, we give some indentation, which in Jupyter Notebook, if you press enter, it automatically takes the particular indentation. Print greater than 10. Else print less than 10. So now since x is 40, which is greater than 10, we get the print to be greater than 10. All right. Now the same thing can be written in a broader sense by using nested if. So here what I have done is, I've taken x to be 40 as it is. Then I've taken an if statement as was shown in the previous program. So if x greater than 10, print greater than 10. If x greater than 20, note that this if is not another condition given. This is a nested if, that is if under if. So first the program will try to understand if x is greater than 10 or not. And if this condition satisfies, this would be printed. Then it would move to the next condition. So if x greater than 20, print greater than 20. Again, if this satisfies, this would be printed. After that, it would come to this particular condition over here. That is, if x is greater than 30, print greater than 30. Else, print less than 10. So now, let's understand through the program. It was said that x equals to 40. So what happened? If x greater than 10, yes, x is greater than 10. So 10 has been printed over here. Then it comes to the next particular condition, which says if x is greater than 20, yes, x is 40, which is greater than 20. Therefore, print greater than 20. That is also printed. Then it comes to the next condition, that is if x is greater than 30, then print greater than 30. That has been printed as well. Now it says else, that is if none of this condition above, rather if this particular condition over here was not satisfied, then it would print x is less than 10. So we know that x is 40, it is greater than 10, 20 and 30. What if I wanted to change the code? Let's say, what if I give a condition over here as if x is greater than 10, print greater than 10. And the else condition, let's say, what if I write over here, if x is less than 20, print lesser than 20. Now tell me one thing. Is x greater than 10? Yes. So it should print greater than 10. Is x now less than 20? No. X is greater than 20. Therefore, the condition would end over here because x is no longer lesser than 20. Now for the next condition given, that x is greater than 30, which although is true, would not be printed because once the pointer comes over here and finds this particular condition to be false, it ends. It cannot really go to the next line. So let's see what happens. Yes, as expected, it gives me x is greater than 10. Now what if I wanted to print if x is greater than 30, print greater than 30. So in that case, I shouldn't have used a nested if. I should have used an elif instead. So elif x greater than 30, print greater than 30. So now it has still not printed. Can you tell me why? Because in conditions, elif is only accessed once this if condition. So what I'm trying to say over here is, the first priority is given to if, followed by elif. If none of the two satisfies, then the pointer moves to else. Now, since over here, x greater than 10 has been already satisfied, right? It does not really move to elif position. It might go until the chain of the ifs, that is the nested ifs. But it won't ever come to the elif position or the else position. Now to come to the elif position, this if condition should not be satisfied. So let me do that as well. So let's say if x is less than 10, which is not true because x is greater than 10. So in that case, we get the print to be greater than 30 because this if condition has been falsified. Therefore, it directly moves to the elif condition where it says if x is greater than 30, which in a way is true, and therefore it prints greater than 30. Now, what if I wanted to access the else position? What I need to do is I need to put a false comment over here as well. Now, let's see, it says less than 10. Now, it is technically wrong. X is not less than 10. But since the program has been designed such a way that if condition has not been satisfied, neither has the elif condition been satisfied. Therefore, it moves to the else condition, which is less than 10. And that's what being printed. So I hope you understand how the conditional statements work. Now let's look to the next program. Here it says that if x equals to 40, x equals to 40. I have assigned x to be 40. If x greater than 10, print greater than 10. Elif x greater than 20, print greater than 20. Elif x greater than 30, print greater than 30. Else print less than 10. So any guesses what would be printed? Obviously, the first line would be printed. That is, x is greater than 10. Because once the if condition has been accessed, I mean, it's true, it finds the if condition to be true, it doesn't go to the elif or the else conditions. And it prints the first condition, that is greater than 10. So I hope this particular topic is clear to you guys. Now let's understand the first problem that I was sharing at the very beginning. So what if I wanted to design a car that moves from the start position to the end position? So for the very basic program, I would write move from start to end. I'm just saying the pseudo program. Right? This would be the very easy thing to do. Now what if we find a blockade? This is a blockade. What I would say is, please move from start to end. Then I'll give a condition if you find any blockade ahead. Maybe take a right turn. So now what it would do is, it moves till the blockade, then takes a right turn, take a right turn and continue. And then it continues to the end part. What if there is a blockade in the right as well? Now, if initially there was a blockade at the right as well, so what I'm trying to say is from start to end, here it comes across this block, And what if there was a block at the right turn as well? So it cannot take the right turn. So in that case, what I'll also include is, it would be a nested if, saying if blockade towards right then take left and continue. So it moves forward, finds a blockade on the forward or towards the front, tries to move to the right, where it also finds a blockade, and then it moves to the nested if condition. So it finds a blockade to the right, it takes a left, and then moves to the end. What if there was a blockade at the left as well? I guess then nothing was to be done. I would probably include another nested if, saying if blockade towards your left as well, then stop or return back. So that could be done. Now, coming to this particular case, if when we move forward, there is some space to move towards the right, it moves to the right, and then let's say it finds a block. Then what would we do? Here we'll be using an elif statement. So if blockade ahead, take a right and continue. Or rather, we can also use an if statement. Everything works over here. So if blockade towards your right, or you know what, even we do not need this particular statement over here. Since the car was moving forward, it found a blockade towards its front, it takes a right, and now this direction becomes its front. And now it finds a block towards its front. Therefore, what it would do is, it would take another right, which is this direction. Suppose after going for some time, it finds a block over here as well. This would be its front. It would take a right turn. And this would be continued. So this is the magic of conditional statements, which is pretty much the basic for creating games or an automated program. With the introduction of loops, you would understand how loops and conditional statements together help in creating the entire program. So that's all for today, guys. Hope to see you in the next one. Hi everyone. In this lecture, we'll be learning about loops in Python. So generally, there are two types of loops in Python. The first one is the for loop, and the next one is the while loop. So we'll be learning the two loops in detail. Along with this, there are two more concepts we learned. That is the break statement and the continue statement. So whenever we find the break statement in a loop, what it does is, it breaks the sequence once the condition is met. So therefore, once it is inside the loop and we encounter the break statement, obviously after the condition has been met, the loop breaks down to the outside of the loop. Same for while loop. What continue does is, it skips the element where the condition is made. So let's say if a condition is met and we encounter the continue statement, that is Python encounters the continue statement, it skips that particular code, that particular element, and then again start reiterating. All right, let us check all of them in the practical session. So here we will be seeing both the for loop and while loop. So I've taken a list. This is basically a list again, For now, think of it as a collection of city names. City equals to Delhi, Mumbai, Kolkata, Bangalore, and Chennai. For I in city, that's how we create a loop. For a for loop is written as for a key, an element. This is basically a pointer that points to the entirety of the storage element. For I in and the name of the storage element. Here it is city. So for I in city, print I. And that is how it prints. It prints all the name of the element. Delhi, Mumbai, Kolkata, Bangalore, and Chennai. Another way how we could have printed it is for I in range len of city, print city of I. What it essentially does is, let me explain you. So range is basically the range. Okay. Let me make you understand. What is len of city? It gives me the length of how many elements are there. How many elements are there? 1, 2, 3, 4, and 5. So len of city will give me 5. Okay. This is giving me error because I have not actually run the cell above. Now, len of city gives me 5. Now, what it does is for I in range len of city. So len of city is basically 5. We already saw. We could also write 5 for I in range 5. We give a colon and then print I. What would it do? It prints 0, 1, 2, 3, 4. Same thing would it print when I write len of city. Alright, because len of city is 5. And now what I'm doing is I'm printing city of I. This is how we access the element. So before writing this, let me show you how do we access city of 0. This is basically accessing, as I said while learning strings, that the first index is 0, then 1, 2, 3, etc. It is same throughout any data structure in Python. Since this is a list, Delhi is index 0, Mumbai 1, Kolkata 2, likewise. City of 0 will give us Delhi. City of 1 will give us Mumbai. City of 2 will give us Kolkata. City of -1 will give us Chennai. Okay, like that. So in this particular thing, I'm writing city of I. And I is in the range of I is once 0, then 1, then 2, 3, and 4. So that's how you would see it. Okay, let me show you in a better way. So I when 0, it's printing city of I, that is city of 0, as Delhi. I when 1, it's printing city of 1 is Mumbai. I when 2, it's Kolkata. I when 3, it's Bangalore. I when 4, it's Chennai. And that's how it prints. Alright. So I hope you get a fair about idea how it basically works. Right? Now, what we will be doing is, so this was the basic editor that I had actually mentioned. And instead of this, we could have also, written in a very simple way for I in city, print I. In that case, it would print all of them one by one. Now there is another concept of nested loops, nested for loop. What happens here is I've taken two lists, num and alpha. Num equals to 1 and 2, alpha is equal to a and b. Now for I in num, for j in alpha, print I comma j. How does it happen? Let me explain. For I in num, that is 1 for the first iteration. For j in alpha, that is a, print I comma j. So for j in alpha, the first thing was a, 1a. It has printed. One iteration has been completed. Then the next iteration, it would complete for j again, because j has not been finished. Until it completes this particular loop, it cannot go back to the former one. Therefore, after 1a, it would print j in alpha would become b, and 1 remains the same to 1b. After that, since j has been completed, that is alpha has been exhausted, it goes back to the former loop for I in num, and 1 has also been done. Now it prints 2. Similar way to a, and here b to b. Alright, this is how a nested loop works. Now a while loop is quite simple, quite similar to for loop. The only difference is in the way it operates and obviously the syntax. What I've done here is a equals to 1, while a less than 4, print a. Now, had I not put a limiting statement, it would have gone on and on printing a, since a is always less than 4. But what I have done instead is, after each print, a is increased by 1. A is equal to a plus 1. If you remember, a plus equals to 1 means a equals to a plus 1. What happens? After each iteration, a is increased by 1, and at a particular time, first it prints 1 when a equals to 1. Next, a becomes 2. Again, it satisfies the condition and 2 is printed. Again, a is increased to 3. Again, a is less than 4. It prints 3. And now, a is increased by 1 to a to 4. At this particular point, a less than 4 does not satisfy, because 4 is not less than 4. Therefore, the loop ceases to exist, and 1, 2, 3 is what we get. Alright. Now we move to the break versus continue statement. Here, as I said, breaks the sequence when the condition is met. For I in range 5, that is 1, 2, 3, 4 will be printed. If, okay, let's see what happens. So for I in range 5, print I. Alright. So 0, 1, 2, 3, 4 is printed. But what I have included here is I equal to 3. If I is 3, break, print I. Whenever it encounters this particular I value, statement breaks and it moves out of the loop. Therefore, 3 is not printed and nothing after 3. Therefore, what we get is 0, 1, 2. And after that, it breaks. If I want to take you to step by step, at first it would be 0, then it would be 1, then it would be 2, then it would be 3. And while it's 3, if I equal to 3, the condition met, break. The loop ceases to exist, and that's the entire thing you get as a printout, 0, 1, 2. Now, what does continue do? Continue skips the element where condition is met. The same thing, 0, 1, 2, 3, 4 should have been printed, but here instead of break, I use the word continue. What happens is 3 has not been printed and everything else has been printed. So what happens? First it prints 0, then 1, then 2, then it is 3. If I equal to 3, yes, the condition is satisfied, continue. Continue means it again goes to the loop. And the print statement is invalid for that particular step. Again, if I equal to 3, now I is 4 and it is invalidated and print I, that is 4 is printed. Except 3, all have been printed. That's what continue does. And that's the essential difference between break and continue. Now the concept of range. I've already given you a brief idea what range does over here. Now let's understand the exact things that are there in a range. The range has 3 attributes: start, stop, and gap. For I in range 2 to 10, let's understand. What we can do is for I in range, let's say 5, we'll get, print I. What we'll get is 0, 1, 2, 3, 4, n minus 1. It means start from 0 and end till the given number, or n minus 1, whatever it is. Then you can also, if only one attribute is given, it considered it to be the stop element. If you give 2 elements, 2 attributes, it considers the first to be the start element and the next to be the stop element. Let's say I want to start it from 2 to 5. It would give me 2, 3, and 4. And if you give all the 3 attributes, then the third attribute would be considered as the gap attribute. So let me take 2 to be the gap attribute. That is, it prints every alternate element. That's what's happened. 2 and 4 is printed. What if I give 2 to 10 and 3? Therefore 2, then 5, and then 8 is printed. That is the basic understanding of the concept of range. So I hope this loop concept, including break and continue statement and range, is clear to you all. I hope to see you in the next lecture. Bye-bye. Hi everyone. In this lecture, we'll be learning about data structures in Python. Alright. So in Python, we have 4 basic data structures: list, tuples, or tuple, whatever you want to call, set, and dictionary. Now, lists are nothing but a collection of objects that are decided or that are represented inside a third bracket. Lists provide us with a lot of manipulation operations and techniques. The most important thing in list is that it is mutable. That is, elements inside a list can be changed. Much similar to lists are tuples, which are represented by first bracket, and every operations that are performed in lists can be performed in tuples as well. However, the basic difference between list and tuple is that unlike the changing operations, that is, first we need to know that tuple is non-mutable. In simple words, it cannot be changed. So any data entered inside a tuple, let's say 1, 2, 3, remains as it is. In list, let's assume that 1, 2, 3 are the data that are taken inside a list. Now, let's say going forward, you want to change 3, or rather replace 3 with 4. So the new list now would become 1, 2, and 4. This can be done. using list. However, this is not true for tuples. So essentially, tuples are collections wherein all kind of manipulations can be done, but no change in data, no addition or no subtraction in data can be done. Lists are like tuples, wherein all operations of tuples can be done, plus addition, subtraction of elements can also be done in lists. We'll be learning more as we move forward. Now, sets are nothing but mutable as well as unindexed. We'll learn all these terminologies as we move forward. And one most important thing in sets is that it cannot have repetition of numbers. So a tuple a list might have 1, 2, 3, 3. So can a tuple. But for set, if you enter 1, 2, 3, 3, the output would only be 1, 2, 3 because it cannot take any repeated values. What are dictionaries? Dictionaries are nothing just like sets, but they have a key pair value. So this is the correct representation of a dictionary. We have a key and we have a value. The value can be called through the key. So here as we see 1:2, 2:3. Now when we call a of 1, we'll get the value. That is 2. The value of 1 is 2. And the value of 2 stored here is 3. So if we call a of 2, we get 3. Now we'll understand everything. This is the very basic thing that I have really told. Let's move forward and understand what are those things. Okay. So what are lists? List is a collection of ordered and mutable items. As I said, these are ordered items and mutable, that is changeable. We'll be also seeing examples as we move to the lab sessions. Now, elements inside a list can be of the same or of different types. That is, a list can have all numericals, maybe some float values, as well as some string values. A list can have everything, a combination of everything. There is no problem. Duplicate members are also allowed. So as I said, you can have duplicate members. There is no problem. And the most important thing, lists are included within the third bracket. All right. Now let's move to tuple. What are tuples? Seen, tuples are ordered. However, they are non-mutable. That is, they cannot be changed. Elements can be of the same and different types, same as list. Duplicate members are allowed, and they are included within the first bracket. So the only two major difference that can be observed between list and tuple is that tuples are non-mutable while lists are mutable, and these are included in first bracket while lists are included within third bracket. So I hope this basic difference is clear by now. Now let's actually move forward and look at the entirety of differences between lists and tuples. All right. So the first difference, as I said, mutability. Lists are mutable while tuples are immutable. Next comes the iteration process. Iteration means simply going in a loop or using loops. That's per se. So the basic thing you can understand when I say iteration is including a loop inside this list or tuple. So iteration in list is slower, while that in tuples are faster. Now the basic difference here is due to manifold reasons. Let's just understand the point here. If we go deep dive into the data structures part, we'll understand how lists are created and tuples are created. And then is when we'll understand why lists are slower. You can also understand this particular point in this way, that since lists offer additional functionalities as well as addition and removal of elements, therefore, they need to be created in a very different way, and that is why they are slower. Now, for coming to the next part, that is memory consumption, lists do consume more memory. That is because of the same reason here. It has more functionalities and are created in a very different way. Tuples, on the contrary, consumes less memory. Now, the major use of list is for insertion and deletion operations. But for tuples, now also note that list can also be used for various accessing operations and other manipulation operations as well. But mainly we use them for insertion and deletion because comparatively they are slower and consumes much more memory. While tuples, on the contrary, are read-only. We use them for read-only operations and accessing elements and manipulation techniques, etc. Now, as we will be understanding about lists and tuples when we deep dive into this particular topics, we'll understand that lists provide many, and I mean many more inbuilt methods compared to tuples. All right. Now let's also take a quick overview of what sets and dictionaries are. And then we can actually move to the lab session. Okay, so sets are collection of unordered. Here, this is important. Both list and tuples were ordered. However, set is unordered and mutable. It is also unindexed. That is, so indexing, as we know from strings, let's say this is a string called hello, and let's it be included inside the variable s. So when we say s of 0, what do we get? We have already learned it, we get h. Why? Because the index of h is 0, here it's 1, 2, 3, 4, and so on. Same with list and tuples, we can access elements by indexing. However, for sets, these elements included inside a bracket are unindexed. So if this is a set and we write s of 0, let's say, we straight away get some error because Python doesn't really understand what you mean when you ask for the indexing or you want to access any elements from set. Elements can be of same or different types. Duplicate members are not allowed. And these are included within the second bracket. So all are these parts of set. Now what are dictionary then? As I said, dictionary are key pair values. Here we get the key and here we take the value. So these are a collection of unordered and mutable items. These are indexed, not unindexed. We can access any value by writing T of the key. Elements can be of same or different types, and duplicate members are not allowed. That is, elements with same key value pairs can never exist, and they are included within second brackets. However, the essential difference between set and dictionary is that set contains list of elements separated with comma, while dictionaries have a key pair value separated with comma. That's the entire difference. Now we have several operations. A total of 14 are important that I have noted down. For list, we'll be understanding them one by one, everything. Okay, let's just understand the basics so that we can also understand what tuples provide and don't. So lists allow us to access items. Looping through lists, is also possible. They allow us to append items, insert items. Okay, so what is the difference between append and insert? Append means appending any item at the last. So let's say there is a list 1, 2, 3, and I want to insert another item at the last. So what I do, I use this append function, which we'll be learning how do we use it in the lab session itself. Let's understand what it does. Let's say we append 4 here. So the list becomes 1, 2, 3, and 4. What if we wanted to insert 2.5 in between 2 and 3? Then we should have used this insert operation and specify the position. And in that case, we could have taken 2.5 within 2 and 3. So append and insert are same. However, insert has some extra functionalities. That's the entire difference. Now, what is extend? Extend is when we have two lists and we want to incorporate them into one by appending it in the first one. So by an example, let me take an example. Let's say there was a list called 1 and 2. There was another list called containing 3 and 4. And if I appended this here, I would have got 1, 2, and the third element would be 3 and 4. So that would give me a list inside a list. However, had we used the extend operation, we would have got 1, 2, 3, and 4. So this is the basic difference between extend and append. Concatenation is nothing but addition of two lists. You can understand, same as that we have learned in string. Addition, when I say addition, I mean it kind of operates like 1, 2, 3, and 4. So that's what concatenation is. Now, copy of a list. We'll learn many things about this particular operation. Copy of a list. How can we copy a list? Much more about that when we deep dive into it in the lab session. Sorting of a list. So a list also contains inbuilt sorting operations. We also learn about operations like replace, remove, pop. So replace and remove are used to replace any elements. Both have their own different methods and usage. We'll understand everything. Same as pop. Pop is just used to pop any item. delete is used to delete the entire list, and clear is used to clear the list so that list becomes blank again. Also, list can perform many mathematical operations, which we'll be understanding everything in detail. Now, tuples cannot perform some operations due to its immutability that lists can. What are those? Append, insert, and extend. These are things that tuples cannot. They cannot also perform remove, pop, delete, or clear operations, unlike lists. Again, replacing any elements. This cannot be performed by a tuple. Also, tuple cannot perform any sorting operations. Other than that, accessing an item, looping through tuples, concatenation of tuples, copy of a tuple, and different mathematical operations. All this can be easily performed using a tuple. Now, dictionaries. So dictionaries and sets have their own operations, and I really do not want to go into detail now. We'll be seeing everything in the lab session. One important thing that I wanted you all to know, set has this incredible operations which people belonging from any mathematical background would understand. That is performing union, intersection, difference, and every set operations that we can perform can be performed in Python itself using sets. All right. Now let's move to the lab session and understand the basics of data structures. Okay, so we've already learned what data structure is, all the 4 data structures that we need to know to go forward with our course. Now let's understand what we necessarily do. So starting with list, how do we create a list? So there are essentially 2 methods of creating a list. The third one is just an extension of the second method. So the first thing that we do, I'll perform intuitively while we write. So the first thing that we can do is we declare a variable. Let's say I declare li, and we put the third bracket into place. And then we can write any elements that we want to include. So what I've done here is I've included a string, an integer, and again a string. Right? So this is a string, this is an integer, this is again a string. And when I print li, I get this as my output. I can also create a list by simply writing li or any variable that's for you to decide, and writing list of, and then give my variables. So what I've done here is li equals to list of 1, 2, and 4. So what it would do now is it would take 1, 2, 4 and convert it to list. This was a string earlier, and now it will be converted to a list with each element as string. And since it's a list, it will be enclosed within the third brackets. And that's what has happened over here. The same thing can be done using a loop. So what I've done is I needed to take all the elements from 0 to 9. So that's what I've done. List of I for I in range 10. So we have already done loops. So what does this do? I for I in range. That is, in simple words, it's for I in range 10, that is from 0 to 9, print I. That's what it has done. And therefore, it has taken all the values from 0 to 9. Now, tuples. Tuple can be created by the same method. I've taken t to be the variable. And as list, I have done the same thing, only taking first bracket. And the same thing I've got as an output. Again, it can be created by writing the function tuple instead of list. So that's the same thing it has done as it has done to list. And again, this is the third method wherein I have used a loop to include all numbers from 0 to 9. So I hope you understand everything. Now coming to sets. What does set do here? So set can be created in the same method as tuple and list, but this time using second brackets. It can also be created by the function set. And this is again the same, using a loop. Now for dictionary, creating a dictionary is a different process, but it's again very easy. What we do is, like I've done, I've taken the variable name equals to key value, comma, key value. So that's what we do. Now, note that this is the first key and this is the first value linked to it. This is the second key, this is the second value linked to it. This is the third key and third value linked to it. Now let's say we want to access Ford. What do? D of brand. It gives me Ford. When we write D of 2, it gives me Mustang, this particular thing. So this is how it works. So let me check it. Does it really work that way? Let us check. So let's say D of 2, right? So it should give me Mustang, right? 2 Mustang. Yes, it does give me Mustang. Let's see D of brand. What does this give me? This gives me an error. Why? Because 2 was an integer and I had given an integer symbol. However, here brand was a string. So we need to give it as a string. And then only we get the value Ford. Same with this, when we take year, we will get getting 1964. So that's pretty much how dictionaries work. It has immense utility and we'll understand again everything. Now there are some important things to note. Creating empty list. Simple. Li equals to, just give a third bracket, leave it, an empty list has been created. Why we are learning that? We will be using every single thing. So right now, just learn the process. We'll be understanding how and when do we need it. Again, a list can also be created by this simple function by the function list and leaving it empty. Same for tuples. However, do note, for set, you have to use this particular function. Otherwise, if you just use your second bracket, let's say s equals to second bracket, a set won't be created. We can also check this out. Let's say we want to check it out. Okay. So let's say li equals to this. And let's say I just want to know if a list, blank list has been created or not. So type of li, it is a list. Let's say I just wanted to create a tuple. The name of variable it doesn't really depend. So yeah, now it would be a tuple. What if I give the second brackets? So one must have expected we get a set. But disappointing much to our disappointment, we get this to be a dictionary. So when we give second brackets, a dictionary is basically formed. If we want to create a set explicitly, we have to give set function, and only then a set can be created. However, do note, I can create a set by this method. Just give second bracket, and let's say I put 1 and 2. In that case, it would be giving me a set. Why? Because a dictionary is only key value pair. Only once I had given a key value pair, then it could have understood it's a dictionary. Also, then why did it take a blank second bracket to be dictionary in the first case? This is because when nothing is given, it doesn't really understand. Is it a set or dictionary? And the most important data structure that has been marked here is dictionary by usage, by the default, and that's the reason we get dictionary. So explicitly, if you want to create a set, write the function set. S is equal to set blank. This is what you do. S or li equals to whatever you want, and a blank set would be created. So I hope you get a basic understanding of data structures. We will be deep diving into each and every data structures, all these 4, as we go, so that you get a clear understanding of all the functionalities and operations of them. So that's it for this particular lesson. We'll be seeing you in the next subsequent lessons. Hi everyone. In this lecture, we will be understanding everything about lists. All right. So as we knew how to create a list, there are basically 2 ways. One is you use the list function, and the other is you just put a third bracket and start writing or incorporating all the elements inside it. I prefer the second method. You can prefer whatever you want. Both are exactly the same. All right. So the different operations, as I had already mentioned, that can be performed using lists are: one is accessing all the items that we have also seen in strings, looping through lists, appending and inserting, as well as extending the list, concatenation, copy of a list, sorting of the list as well. We'll also be understanding about replacing any values, that is elements, let's say 2 and 3. So let's say we want to replace 2 with, let's say 4. So we can do that as well. Removing any items from lists, popping out any elements from a list, deleting the entire list or any items inside the list, clearing the list. So again, the basic difference between clear and delete remains, that delete deletes an item, while clear clears the list. The list still remains. We'll be understanding with when we go ahead. And also we can perform some mathematical operations in a list. Right. That said, let's start. Now, what we see is that what we see is that accessing the items start with the first process. Here we see that. All right. Let me take this list to be the basic formation. What I've seen here, I have taken a list li containing apple, banana, mango, and the number or integer 2. All right. Now, the first item is very similar to what we have learned in strings. The first item, so li equals to apple and whatever it is, apple, mango, and everything. Okay, let me take it as well. Yeah. So this was what the list is, and let me put it over here. When we want to extract the first element, this was the 0th element, this is the first element. So when I want to extract the first element, we write li of 1. And what do we get? We get banana. As I said, this is the first element. Same way as what we do in strings, the elements can be taken in a backward position as well. So when I say li of -1, I should get 2. That's what I got. I can also take li of -2 and we'll get mango in that case. So entirely the same way as strings work. Now again, like strings, we can also have the entire list taken. When I put this colon, and when I want to reverse a string, the simple thing that we do is double colon and -1. So the entire concept that we have learned in strings for accessing any elements or items is as similar to that for list. So I hope this is quite clear to you. So let us move to the next operation and let me clear it out. Yeah. Now coming to looping through a list. So that is very simple. As we have already learned about loops, so the same thing can also be done inside a list. So for I in li was the list containing the entire, this was the list, li. So when I do for I in li, print I, all the elements one by one would be printed. Apple, banana, mango, and 2. And that's exactly what has happened. Another way of doing the same is, as I've already mentioned in loops, the concept of range. So for I in range, len of li. Now len is a function which gives me the length of the list. All right. So let's understand. My list is this, right? Apple, banana, mango, and 2. What is the length of the list? How many elements are there? 1, 2, 3, and 4. So let's check it out. Len of li. It gives me 4. So exactly that is what happening over here. For I in range, len of li. That is, we can replace len of li here with 4. So for I in range 4, print. Okay, let's check it. So for I in range 4, print I. What should you have got? You should have got 0, 1, 2, and 3, correct? Let's check it. So I exactly get 0, 1, 2, and 3. Now, I put this particular thing into use, li of 1, li of 2. So what I do over here is, instead of printing I, what I do, I print li of I. That is, each time I is increasing, li of I, it is accessing different elements. So at first, it would be accessing li of 0, that is the 0th element, which is apple, right? Then it would be accessing li of 1, which is banana. Then li of 2, which is mango. And then li of 3, which is 2. That's what here it's happening, right? Let's check it. That's exactly what has happened over here. So I hope you understand how I actually manipulated using the range function to get the same output. All right. Now coming to the next operation, which is append. So as I have already mentioned, append adds an item at the very end of the string. So I already had li to be apple, banana, mango, and 2. Now when I write li.append orange, this orange comes and gets added at the last. So after 2. And that's what has happened over here. After 2, orange comes. Now what is insert? Again, as I have mentioned, it is nothing, just an extension of append, wherein I also mention the specific position where I want to insert my required element. So I want to insert orange at the second place. This was the 0th element, this was the first element, and this is the second element. So I want to place orange at the second position. So mango would actually take third position, right? So now orange would come here. It would be taking the second place, mango would be taking the third place, and 2 will be taking fourth place. That's what has exactly happened. Apple, banana, after that orange, then mango, and 2. So insert and append are kind of same. However, unlike append, it also takes a positional argument so as where it should place this particular element, while append only adds it at the very end. All right. Now, extend. As I had already mentioned, what extend does is there are two lists. One is apple, banana, mango, and 2. Another is good and hood. So when I extend it, let me grab my pen real quick. Yeah. So when I extend it, what happens? Good and hood is appended at the last, but not as a list, as simple elements. And that's what has happened. And as I have mentioned, the difference between append and extend is that append adds a single item. So when I use, so let's see what happens when I actually use append instead of extend. So this is my list. And this is the list that I want to append. So instead of extend, I'll just write append. See what's... Okay, I also need to call li. See what's happening. So what actually happened is, when I used extend, the items got added. But when I used append, after 2, a single item got added, and that too as a list. Right? This is the entire difference between extend and append. Now, let me be very clear with one more thing. Can I still access, let's say, hood out of this? Yes, we can. How do we access hood over here? So let's say I wanted to access hood. So what I'll do is, I'll just write li of. This is the 0th element, this is first element, second, third, fourth, and 5th element. So when I write li of 5, I get hood, right? Now, can I write li of 5 over here? Can I do that? It would be giving me an error because this is the 0th element, 1, 2, 3, and this is the 4th element. So li of, Okay, I've not run this. That is the reason it gave me the answer. Now let's check it out. So it's throwing me an error. Index out of range. Correct, because there is no index. So what I can still do to access hood is, let me check. So when I say li of 4, I get this fourth element as a list. Now I get both good and hood. Say for example, I want to access hood. I want to go inside this list and access the first element, 0th element, and this is the first element. So this is what I do. And I get hood. Also, I can access the 0th element to get the good. Right? So this is how we access elements when it's present inside lists, inside lists. All right? So this was all about append and extend, the differences between them. Now coming to concatenation. What does concatenation do? It just adds the two lists together. So list 1 gives me 1, 2, and 3. List 2 gives me 4, 5, and apple. So when I do list 1 plus list 2, I get 1, 2, 3, 4, 5, and apple, both concatenated. Same as that we get in strings. Now coming to a very important operation of list. How do we copy a list? Okay, so for this we need to understand certain things. So let's say string. When I write a string, as I have mentioned how strings are accessed, if you remember, variables are nothing but locations or pointers to memory places. So if a equals to 23, this is how it operates. If b equals to 23, it points to this particular place as well, right? This is how the entire thing happens. Now, an important thing what happens in list is, let's say list 1 contains this particular list, apple, banana, mango, and 2. And what I do is list 2 is equal to list 1. Right? So people might be thinking that list 2 is now. So let's see what is list 2, right? Let me check it one by one. So list 2 is equal to list 1. Let's print list 1 over here. Obviously, this is what I'll get. Let's also print list 2. Same thing that I'm getting. So up to now, I think everything is cleared. Nothing, no problem. Now, what if I just want to add? So list 2 is this, right? What if I just want to add something I want to append to list 1? So list 1 dot append. Let's say 5. Simple. Now what should I get in list 1? No prizes for guessing. After 2, 5 would be added or appended, whatever you want to say. But what would be list 2 in that case? It should be same as this. I've done nothing with list 2, right? No tampering. Let's check out. Okay, that seems a bit weird. Why? I have appended 5 to list 1. How did list 2 get 5 appended as well? See, the problem to it, again, this is a concept of data structures, but this is a very simple thing that I have already explained in strings, so I'll be going forward and explaining it. So what happened was list 1 and list 2 are the same, right? Pointing at the same memory place. And let's say this contained X, and now it is containing Y. But list 2 is also pointing at the same memory place. It's not an entirely different list. When we write equals to, it doesn't copy. it only creates another pointer pointing at this particular place. And that is the reason when the elements has changed, or in this case, another element has been appended, both are reflected in this two pointers. So first understand this equals to does not really copy the list. It creates another pointer pointing at the same location, right? Okay, so we understand that we have not learned how to copy as of now. But then how do we do? Because copying is an important part. So for that, what we do is, there are three methods, right, to do that. The first is we use the function .copy. All right, let's check each and everything one by one. So this was list 1, right? This was list 1, and list 2 equals to, right? List 2 equals to list 1 dot copy of nothing else. So list 2 is equal to list 1 dot copy. Now let me check it. Okay, list 1, I'm getting the same thing, right? Apple, banana, mango, and 2. What if I put list 2? I'm getting the same output. What if I want to append list 1 dot append 5, and let me print out list 1 as well. I'm getting 5 as the output. And what about list 2? No, I'm not getting 5 as the output anymore. So what we do is list 2 is equal to list 1 dot copy. This is a method to copy, and this is the essentially important and the only method to copy. However, with time, other methods has been developed, but those are developed due to other reasons. This is the primary method that you use for copying. Again, you can use other methods as well. I preferably use other methods. So we'll see what are those. The second method that we can use to copy is we create another list. So what I do over here is, instead of list 2 is equal to list 1 dot copy, okay, let me remove this and let me show you. The problem still arises, right? So what I do is I create another list entirely. So I create another list. List 2 is equal to list of list 1. Now, what happens is, there was a list called list 1 containing some elements, right? Some elements. And what is list 2 now? List 2 is equal to another list that I have already created, which is equal to the entire list 1. And therefore, it is not a pointer anymore. It's not a mere pointer anymore. It's another list. And now what happens is, the changes will not be reflected. So see, list 1 is now 2, 5, while for list 2, it's still 2. So this is the second method. You create another list. The same thing copy method does, but it creates a list internally. So that's the entire thing. The third method that I normally use is what I do. Here, what you do is you use the slicing method. So what you do is list 1, and you use the slicing with a colon that takes all the elements together. This is also creating a list, but it's more effective. So what happens? Let's see. When I append, 5 is taken into place. but list 2 does not take 5. So these are basically 3 methods we use to copy lists. Alright, let's quickly recap. The first method is the dot copy method. The second method is creating another list. And the third method is slicing. Alright. So next time, do not think you have copied a list using the equal to sign. This is only you are creating another pointer. Alright. Now let's move to the next operation, that is sort. So lists also come with their own built sorting methods. So let's say I've created a list. List 1 is equal to 1, 2, 3, right? List 2 is equal to ABC. What I do is I sort list 1 dot sort. So it is sorted in an ascending way. So here you might not be able to understand what is happening because it's the same thing we're getting. So let me do one thing. Let this be 4, right? And let this be Z. Now see the difference. So list 1 is 1, 4, 3. And when we sort, I should get 1, 3, and 4, right? That is exactly what I've got, 1, 3, and 4. And when I'm writing list 2 is 1, Z, and C, we should get 1, C, and Z when it is sorted. That is what we are getting. The function that is used is dot sort, list 1 dot sort. Alright. For sorting in a descending order, what we do is, we here just introduce, reverse equals to true. That's all what we need to do. And see, it has been sorted in a descending order. Alright. That was everything about sort. Now there comes another important function called sorted. So what is the exact difference? Sort is used to sort the original list, while sorted, if we use sorted, the original list is not changed. So let's take an example. Here list 1 is 1, 2, 3, right? And list 2 is sorted list 1 in a reverse way. That is, list 2 would be list 1 sorted in a descending order. So that's what we do. Sort it and write this. Here, the difference that we get is list 1 would not be sort. So I get list 1 to be 1, 2, 3, while list 2 to be 3, 2, 1. Had we used the sort function, both list 1 and list 2 would have changed. But since we use the sorted function over here, we are getting a change only in list 2 and not in list 1. So I hope you get this particular concept cleared. When you want to change the list itself, you use the dot sort method. When you want to change the another list and keep the initial list intact, you use the sorted method. Right? Alright. Now coming to replace. So what does replace do? It's very simple. You just access the required element that you want to swap. In this case, I want to swap apple with cherry. So what I do is, I have accessed the apple. Li of 0 is obviously apple. And I have replaced that with cherry. Li of 0 equals to cherry. And now when I print, I get cherry, banana, mango, and 2 instead of apple. So that's what replace do. Now coming to remove. What does remove do? It removes a specified keyword. It takes only one argument, and it essentially means that only one item can be removed. at a time. We can remove many items, but at a time, only one item can be removed. So what I've done here is I've taken a list to be the same list, apple, banana, mango, and 2, and I've removed banana out of it. So li.remove banana. And see, when I now print li, I get apple, mango, and 2. So banana has been removed. Now, what if I had 2-3 occurrences of bananas, right? In this case, I have apple, banana, mango, banana, and 2. Then it only removes the first occurrence. So this particular banana would be removed when I remove banana. And what I get as an output is apple, mango, banana, and 2. So apple, mango, banana, and 2. Had I removed banana again, so let's check out what happens. Now let me remove banana again. Now what we get is no bananas because twice banana has been removed. Alright? That is how it operates, the remove function. Now coming to the pop function, it removes the items from the specified index, right? The remove function removes the items. So we explicitly mention which item do we want to remove, while pop is an index-based removal. So we essentially write li.pop and mention the index. So what happens is when 0th element has been removed, we see this apple, 0th element has been removed. We get banana, mango, and 2. So remove is a, we mention the element that we want to remove, and this is an index specific removal. This is element specific removal. This is index specific removal. And when we use pop, we can also get the removed item. So I have just taken the removed item in a variable, removed equals to li.pop 0. So when I want to take, when I want to understand which is the item that I have removed, I just use removed and I get apple. Apple is the item that I have removed. And the updated list, that is li, now contains banana, mango, and 2 without apple. Alright. Now, one important thing, in case we do not mention which index do we want to remove for .pop method, it removes the last item. See here, li equals to apple, banana, mango, and 2. And we have not explicitly mentioned. Here we had mentioned, and therefore the 0th item, that is apple, has been removed. Here, since we have not mentioned, it removes the last item. And mango, it finishes now with mango. Apple, banana, and mango. 2 has been removed. Now comes the del operation. The del operation removes the items from a specified index. The pop, what is the difference between del and pop? Pop pops out that item, and that item can also be accessed, right? For del, that item can never be accessed. So that's what happens. Li is equal to this, and we have written del li of 0, right? Therefore, apple has been deleted, and now this deleted item can also never be accessed. Now, unlike pop, if we do not explicitly mention which item do we want to remove, if we write del of li, it deletes the list entirely. The list does not exist, right? That is the reason when I now call li, it gives me an error, because it says the li is not defined. It has already deleted the list. Now in its memory, it cannot recall that anything called li is really defined. And that's how del actually works. Now we come to the clear operation. Clear operation is very similar to that of del. However, it does not delete the list. that is the data structure itself, it deletes all the elements inside the list. So when we write li.clear and then print li, it gives me a clear list with nothing in it. So these were some of the manipulation techniques, manipulation operations rather. And now we come to the one of the most important parts, where the list itself can perform all the mathematical operations. Mainly there are three operations that it can perform. One is sum. So when we write sum of li, it gives me the sum of the entire elements. So here we get 1 plus 2, that is 3, 3 plus 3 is 6, and plus 4 is 10. So that's what we get, 10. What is the maximum element? We give the function max of li, and we get maximum element here is 4, so we get 4. Similarly, for minimum, we write mean of li and we get 1. Also, we have already discussed about the len function, right? So the len function gives us the length of the number of elements or the length of the list. Here it's 3. That's what. It should be 4, right? Because there are 4 elements, 1, 2, 3 and 4. So it should give me 4, and that's what it has given me. All right. So yeah, that's all for today. We have learned lists in detail. In the subsequent lectures, we'll be learning about tuples, sets, and dictionaries in a detailed manner. Hello everyone. Welcome to this new lecture on tuples. So in the last lecture, we have discussed about lists, and as I already mentioned, that tuples and lists are quite similar. Tuples having some less functionalities, and also that it's not changeable or non-mutable. Okay, so to start with, we'll be taking tuple as t, and I have declared the same elements inside it: apple, banana, mango, and 2. Now we need to understand the ways of representing a tuple. For list, it was quite simple. Li equals to, and you put the third bracket, or you use the list function, whatever works for you. Now for tuple, we do have this particular method, tuple, and we can also take tuple equals to this. So this gives me a tuple. But other than this, we can also declare a tuple by the following methods. First, so this everyone can understand, this is a tuple, right? Now, if we even do not give the first bracket, we explicitly we do not need to explicitly declare all the brackets. We can just go ahead and type the, collection of numbers, 1, 2, 3, 4. In that case itself, so type of the, it has still understood that it's a tuple. Now again, one important thing that we need to know is if we, let's say, write t equals to, right, give this first bracket and write one element inside it, or let's say a, anything. People might think this is a tuple, but it is actually not. A tuple must have at least a collection of 2 items, at least. If it needs to have 1 item, then a comma is what is necessary to be put. So for example, when we see type of C1, we get it to be an integer. However, in the second thing that we have done is, we have just put a comma, and now it's showing it's to be a tuple, right? Same can be understood here for D1. I think everyone can understand that this would be a, so I think everyone can understand that D1 is a integer. That's what it is. But when I put d1, d2 equals to 1, comma, it again becomes a tuple. So tuple can be declared by first brackets or by just mentioning a collection of numbers. Also, one thing to note, if you put just one number inside the first bracket, it is not a tuple. You need to put at least a comma to make Python understand that you are using a tuple. All right. So this was all about how to represent a tuple. Now, coming to the operations, as I have already mentioned, that due to its non-mutability, it cannot perform operations like append, insert, or extend. Neither can it perform operations like remove, pop, del, and clear. It cannot replace, neither can it sort, right? So the things that it can actually perform are accessing items, looping through the tuple, concatenation, copy of a tuple, and the mathematical operations that we have already learned in lists. So accessing an item in tuple is as same as that in lists or strings. So T of 1 is giving me banana. A tuple was this, apple, banana, mango, and 2. So T of 1 is banana. And the rest as follows, very similar to that of lists. Looping through tuple is again as similar to that as lists. We just need to put the name of the tuple inside it and then print I, so we get the items printed. And again, we can use the range concept that I have already discussed in lists. Again, concatenation is as similar to that as in lists. We just use the plus symbol to concatenate. For copying of a tuple, this is where it gets different. Copying of a tuple can very easily be done by T1 equals to T2. And why is that? Let's understand the reason, right? So the essential reason behind it is you can append, clear, or replace items in a list. You cannot do so in tuple, right? Can you do? No. Therefore, when you declare a tuple, a memory space, let's say A, B, and 1. So let's say T1 points to this particular memory place. The copying of a tuple actually makes not a lot of sense. But if you write T1 equals to T2, it points at the same place. There's not much you can change here. And therefore, where T1 points, T2 points at the same place, since T1 cannot be changed. Therefore, it doesn't really matter if you create another tuple. So T1 equals to T2 does our work. Again, we do not necessarily copy a tuple. That is something we do for lists. So that is one thing that we need to understand. Right. The last thing that we also need to know is we can also perform the same mathematical operations, sum, max, mean, and also the len function. Let me quickly write it as well. So print len of li or t. That's what I've mentioned. And yeah, that's what we get. So very similar to lists. The essential difference that I've already mentioned in a chart previously is the representation as well as performing this mutable functions. Other than this, tuple and lists are quite the same. So that's all for today. We'll be learning about sets and dictionaries in the subsequent lectures. Hello everyone. In this lecture, we will be learning about dictionaries. In the past few lectures, we have already learned about lists and tuples. Now it's the turn for dictionary. Now, as we have already learned, dictionaries can be created as in key value pairs. So D equals to key given by its value. So here brand is the key, Ford is the value, again 2 is a key, Mustang is the value, here is the key, and 1964 is the value. Alright. So what are the operations and dictionaries that we will be learning? First is the way of accessing items, accessing keys, values, both, looping through dictionaries, adding any items in a dictionary, copying a dictionary. Now note, dictionary like list can be appended, replaced, or subtracted elements from dictionaries, that I mean. And therefore, copying of a dictionary is quite similar to that of lists, unlike tuples. We'll also be learning about replacing, updating items in a dictionary, the function of pop and pop item, deleting a dictionary, and clearing a dictionary. First things first, let's start with the basics. So primarily, we have our dictionary, that is this one. Let's copy it for us to have a quick look. So that is what the dictionary is. Now, let's assume we want to get the value of year. So what we do is, we simply put D of year. And year should be in side apostrophes because it's a string. That's how it has been declared. And we get 1964 straight away. But there is another way of getting the value from the keys. And that is, we write the get method. We use the get method. So this is d.get, and we put year. So we get 1964, the same thing. So the two things that we learned was are d.get of 1964 and d of year. So this process is quite similar to that of list or tuple, and I prefer to use this. However, there is a catch. Let's say you create a dictionary, and dictionary won't be this small. Every collections, list, tuples, dictionary sets will be very long, and you necessarily may not remember what are the keys inside a dictionary. So let's say you are creating a dictionary for a person, the attributes of a person, the height, weight, it's his BMI, his education qualification, and everything. Now what if you want to give a key that is not present at all? So let's say, let me comment it out. Let's say you are giving a key which is not present here. Let's say build. So build is a key that is not present over here. Let's see what it gives me. It's throwing me an error. Now, once you are running a script and it throws you an error, it's very problematic because all the subsequent processes gets, stopped or behaves in a very ill-mannered way. And that is the reason we also have this particular topic which we call as exception handling, where we handles this exception, and even if error comes, we still pause the particular running of the program and move to the next programs. So what we learn, we need to exclude or we need to eradicate any error in our code. So d.build gives me an error. However, if we use the get method, and if I write the same thing, d.getBuild, it won't give me an error, it would give me nothing. So that's what it's giving me, nothing. So a better alternative is the get method in dictionaries. However, I prefer this particular method because it's quite similar to that of list, tuple, and every other collections. But when you're writing a program and you know that error might creep in, that is the time I prefer to use the d.get method. So that's something you need to understand. All right. Now that said, let's move to the next operation. How do we get access to the keys, values, and both keys and values? So for accessing keys, we use the d.keys method. So what I've done over here is d.keys, and it's giving me all the keys, brand, to, and here. When I write the d.values method, it gives me all the values, Ford, Mustang, and 1964. So for the key brand, I get Ford as the value. For 2, I get Mustang as the value. And for the key year, I get 1964 as the value. What if I want to access both the items? This is when I use d.items. So d.keys, d.values, and d.items. For d.items, I get brand Ford, 2 Mustang, year 1964 inside a tuple, inside many tuples. So the key value pair are enclosed within a tuple, within separate tuples as such. That's how accessing keys, values, and key value pair works. Now looping through a dictionary is very similar to that as list. Only the factor that here we might want to take, the keys or the values or both. So for keys, what we do is, for I in my dict contains this thing. And when I print I, it gives me all the values of key. So brand, brand, 2, and year. That's what we get. Now, if you want to get the values out of it, what we do is d of I. So for list, if you remember, d of 0 or li of 0, whatever you want to call, gives me the value because it was index based. A dictionary is key based. So we write d of the key. So d of brand, d of 2, d of year. That's what happens. And it gives me the values. Now, what if we want to get both? We simply write for I, j in my dict, or any variables that you want to take, any pointers rather, not variables, in my dict dot items. This is what you need to add, dot items. Print I, j, and you get the key value pairs. So brand Ford, 2 is Mustang, here is 1964. That's how we take both the key value pairs together. All right. So what if we really want to add any variable to the dictionary? Not variable, but a key value pair. Only key or only value cannot be added. So we have this my dict having 3 keys and 3 values attached to it. Right? So this is the key. Now we want to add another key, let's say, and that let it be color. And the color of the Mustang is red. So what we simply do is, we call the dictionary that here it is my dict of color equals to red. And it simply gives me color, red as another key value pair. Right? So it was the original dictionary up to year 1964. The next one, when we added color, red, got added. Now we move to the copy method. Now for similar method, as we have already learned, in list, we cannot do dict1 is equals to dict2. Instead, we do dict1 equals to dict of dict1. That is, we create another dictionary similar to list. List2, if you remember, is equal to list of list1. There were two other methods for list as well, but this is the actual method that we follow everywhere. For dictionary, list is removed by the function dict. That's all. So that's what we have done over here. All right. Now the replace function in dictionary. So for replacing, what we need to do is, it's quite simple as addition. For addition, we call the dictionary and then we use the required key followed by its value. For dictionary, for replacing, what we do is, we call any present keys. Here we have called year, and instead of 1964, I have written 2020. So I have updated in a way. So what I've done is my dict year equals to 2020, and now the previously it was 1964. Now it has become 2020. That's how we use the replace function. An extension to replace function is the update function. What we do here is, let's say we want to replace 2-3 key value pairs together. Replace allows us to replace only one key value pair at a time. But update lets us, so see here, it was brand Ford, and what I've done is my dict.update, and I have taken a dictionary. So I've changed brand with BMW and 2 with Lambo. So short form from Lamborghini. So now the brand, instead of Ford, it should show me BMW, and that's what it's showing. And for 2, it was showing earlier Mustang, and now it's showing me Lambo. This is what we do using the update function. Just an extension of the replace function. Now we come to the pop and pop item. It is again quite similar to that of list. So what we have done here is my dict.pop brand. So I have popped the, in list, remember what we used to do is li.pop, and we used to put the index in place, right? So that the value got deleted. But since dictionary is a key value pair, we write .pop and followed by the key. So I've taken brand. Therefore, this got deleted or popped out, and we get 2, Mustang and year, 1964. The rest. What is pop item then? Pop item is when we are not sure what we want to remove. For example, when I wrote li.pop, it removed the last item. For dictionary, pop item does the same. It removes the last item. So I've written my dict.pop item. It has removed the year part. All right. Now coming to delete function. Again, it's exactly as same as that of list. When I write, the dictionary is same. When I write del of my dict year, it deletes the year. And unlike pop, I cannot access this particular year. So it says brand Ford to Mustang. Again, if I only wrote del my dict without giving any attribute, it deleted the entire dictionary. So now when I call my dictionary, it's giving me an error saying that this name is not defined. As it has been deleted, it's not in its memory that it was defined at a point of time. So that's why it says, I cannot really recall that you had defined such a thing called my dict. Now clear is the same thing as in dictionary. It clears the dictionary, nothing else. And you get a blank dictionary. So this was all about dictionary. And since we have moved to this particular stage, I have curated a simple problem which I would really want you guys to solve. Although I'll be giving you the solution and explaining it step by step, but I would really want you to understand the problem first, and pause the video and think about the solution. Maybe write the code. If you cannot, and in case you can, just check my code to get the proper idea. So given is a nested dictionary. A nested dictionary is what? Dictionary inside a dictionary. So what we see here is, this is a dictionary having Ram as the key, Sham as the key, and Mohan as the key. And these are the values which are incorporated inside another dictionary. And this dictionary has different subject names as their keys and their marks as the values. So what I want from here is, I want this to be displayed. So name of the student and the marks he got. Again, name of the student, the marks he got. And same way, it should go on and on. So this is where you stop your video and try to answer this particular question. Okay, now let's resume the video and see my solution. All right, so what I've done is, this is the first step that I've taken. I have declared the entire list, the entire dictionary, so as that I can work with the dictionary. It's quite simple. I've taken Ram as the key and this dictionary as the value. Same for Sham and Mohan. And again, inside this dictionary, all the subjects as their keys and their values as marks. Their marks as their values. Now, understand the solution. So, what I've done over here is, I've taken for I, j in student marks, which is the name of the dictionary, student marks dot items. If you remember, dot items gives me the key pair value, right? Print name of the student is I. So let's understand what it actually does step by step. So, any guesses what this would give me? Print I, j. Let's say for I, it should give me the key, and for j, it should give me a value. So it should give me the entire value. Ram, Sham, Mohan should be the keys, and their dictionaries containing marks and the subject name should be their values. This is what exactly we get. Now remember, I want to get this as, name should be differently accessed and the marks and their subject name should be differently accessed. So for that, what we do is, I take I and I do get the name. And now I have to tweak a little bit of something. So for that, I just need to create an if string, if you remember what it is. So name of the student Okay, you have to give the apostrophe properly. So now it's working perfectly. So name of the student is Ram, Sham, and Mohan. Now what we need to do is, we need to find their marks. So what I'll be doing is, so now J has all their, okay, let's see what J has. So J has the name of the subject and marks. So what we can do is, we can take two other pointers, let's say for, let's say A, comma, B, right, in j dot items. Should this be making any sense? So what would this do? It would take these dictionaries and treat this as key and this as values. Let's see. Print AV. Yes, it is performing our task, right? Now what we need to do is, we need this as the output. So maths and 75, right? So what we do here is, let's create another F string. Okay, again, I need to close the inverted comma. And yes, voila, we are getting the output as we want. So name of the student, I've used the F string, and we're getting the names. And then again, going inside this next dictionary as j.items, and I am naming them as A and B. So A is the name of the key, that is maths, science, and English. And B is the marks, that is the values. That is what we are doing. So I hope you understood this. If not, do try to get it on your own and practice this kind of things. All right. So the next lecture we'll be learning about sets, and that's how we'll be ending our lecture on data structures. Hope to see you in the next lecture as well. Hello everyone. In this lecture, we'll be learning about sets. So we have already learned about lists, tuples, dictionary, and now we'll be learning about sets, which is the last data structure in our curriculum. So first, let's understand how do we represent a set. So it's very simple. As list and tuples, just we put the second bracket. And we have already discussed all of them. All right. So I've taken a set consisting of apple, banana, mango, and 2. Now let us perform the different operations that we have. First one is accessing the items. So this is as simple as it gets. We have done this a number of times. One thing that is to notice over here is, since sets are unordered, therefore it is not really possible to access an item using the index, right? So we cannot really, so let's understand this. So let's copy this particular set. And let's say you want me to grab apple, right? So I cannot necessarily do this. This would throw me an error. Why? Because as it also says, set object is not subscriptable. That is, since it does not have any index, it cannot take the values. It doesn't understand what do you mean by s of 0, because these are not indexed, right? These are not ordered. So how do we access elements inside a list? Well, the only option is to get all of them together using a loop. That's exactly what I've done over here for I in S print I. And I'm exactly getting all of this elements. Now note that unlike in list and tuple, we cannot use the range function over here. Because as I said, it does not understand any index, right? So let's again see what happens. For I in S, okay, let me use another. For I in range. Again, it's just a waste of time because ln of S doesn't, ln of S is 4, right? So now what we need to do is for I in range, right? So print I, it would definitely give me all the numbers. But when I write print s of I, it would throw me an error. So that's how it operates, right? So I hope you get it. How do we access items? By simply getting all these items. Now, one other way is we can store the items from sets into another data structure, for example, list, and then we can do all of the manipulations. Those are called using different data structures, and that is what we necessarily do. And we'll be coming to all those things later as we move forward with the course. But for sets, let us understand all the operations that a set does, and later we will combine to permutation and combination and understand each and everything in detail. All right. Now, what about changing items? We can necessarily, okay, so let's read from here. It says that once a set is created, you cannot replace any item. So once it is created, I cannot replace an item. Necessarily I cannot, because I do not know at which index Apple is present, right? Let me show you one important and interesting thing over here as well. So what happens is, let's say I'm creating a list, right? You might expect that Apple is located in the first place, but no. When I print this list, see, 2 comes over here, apple, then banana, then mango. We do not actually know which item is present. We only know that each of the items mentioned will be present and present only once. That is the beauty of set. Therefore, we cannot really replace a set, right? We do not know where or in which index or in which position these items are present or elements are present. What we can do though is we can remove and add elements. So here what I have done is add cherry, and cherry is added somewhere. I do not know where, but it is added somewhere. And this is how I got it. So it keeps on changing. Previously cherry was added somewhere, I forgot, but then now it has changed. Hopefully the next iteration it would remain the same. Yes, it remains the same, but then that's how it operates. I have added cherry, it got added somewhere. Now, same as in list, if you want to add multiple, elements, we use the update option. So s.update, I have used a list of elements, and when I print s, I get all of this together. All right. Now, one very important thing in set is the set operations that we perform. So first, let us understand what are the set operations. The first is the union. So let us consider 2 sets. All right. Let this be called as S1 and this be called as S2. Now, anything located here in the shaded region is to be termed as S1 intersection of S2. I'm sorry, the intersection is, so S1 intersection of S2. This is the region. What is S1 union S2? This is basically the intersection region plus this region plus this region. So this is union. Necessarily, it can also be written as S1 plus S2 Now S1 plus S2 means this region, Okay, let me make you understand in a different way. So S1 means this, S2 means this, and now this particular region gets repeated twice, right? That is the intersection part, gets repeated twice. So we can also write S1 union S2 equals to S1 plus S2 minus S1 intersection S2 minus this intersection part. All right. So now by examples, we'll understand how this has been operated. All right. So I've taken two sets. One is S1 containing 1, 2, C and D. S2, 1, A and D. So what are the common elements over here? 1 is a common element and D is another common element, right? So S1 intersection of S2 should give me 1 and D, because these are the regions. So 1 and D lies over here, and A over here if this is S2, and if this is S1, here lies 2 and C. So S1 intersection S2 is 1, D. And union, that is S1 union S2 is all of them together. That is 1, 2, C, D and also A. 1, 2, A, C, D, right? So let's understand. So when I've written union, I'm getting 1, 2, D, C, A. 1, 2, D, C, A. When I'm doing the intersection, I'm getting A and D. That's precisely what we should be getting. Another is difference. What is difference? Difference means S1 minus S2. That's what I've done, S1 minus S2. So when I'm doing S1 minus S2, understand. So S1 contains 1, 2, C and D. If I subtract S2 from it, so I'll be subtracting 1. I will be subtracting A, but A is not present over here, so A is overlooked. I would also be subtracting D. The rest, that is 2 and C, remains as it is. Therefore, the answer that we get should be 2, C. That is exactly what we got, 2, C. So this is all about difference. Now let's understand the code over here. So what I've done is, there are two methods by which we can do the union. One is we use the OR symbol. This is the OR symbol, S1 or S2, which essentially means take this or this, that is entire thing. Or we can simply write S1 dot union S2. Both does the same thing. Exactly same. For intersection, we take the AND operation. Means this and this. Wherever the two common things, we might also use the intersection function, dot intersection. For difference, what we do is S1 minus S2 or use the dot difference function. So these are all the set operations that we have learned. Now set also has the remove methods as present in lists. So pop, remove, discard and clear, all very similar to list. Although discard is a new thing to learn, so we'll be doing that. So pop is quite same. You have all the items. Here what you do is s.pop and it removes any item. Now you necessarily do not know which item is gonna be removed? See, removes only the last item. Since sets are unordered, we don't know which item gets removed. So pop is something that is there, but we do not necessarily use it. But yes, we definitely can know which item has been removed. Right? Now, another important function is remove. It removes the specified item. And it gives error if the item is not present. So quite similar to that of list. So what we have done over here is s is equal to all the names as previously. S.remove banana. And now when we print, we get the set without banana. Now when we try to remove an item which is not present, we get an error. So that is quite the same for list as well as set. However, in set we also have an option called discard, which is same as that of remove. S.discard banana, it discards the banana. But in case this item is not there, for example cherry, S.discard cherry, it does not give me an error and prints the set itself. The last remove function, that is clear, again, as similar to that of list, it clears the set. And that's why we get a blank set. And unlike list or tuple, we do not get this. This we get in dictionary. Here we get set. This is a blank set. Now we also have the mathematical operations. So sum we also have the max and mean and the len as we have shown. So this was all about set. So I hope you have understood all the different data structures, starting from lists, tuple, dictionary, and set. So these are essential, and we will be using every single of them as we move forward with the course. All right. So thanks for joining in. This was it for this lecture. Hello everyone. Today we'll be learning about functions in Python. So to begin with, what are functions? Functions are nothing, but these are a kind of expressions which helps us in reusability of our codes. And therefore, it also reduces the redundancy. So what do I exactly mean by this? Let's say I'm writing a certain line of codes, and I know that this lines is going to repeat for certain other parameters. Let's say I want to write a particular code for each of the 50 students in a particular class. So should I write the same lines of code 50 times? Should I do that? No. Instead, what we do is we create function, and this function is what we repeat. We call 50 times. And therefore, but by writing just the simple line of function, we can compute for all 50 students. So this is the magic of function. Therefore, it allows us reduces the redundancy in a great level. Now, there are basically two types of functions: user-defined and inbuilt functions. So inbuilt functions are those that has been predefined by the Python community or the language itself. And user-defined functions are custom-made functions. We create them on our own to suit our own needs. And we'll be focusing mainly on the user-defined functions. The inbuilt functions are, so we already learned about list, string, and everything. So we use this function called length of list, right? Which gives me the length of list. Or let's say list of sum. This is not function though. Or let's say max of list. All these are functions. Max, len, these are functions, and these are inbuilt functions. However, mainly we deal with the user-defined functions. Why? Because more than often we come across situations where we need to custom define our own functions, and that is what we are going to learn over here. So there are certain rules to define a function. So the first thing is we define a function using the def keyword. The def keyword is what is required. So this is how we define our function. First we write def, then it is followed by a function name. So here demo underscore function is the name of the function. So that's what we do. Def, then the function name. After that comes the parenthesis enclosed in a first bracket or parenthesis, whatever you want to call. So A is basically the argument or the parameter that we will be using. So don't get overwhelmed if you do not understand the terms as of now. You'll be totally comfortable towards the end of this lecture. Trust me on this. This is what we call as parameter or argument. And this is defined inside the parenthesis after the function name. So what we learned? Def followed by function name, followed by parenthesis and the argument. Then we write the colon, right? Again, an important thing to note is that this is optional. This name of the argument is optional. Why is it optional, or when should we include it, or when should we just eradicate it? We'll learn everything. Okay. So finally, there comes the colon to end the function header. So this marks the end of the function header. After that comes the body of the function. It consists of one or more statements, and these statements must have the same indentation level. So after the colon, we go to the next line where we write the body, and the body should have an indentation. Generally, we take a tab indentation. What is a tab indentation? You have the tab bar in your keyboard, right? You press it once. So the indentation, the space that is given by the tab is called the tab space. And that is the indentation we generally follow. However, you can make your own indentation, maybe 2 times pressing the space bar, or maybe 4 times. Tab is basically pressing space bar 4 times. So you can follow your own indentation level. That matters nothing. But remember one thing, the indentation level that you're following should be uniform throughout your code. Generally, if you're using a Jupyter notebook, you need not even put the indentation. When you press enter after pressing colon, it generally takes the tab space indentation. So that is how it goes. However, you may be using other compilers as well, wherein the indentation does not necessarily take place automatically. And there you might want to press the tab. All right. Finally, the last thing that is done in a function is the return statement. The return statement is finally used to return a value from the function. So here I have also written the return function. Now let us understand what this function does, right? So I have written, it's defining a function over here. So I've written the def keyword, name of the function is demo func. After that, parenthesis and the parameter name, that is A, followed by a colon to mark the end of the function header, right? After that, we move to the second line, and the subsequent lines form the function body. So these are the function body. Here what we have done is, I have defined another variable which is in the local scope, if you remember the scope of a variable. So b equals to 2. I have also defined another variable called prod, which is equal to a into b. So whatever the value of a is, let's say a is 3, then prod will become a into b, that is 6. Okay, and then I have written return prod. So the output of this entire function block would give me 6, right? Because that is what it is returning. Now, how do we get the output? We need to call the function. This is the defining of the function. And now I'm calling the function. How do we do that? I write the function name, demo underscore func, followed by the parenthesis and naming the argument. So here a, I'm taking as 3. I can take it any value I want. So here I have taken it to be 3. And therefore, the output that I'm getting is 6. Because a, that is 3, into b. b is already given 2. That cannot be changed. This, however, can be changed. So we are getting the output as 6. Alright. I hope that makes some sense. Okay. We will be understanding more when we go to the lab session. Alright. But before that, I also want to let you know some more facts about parameters. So parameter is what? Def followed by function name. Let me call it to be func. And then parenthesis, and here comes the argument. Right? This is the argument. So this argument can be of the following 6 types, right? First, we can take no parameter or no argument. Parameter is synonymous with argument. Alright. So we can take either no parameter, that is okay. We can take one parameter, as we have seen in the previous example. We can take multiple parameters, right? Suppose in that particular previous function, we could have taken a and b both to be the parameters and defined them explicitly. That could have also been possible. We can take a default parameter. What is a default parameter? A default parameter is when we will be learning in the lab session for ease of use. Let's say, in simple words, default parameter is what? When you define the parameter in case nothing has been explicitly declared. Alright. Now, we come to parameters enclosed within a data structure. This parameter may not only be a variable, this might be a list as well. A list of values can be passed. So that is also possible. And last but not the least, perhaps the most important thing, args and quarks. Args is basically when you are unsure of how many arguments you want to take into account. And quarks is same, but for key value pairs, necessarily what we define as dictionaries. So we'll see examples of them as well, right? All right. Now let's understand all these things that we have learned and then move to the next topic. Let me quickly go to my lab session. All right. I hope my screen is visible. So what happens over here is, as I have already said, that functions allow the reusability of codes and thereby reduces redundancy. There are 2 types of functions, everything I have defined. Now coming to the very basic function that we have seen. So def followed by the function name a. I have explained this particular function. So now I'm writing demo function 3 and it is giving me 6. What if I had written it to be, let's say, 50, right? 50. Demo function of 50. Any guesses what would the answer be? It would be 100 because A now becomes 50 and B is 2 as it is given. So our output is 100. I hope it is clear. Okay. Now one most important thing that we need to note over here, which perhaps I have missed in the PPT, is the use of return statement, right? So always remember the return statement or the return keyword is put at the very last of the function. Let's assume we put it somewhere before, in mid of the body. What would happen then? The function would immediately stop execution. It would stop execution. Return also marks the end of the function, right? So I've written that any code after return statement will never happen. So the following two examples will illustrate the same. So let's check out this particular example. Def add numbers. Add numbers is the name of the function. And I've given two parameters, x, y, right? Then I've taken another variable called total equals to x plus y. So whatever the values of x and y is when we call 4 and 90, so it should give me the sum total. So let's see what the body says. It says print, this is example 2. And after that comes the return statement, return total. So the output that should be given over here is, first, it would compute the value of total. Then it would print this particular statement. This is example 2. And only after that, it would it would return the value total, which in this case is 23. And then it would actually end the function, right? So that's what has happened over here. When I called the function add numbers 4 and 90, it prints the line, this is example 2, followed by the value of total. Yes. Right? Now, check out over here. Okay. So, check it out. Here what I've done is, I've done the same thing, add numbers xy, total is equal to x plus y. Then, instead of print, I have written return 4. Right? After that, I have written print, this is example 1. And then also written print total. So, one important thing is, if this was never mentioned, right? What would have been the output? I should have got print, this is example 1. Then the total, that is 23. So my output should have been, okay, just forget it. This line, this is example 1, followed by 23. That should have been my output. So let's quickly check it. Let me put a comment over here real quick. And now, when I run it, it gives me the same thing. This is example 1 and the output is 23. But since I have not, so what I exactly did, if you have missed it, I've just put a hashtag which actually comments the statement, and yeah, this is what I get. Now, since this was not commented and return came before this print statement, the program execution would stop after returning 4. The function will end, and that's, so let's see what has happened. Yes, it's giving me 4. Out of nowhere, it is not printing the statement, it is not giving me the total, it is doing nothing, but it's giving me 4 as the output. So I hope you understand the use and the power of return. It not only gives me the output that is specified over here, it also ends the function, and that is a very important thing to note. All right. Okay, so that's it. Let's move to the parameters part that we have already learned, right? So we'll be understanding all these 6 parameters. Okay. So the first thing, without any parameter. So if no parameters is passed while function construction, it should also be called during calling. There might be some mistake in the writing. What I essentially mean over here is, if no parameter is passed while function construction, it should not be called during calling. So what I've seen all over here is, I was passing these two parameters, right? X comma y. And while calling, I was passing two parameters as well. Same for here. During construction, I created one parameter. During calling, I called one parameter. So now, when I do not create any parameter, while calling the function, I should not call any parameter as well. So def func print hello. When I call the function, it should print hello. And that's what it is essentially doing. It is calling hello. What if I actually gave a parameter, func of a? It is giving me an error. Why? And it clearly says, name a is not defined. I'm sorry, but a has not been defined, right? Let's say I call func of 2, still gives an error. The previous error was something different. It was my mistake because a has not been defined. But now is the actual thing. It says func takes 0 positional argument, but 1 was given. That means it takes no positional argument. So how can you give an argument? That's what Python is telling you. So that's how we do without any parameter. Now with one parameter, it's very simple. We have already gone through this. So def func, I'm giving a parameter as name and returning welcome plus name. So whenever you give something, it returns welcome that particular name. And that's what exactly has happened. Welcome Steve, right? Now, taking into account multiple parameters, this is very simple as well. I've given A, B, C as the parameters and I've called 4, 5 and 2. What does the body say of the return statement? It says A plus B into C. So Bottom's rule will be followed, B into C. And one most important thing to note over here is, when I say A, B, C and I call the function func, okay, let me just do it over here. So A is basically mapped to 4, right? B is mapped to 5 and 2 is mapped to C. That's how it works. A will always be marked to 4, the first one. Second one will be marked to the second one and third one will be marked to the third one. That's how it operates. So when I say A plus B into C, so first B into C occurs, that is 5 into 10, 5 into 2 equals to 10, plus A, that is plus 4, 14, and 14 is the out that we get over here, right? Now coming to the default parameter. So as I said, I will be taking time to explain this. So what generally happens, okay, let me first read out the line. It says, if default parameter is set while function construction, it is not necessary to call the parameter during the function calling. So what do we mean by that? Let's say, let me give you a situation. Let's say you come into contact with a group of 100 odd people, right? And most of them are Indians, all right? And only 5 to 7% of them are of different countries, right? So would you really want to spend your time writing the country name? So when I said 5 to 7%, it means, and you have 100 odd people, it means 5 to 7 people are from different countries. The rest are from India, right? So would you necessarily spend time in writing 93 times India? Would you do that? Even if you're okay with that, what if the data is, let's say, 10,000? In that case, it should be 9,300, right? 9,300. Would you really write this number of times India? No, right? So the best thing that we do is, we take a default parameter. What is a default parameter? While defining the name of the function, rather the parameter, I've defined the parameter as country, right? So let me work this through step by step. Okay. So what I could have done is def, right? Func, that is the name of the function, followed by parenthesis and taking the parameter as country. Return, I'm taking an f string. I am from country, right? Now when I call the function, I should be giving a name, right? Let's say I'm giving the name as India. So it says I'm from India. Let's say I'm giving the name Spain. So it says I'm from Spain. And now what if I give nothing? It gives me an error and says missing one required positional argument. So you had already defined parameter as country and you're not giving any parameter. Why is that? I cannot understand. That's what the Python is telling you. So please give me an argument, right? Now, had I defined a default parameter, that is country equals to any name, let's say India, right? And now I say I am from country. So if I just called func, it would give me I am from India. Why? Because default is that you are from India. As I said, 7% is from other countries and all the rest 93% are from India. So that is something that I would be using. So when I'm calling func, it is giving me that I am from India. Now let's say for the rest 7 of them, let's say one of them is from Spain. So nothing, just give the argument that I am from Spain. Right? And that is what you're getting. I'm from Spain. Let's say I'm from Australia. I'm an Aussie. I'm getting that. I'm from Australia. Right? But if you're not giving any argument, you'll be getting India as the print line. That doesn't mean that you cannot give India as the argument itself. I'm from India. That can also be done. But if you do not give anything, you will get this particular output. So I hope this is clear to you. This is the power of default parameter. All right. Now one quick important difference between default parameters and no parameters. If you did not give any, if let's say out of the 100 odd people, 100 were Indians, then what would I have done? I would not have defined any parameter as such. Because I know there is no other people, right, from any other country. So this is what I would have done. I'm from India. And each time it would have been printing, I'm from India. And now I cannot pass any other argument over here. We use default parameter only if there is a discrepancy. Let's say 1 to 2%, 3%, some percent of them are from other countries as well. Only then is when we use the default parameter. So I hope the difference is clear to you. All right. Now moving to passing a data structure as an argument. So that is quite simple. I've done the same thing, def func food. Now for I in food, print I, right? So what's happening now, I have defined fruits to be a list of fruits and an integer as well, apple, banana and 2. Now when I'm calling func of fruits, it's returning the loop. So it's giving me apple, banana and 2. That's what it has done, right? It's quite simple. Instead of this argument to be a string or numerical number, integer, it's just a list over here. It can be anything a tuple or something like that. Doesn't really matter. Now, one important thing to note over here is I'm using the print statement and not the return statement. Can you guess why? So I've quite explicitly written the reason. Return here will not work. Why? Because it will return only the first element. What had I already mentioned? Return ends the function, right? Whenever you find the return statement, it returns the element and ends the function. So return I would only give me apple and then stop from being execution. Print, on the other hand, will print all the elements in the list. So that's the reason I have used print over here. So that is all. Now, coming to one of the most important things, that is use of args and quarks. Okay, so if you're unsure about the number of parameters to be passed, use args or quarks, not ands. It should be args or quarks, depending upon your need. So args, how is it written? Star args, and quarks, double star quarks. So args are basically non-keyword argument, gives output in the form of tuples. And quarks are keyword argument, gives the output in the form of dictionary. So let us understand the same. I've defined a function, students, with both args and quarks, right? And note that this star is what it makes it to be args, and double star makes it to be quarks, right? You can use any other name instead of args. You can use any other names instead of quarks. But this star should be given, and here both double star. But for general purpose and for understandability, we generally use args and quarks and not any other name. You can even use Mickey Mouse over here and let's say Tom and Jerry over here. Doesn't really matter. But for people to understand, we use args and quarks. These are the key name that has been used. Although these are not defined keywords. These are things that have been coming through ages, and that's the reason we use them. Okay. So what I've written is print args. So the function would print args and also print quarks. It would also print name is quarks of name. All right. So now I'm passing the function with the arguments. So student, that is the name of the function. The arguments are math, arts 2, and name equals to John, age equals to 24. So all these three, comma separated, non-keywords, will come under args, right? These are keyword elements. Name equals to John, age is equal to 24. This will come under quarks. So let's see. When I'm calling the function, first it should print the args. So it's printing math, arts, and 2 as args. Second, it's printing name is as the keyword and John as the value. Name equals to John. Age and 24. Age equals to 24. So these are quarks, right? And the last thing, name is quarks of name. So name is quarks of name. That is quarks of name. It should be John. So name is John. Do you get it? That's how args and quarks actually work. All right. Now, coming to another important aspect here. So, if we unpack the items, if we pack the items in data structures and call them by the variable name, expected output cannot be received. So what I've done over here is I've done the same thing, args and quarks, print args and quarks, right? Now, instead of passing the arguments inside the function name, what I've done, instead of calling the function with the arguments, what I've done, I've also created two variables, right? One for the args, where only the args are given, and one for the quarks in the form of a dictionary. This in the form of tuple and this in the form of a dictionary. Now what I've done is I've called student of courses, info. What necessarily we will think should have happened is for args, it should have printed math, arts, and 2, right? This thing. And for info, it should have printed this. But this is giving me a weird output, and after that, a blank dictionary. Why is it so? So why is it so is a very difficult question to answer. I even don't know how it computes the same, but this is totally wrong. We are not allowed. This is not the method of unpacking. Since we have packed the arguments inside a data structure, tuple and dictionary, we need to unpack them in order to get the desired output, right? So what is the process? Nothing. Simple, since I know that courses falls under args, right? This falls under args. So you just need to give a star over here. Star courses. And info falls under quarks, so you just need to give 2 stars. That's all you need to do. This would unpack all the arguments and you would get your desired output. Let me clear it out. So that's exactly what I have done. Star courses and star info. And see the output that we actually wanted. We are getting the same. For args, we are getting math, arts, and 2. For quarks, we are getting this. All right. So I hope this is clear to you. In the next lecture, we will be learning about lambda functions. All right. So wish to see you in the next lecture. Bye. Hello everyone. In this lecture, we will be learning about anonymous functions. Mainly, by anonymous function, we mean the lambda function. So the lambda function is an anonymous function, and these are basically functions without any names. These are single use functions, that is, used for one time only, and they take any number of arguments but can have only one expression. So I've used a lot of terminologies over here. Let us understand everything one by one. So what is a normal function? We use the def keyword, right? Followed by the function name, func, followed by the parenthesis and the attribute, right? Followed by body, and then the return step. And this is a normal function, right? A lambda function, on the other hand, and also, while calling the function, we can call it n number of times anywhere. We just need to write func followed by the parent, the parameter name, whatever you want to give. Let's say 4 over here. Now, lambda functions do not have any name. Here the name was func. So lambda functions do not have any name, and therefore it automatically suffices that it cannot be used many number of times. The same lambda function cannot be called over and over again. It can be called only once at a given position where it is written. Now, it can also only have one expression, while a normal function can have multiple expressions, right? Let's say what I want to do, I want to, let's say, okay, so let's say I want to write total sum, let's say total t is equal to x plus y, right? X and y has been defined, let's say, or maybe I'm taking that in the parameter itself. And then what I'm doing is I'm taking, let's say, division d is equal to total by, let's say, 4. I'm doing some random things out here. And let's say exponential is equal to t by 4 into to the power, 3. So all these things cannot be done in Lambda function. I mean, it can be done, but in a single line. You cannot take 2-3 lines to do that, to compute your work, right? All right. The syntax for Lambda function is lambda. So that is what we write. Lambda is the symbol, the name of the function, lambda. Lambda x, or any name that you want to give, any parameter name you want to give, let's say lambda a colon a plus 5. So that's what would be happen. When you return a, it would give me the value. Let's say the value of a is 5 or 7. So my output will be 12. That's all about Lambda functions. So let us check it out. All right. So as we have learned what a Lambda function is. Now, so the first example basically says, what if we want to find the square of a number? I will do a comparative analysis between normal function and a Lambda function, right? So what if we want to find the square of a number? That's a very simple thing to do. This is basically a normal function. So what we have done is def square. Square is the name that I've taken. You can take any other name. Let's say you can take tiger. Makes no sense, but you can take it. So def square of x, return x into x. That is what square does, multiplying the same number by itself. Then we print square of 4 and we get the expected output, 16, right? Here we could have also, okay, we have done return only. Okay, fine. Now in case of a Lambda function, what does it do? It's very interesting. What I've done is, I've taken a name of a variable square equals to lambda x such that this, this colon is called such that. So lambda x such that x into x, such that x is x into x. That's how we interpret it. And print square of 4 and we are getting the same output. So that's what we have done. Lambda, right? Lambda x such that x is x into x. And this is something we have taken the variable to be square. And now what I'm doing is square of 4. So I'm getting 16 as the output. Right? Let me show this by another example. So let's say I'm asked to get the maximum of two numbers that has been entered, right? In case of a normal function, what would I do? Def, I've taken the name as max x comma y. If x greater than 1, return x, right? Max. Else, return y. Makes sense. If that is what I mean, if x is not greater than y, then please return y. Just to give you a in-depth analysis, what if x is equal to y? What should it return? It can return any of them. And that's how here it would be returning y, because only this case has been fulfilled, x greater than y. Other than this, it would return y if even x is equal to y or y is greater than x. Anyway, so now when I'm printing max of 3, 7, it's giving me 7. Makes sense. It's an easy thing to understand. Now for lambda function, what I have done is max equals to lambda of x, y, such that x, that is such that return x if x is greater than y, else y. Else, that is this, return y. And I'm getting the same output. Print max of 3, 7, and I'm getting 7 is the output. Right? Now we come to sorting. So what happens over here is sorting of a list of tuples using lambda function. We need to sort this list based on ascending order of the numericals, right? So we need to sort this list based on ascending order of the numericals. These are the numericals. So what essentially is happening over here, list 1 contains multiple tuples, right? And each tuple contains a string and an integer. And our task over here is to sort the list based on the numericals. So what I've done is list1.sort, right? Okay, let us understand what would happen taking each and everything into account. Okay. So let me copy this out and let me paste it. So we understand this is the list. Now, what if I press, right? What if I press list1.sort? What do we get? We get caret 4, eggs 3, zebra 5. So what has it done actually? It has sorted, but based on the strings. First comes C, then comes E, and then comes Z. But our task was to sort based on ascending order of the numericals, not the strings. And that is why we also pass another parameter, which is called key. So key here would be, key here should represent the numbers. And that's what we have done. Key equals to lambda of x such that x of 1 is returned. X, this is x of 0, right? And this is x of 1. So that's what we have actually done. And now when I press it, I get, the first is to be eggs 3, then I get caret 4, and then I get zebra 5. I hope this is clear to you. Going forward, let's understand this. Here we need to sort this list based on ascending order of the age. So this is basically a list containing multiple dictionaries, not tuples, right? And I need to sort this list based on the ascending order of age. So simple thing, list1.sort, key equals to here would be lambda x such that x of age, right? So x of age is returned. And now see, first age is 12, then it's 16, and then it's 18. So when we have a list containing other data structures, we need to use the particular parameter called key. And then define what is the parameter using which I want to sort it. And here, lambda function becomes quite important. Otherwise, what we have had to do, we had to define a function and it would have taken 2-3 lines. Makes no sense. And this is a one-time process, we understand that. And that is the usage of the practical implementation of a lambda function. So I hope the lambda function, which is also an anonymous function, is clear to you. Hope to see you in the next successive lectures. Hello everyone. In this lecture, we will be learning about some of the special functions in Python. These are widely used functions, and in due course, we'll be using each of them. So first, we'll be learning about filter functions, next map, third reduce, and fourth zip functions. So let us understand each of them one by one. So first is filter function. It basically filters function out of a sequence. That is, it returns the filtered list. It's mostly used by a lambda function. The syntax is very simple. Filter, function, comma, iterable. That is the list or whatever, the data structure that you want to pass, right? So let's understand how does it work. So what I've done is, let's say our target problem is, we need to get the list of numbers which are divisible by 15 from the given list, right? So there is 45, 55, 60, 37 and so on. And we need to only filter out all the numbers that are divisible by 15. So let's understand. Let us get all the numbers manually, right? 45, we know it is divisible. 55, it is not divisible, we know that. 60, yes, it is divisible. 37 is not. 900 is again not. 105 is divisible, right? 105 is divisible. 220 is not divisible. So what we find over here is, out of all these numbers, these are the three numbers which are divisible, right? This we have computed manually. What if the list was very long? What should we have done there? So simply we should have used the filter function. So what I've done over here is, I've taken a lambda function a equals to lambda x, such that x percentage 15, what is percentage? Modulus. This is a modulus function. What does it do? If you remember, it gives us the remainder. What I'm essentially telling over here is, please return, what a would do is, it would return x if x is divided by 15 and gives no remainder, right? So if x is divided by 15 and it gives us no remainder, then it should return me that x. So return only those x's that are divisible by 15, in short. And now I'm creating the filter function. So I'm creating a list called result equals to list of filter. I'm using this particular term, filter. Inside the parenthesis, function, the name of the function here will be a, comma, numList. NumList is the iterable over here. That is the list from which the filter is done. The filtering is done, right? And now I'm printing result. And I'm getting 45, 60 and 105. Quite simple. Filter a, that is the name of the function, and the name of the list from which the filtering has to be done. That's all about filter function. Very easy and efficient to use. Right. Now we move to the map function. What does this do? So the map function, it is used similar to okay, we'll learn through this particular example, the usage. So the syntax for map is very similar to that of filter. We use the keyword map followed by the name of the function and then iterable. So instead of filter, we use map over here. Again, we get a map. So what is our problem statement over here? Get the squares of each number from the list. So there is this list and I need to get all the squares of this number list. I cannot use filter over here. Filter would only filter some of the numbers. So I need to use map. So this is our list and I've taken a lambda function where it does the square, right? Now what I'm doing, I'm taking the same variable result is equal to list map of a comma numList. So a would do the square. It would actually map a, that is map this function to the entire list. And therefore the result we'll get is 4, 9, 16 and so on. I hope you get it. Map, what is it is doing? It is mapping this particular function to the iterable. And here it is the numList that is containing all these numbers. And therefore we are getting the output to be as 4, 9, 16, 25, 36, 49. Right? All right. Now comes the reduce function. It basically applies a rolling computation to the sequential pairs. That is, if we take a range of number, right, let's say from 1 to 5, the numbers that are included here is 1, 2, 3, 4, and 4, right? Not 5. So what do we get over here? We get a rolling computation of sequential pairs. It is rolled over to this is rolled over to this, and this is rolled over to this. We can do any kind of operations. So what I've done is I've taken the addition operation, right? So A here would actually add the two numbers. When I say rolling, it means it is taking into account these two numbers. And it would give me the sum, since I'm using addition, 3. Then it would actually roll over to this. So 3 plus 3 would give me, right, 6, I'm sorry, it would give me 6. And then it would do its rolling operation to 4, which would eventually give me a 10, right? All right. Now, one more important thing here, to use the reduce function, we have to import it. So we will be learning about it. Let us forget about this line as of now. So what we do over here is result equals to reduce. Use the same thing, reduce instead of map or filter. A, that is the function name, followed by the iterable. Iterable here is range from 1 to 10. That is, it takes 1, 2, 3, 4, 5, 6, 7, 8, and 9. It excludes 10. So what is the sum from 1, 2, 3, 4, 5, 6 up to 9? Just do your addition, it would be 45. And it works in this rolling fashion that I have already explained. So when I print the result, I'm getting 45 as the output, right? Now, to use the reduce function, one important thing that we need to do over here is we need to import the reduce function. How do we do that? We need to import it from Functools, a library called Functools. So we write from Functools import reduce, and then we can easily use this reduce function. All right. Now coming to one of the most important functions, zip and unzip. What does it do? So we would be understanding the zip function much more in depth, the usage, when we come to use the data science libraries like NumPy, right? So as of now, just understand what it does. It has a huge power. So the zip function returns a zip object, which is an iterator of tuples. What does it mean? Let's say we pass two lists, right? Let's say we pass two lists. Let it contain A and B, the first list. Let me call it as L1, right? L1 is equal to A and B. Let me take another list called L2, which contains 1 and 2. Obviously, these are numericals and these are, strings. Doesn't really matter. We can take two strings or two integers or whatever it is. I'm just taking this as an example. And if I zip, right, zip L1 and L2. Let's say A, right, A equals to zip L1 and L2. Do you know what the output we will be getting? So the output that we will get is A1, comma B2. And this would be inside lists. I'm sorry, this would be inside tuples. So we'll be getting a list of tuples. We'll be getting a list of tuples, wherein in each tuple, we'll get the first element from the first list and the second element, and the first element from the second list. So on and so forth. So this is the power of zip. You cannot use necessarily a loop or something to do this particular operation. You need to use this zip operation. If you think a loop would suffice, do try, and you are free to use it, but it is not possible. You would soon understand all the problems related to it. So zip is the function that we use to take the first element from both the list and pack it inside tuples. Okay. So that's what I have explained over here. What does unzip does? Unzip does the exact opposite thing. It unzips the master list containing tuples and creates two lists containing, it just reverses the zip process. That's what it does. So yeah, the basic syntax is zip of list1, list2, and for unzip, it would be zip, and we put this star mark over here and give the name of the superlist so that we get the zip function. So what we have done over here is I've taken names Rohan, Amita, Sushant, Pawan, and Kiran, and I've taken the marks to be 67, 34, 78, 85, and 65. That is their respective marks. Now what if I want to pair them up, that Rohan has got 67, Amita has got 34, and so on? We will be using the zipped function for that. So zip of names comma marks, and that is taken inside the zipped variable, and zipped list is converting them to a list. When I'm printing list, when I'm printing zipped list, I'm getting the output as Rohan 67, Amita 34, Sushant 78, Pawan 85, and Kiran is getting 65. That's what we have got. Now this was the zipped list, right? When I'm unzipping it, I need to give two lists because there are two lists that were zipped. So I'm giving them names and marks, and I'm writing the syntax zip star zipped list. And I'm also converting names and marks into lists. So names list equals to list of names, and marks list is equal to list of marks. And now when I'm printing them, I'm getting two lists one containing names and one containing their marks. So that is exactly how zip and unzip function works. So I hope all the four functions, that is filter, map, reduce, and zip, were very, very clear to you. If this is very, very clear, we will now move on to the list comprehensions. Not only list, we will be moving to the comprehension functions. We'll see different ways of comprehending. All right. So that was it for this lecture. Hope to see you in the next. Hello everyone. In this lecture, we'll be learning about comprehensions. Now, comprehensions are basically of two types: list comprehension and dictionary comprehension. So in the first place, what is a comprehension? It is nothing but an amalgamation of the data structures. We'll be using list and dictionary as the data structures here, and loops. So basically, a combination of data structures and loops forms the comprehension. While we use lines of codes in loops, we can use a comprehension instead, which is a one-liner code. So we'll be seeing how do we use that and what are their benefits. Now note one thing, for a beginner, comprehension might seem a bit intimidating, but that's really okay. Because as we move forward, trust me, you will be using comprehensions more than loops. So that said, let's understand each and everything in detail. So first, we'll start with the list comprehension. Now let's understand this through a problem. So our problem statement here is, we need to get a list of numbers which are divisible by 15. So this is something we have already done using the filter function, right? In the previous lecture. Sorry, it's filter, not fitter. Anyway. So Now, moving forward, we need to understand one important factor. Coding or programming is quite like mathematics. There is a simple problem, or a problem, not a simple problem, there is a problem, and we need to solve this, right? So, to solve this problem, it might be a simple or complex problem. There are n ways of solving a problem. Someone might take this particular route, another might choose this route instead, and someone else might want to choose this particular route. So it doesn't really matter which route you take until till you solve the problem, right? Similarly, this particular problem statement can be solved using n number of ways. So the first way was filter, that we have already learned in the previous lecture. We'll also see how we can solve this using loops. And again, we can also solve this using comprehension. Again, this can also be solved by other simple methods as well. So that is something you should note. And there is no problem that if you choose any other method. Personally, if this was a problem given to me, I would have gone with the list comprehension method. Someone else might like the filter method. Someone else might choose some other method. So it depends from person to person. It's okay until you get the result correct, right? All right. So moving to the problem, let's understand how we solve this one. So we have this dummy list containing numbers which are divisible by 15 as well as numbers which aren't. We have also taken another list that is a blank list called result. And now what we are doing is we are writing a loop for I in this list. If I is divisible by 15, please append this to the result list. Else continue. And by this method, we are getting all the digits or numbers that are divisible by 15, right? Now, what does list comprehension? Hope you understand this particular thing, how it works. It's pretty simple loop. Now, how does list comprehension work? So for list comprehension, this entire loop has been shortened to just one line of code. And this is the entire code. The total has been shortened to this just one line of code. Now let's understand how. So what I've done here is, I've taken result is equal to a list, right? Result is equal to a blank list. And now, instead of writing a loop and appending it, what I'm doing is, in this blank list, I'm writing this blank list will contain I. Now, how do we define this I? This I is all those numbers, right? Which are divisible by 15. That's what was asked to us. So how do we take it, right? Let me do it in a good manner. Yeah, so this is how it's done, right? So in this list, I'm taking I, rather all the I's which are divisible by 15. And how do we do that? We loop it through the list. For I in num list, if I is divisible by 15. Do you get it? So what we do, take I for I in this particular list, if I modulus 15, that is the remainder of 15, is equal to 0. In other words, if I is divisible by 15. So we take all the I's which are divisible by 15 in this particular list. And that is how we get the exact same list containing all the numbers divisible by 15. So I hope you get how the loop is turned into a single line of comprehension, right? For I in num list, so that's what I've written for I in num list. If I modulus 15 equal to 15, right? Result dot append I. So that's what I've done, I, right? Else continue. So it is taken into account by comprehensions. All right. Now, what if I wanted to add two elements, right? If I wanted to add two elements, not only one pointer I, if there were two pointers, I and j. So even that can be done using comprehension. So take this for example. It is asked that print a letter and number pair for each of the letters A, B, C and each of the numbers 0, 1. So what is essentially asking us to do is print something like this. A0, right, inside a tuple, then A1, right, then A2. No, A0, A1, right? That would be the thing. After that, B0, B1, then comes C0, C1, right? C0, C1. Pardon my handwriting. So that's something we should get inside a list. So let's understand how do we get it. So what I've done is I've taken a blank list, li, and I've taken two values in the form of a tuple, right? I, comma, j in the form of tuple. Now, what are these I and j? For I in ABC, so I should iterate from A, B and C, right? And j in the range 2. Range 2 means 0 and 1 in -1 if you remember how the range operates. So j would take the values 0 and 1. Now, if you understand nested loop, the concept of nested loop, we had already done that. Then you would understand that I is the super loop, right? The outer loop, not the super loop, but the outer loop. So for A, j would occur twice, 0 and 1, and therefore we will get the value A0, A1. Again, then I would shift to B, and we'll get the value B0, B1. Again, I would shift to C, and we get the values C0 and C1, and that's how the output has came out. A0, A1, B0, B1, C0, C1, right? If you did not quite understood this, let me use the loops and make you understand using the proper loop method. So let's say for I in ABC, right? That's what we have done. Print I. So we should get A, B and C, and that's exactly what we are getting. But we also have another loop J, right? Which loops from the range 2 up to range 2 for J in range 2, right? Now what we need to do is print I comma j, and here we get A0, A1, B0, B1, C0, C1. If you want it to be in the form of a tuple, simply put a tuple sign over there, and we just get in the form of a tuple A0, A1, B0, B1, C0, C1. So that's how we actually get this particular output. Now, if you want to also go ahead and add it inside a list, and nothing, we just need to declare a blank list as such, li equals to, and here we just need to do okay. So what we need to do is li dot append I comma j, right? Hopefully our problem will be solved, right? So that's the exact output that we are getting. So instead of writing this entire lines of codes, we could complete it using this one line. Okay. So hope you got the basic understanding of how list comprehension works, right? Now we'll be moving to dictionary comprehension. So what is a dictionary comprehension? Very similar to that of list comprehension. And let's then see how it operates using some examples. So what happens over here is we are required to find So get the dictionary of odd numbers that are present in the given list, that is this particular list, as keys and their values as cubes. All right, so that is quite an interesting problem. So basically this is a two-step problem. Step one, we need to figure out, or we need to filter all the odd numbers from the list, which would essentially be 1, 3, and 5, right? These are the odd numbers. And it should be contained in a dictionary where the keys would be these odd numbers and their cubes would be the values, right? 3 cube is 27 and 5 cube is 125, right? So this should ideally be the output. So let's see how do we do that. So the first thing that we do is using loops, and then we'll understand how do we do that using a dictionary comprehension. So what I've done is, for I in num list, if I %2 is not equal to 0, what does this mean? So if I divided by 2, when I divided by 2 does not give 0 as the remainder, that is, it gives some remainder, then only take the value of I, which is correct, because if I is divisible by 2, it becomes an even number and we are required to find the odd number. So odd numbers are those numbers which when divided by 2 leaves some remainder, and that is what exactly I have done. If I divided by 2 does not leave 0 as a remainder, that is leaves some remainder, then go forward. So what do you do then? Result of I, result is basically a dictionary. Remember, this is not a set, this is a dictionary. So result of I, that is I becomes the key then, equals to I cube. So this becomes the value then. And this is how we get the output. 1, 1, 327, 5, 125, right? Now this can easily be done using, so all these lines of code can be replaced by again a single line, which is this particular line. What does it say? So result equals to a blank dictionary, that's what I've taken. And inside it, I've taken I as the key and I cube as the value, right? And now I define what is I and I cube. And I cube I really do not want to define, because if I define I, automatically I cube is defined. I cube will be just the cube of I. Now what is I? I is for I in num list, that is for I in this particular list, if I modulus 2 is not equal to 0, that is if it is not even, if it is odd. And therefore we get the output, the same output. So we see that using comprehensions, we can actually perform all these loops. We can eradicate usage of long loops and perform them in a single line. So that is the power of comprehensions. Now one more important thing that we can do using dictionary comprehension. So let's say we got two lists, one containing the names of heroes, Batman, Spider-Man and Wolverine, and another containing their real names. So Bruce Wayne is the name of Batman. Similarly, Peter Parker for Spider-Man, and Wolverine's name is Logan something. I forgot his actual name. Anyway, so what we need to do is we need to create a collection, a dictionary, wherein the name of the superhero, that is Batman, let's say, would be the key, and his real name, that is Bruce, will be its values. Similarly, Spider-Man would be the key, and his real name, that is Peter, would be the value. Again, so on and so forth. So what we do over here, if you remember from the last sessions, we had learned the zip function. How do we zip two lists? Using the zip function. And when we do zip, we get a tuple containing the zeroth element, the zeroth indexed element inside a tuple. So that's what we'll get: Batman, Bruce. In the next tuple, we'll get Spider-Man, Peter, and so on and so forth, embedded inside a list, right? So exactly that's what I've done. Printed it using a dictionary comprehension, noted. So we'll understand why and how this particular list tuple combination is converted to a dictionary. So what I've essentially done, just forget about this. For this particular part, for I, j in zip, heroes, names. So it basically creates this particular data structure, tuples inside lists, right? And now I have embedded it inside a dictionary comprehension. I've used a dictionary comprehension, which is a blank dictionary containing I and j. For I and j in this, so I basically points to heroes, while j points to the names. And therefore, this dictionary comprehension in turn converts this tuple list pair into a dictionary containing all the i's as key, that is this as the key, and j as the names of the heroes. So I hope you get what I'm talking about. This particular I, j is a blank dictionary being converted into a dictionary comprehension, I, j. And what is all this i's and j in zip of heroes, names, that is like this. And now I is taking all the first values, while j is taking all the first values from the second values from the tuples. And this is how we get the entire list. The dictionary containing heroes as the key name and names as the values. All right. So this was all about comprehensions. And in the next lecture, we'll be learning about the inbuilt functions. These were all about custom functions. We'll be also learning about the inbuilt functions and a very important concept called recursion. Recursion is a very important topic, and we'll be understanding that in the next session. Right? I might have done some spelling mistake. We'll be checking the exact spelling in the next session as well. All right. So yeah, hope to see you in the next lecture. All right. Bye for now. Hi everyone. In this lecture, we'll be learning about the Python inbuilt functions. Essentially, there are two types of inbuilt functions. One is the aggregate functions, which again consist a lot of aggregations, and another is the analytical functions, which performs the analytical activities, right? All right. We'll also be learning about the recursions. Now, a basic idea on what recursion is. So recursion is a process wherein a function calls itself within a function. So till now, what we have learned is a function has some duties to perform, or maybe it has an aim basically. But sometimes it is also required for a function to call itself again and again. For example, if we are finding the factorial. So this is something which we'll be working on. So we'll get an understanding how recursion actually works. Now, usage of recursion helps us with minimalistic codes. We do not have to write long regions of codes again and again. So the amount of code lines is reduced by usage of recursion, right? So what are the basic advantages of recursion? First is that recursive functions make our task look very clean and elegant, because it we will be actually understanding how elegant it makes our function look. It also can, a complex problem can be broken down into simpler versions of subparts, which together make the particular complex problem. So these are some advantages that recursion brings. Now, there also are some disadvantages. Everything has their own pros and cons. Well, for recursion, the function sometimes becomes really difficult to follow, especially for beginners. So with usage of, in the beginning, you might find it literally challenging. But with time, I can assure you that it would become something you would like to use. And one important thing is it becomes really hard to debug. And trust me on this, even at a stage when you will have learned a lot, you will be using Python a lot, you will still find it hard to debug. This is some problems that even experts face. So yeah, that said, let's understand what recursions generally do. As I said, a factorial. I think most of you know what a factorial is. So let's say, what is the factorial of, let's say, 3. This is how we represent factorial. It generally means 3 into 2 into 1, which gives us 6. Right? So in general, n factorial means n into n minus 1 into n minus 2 into n minus 3 into n minus 4, and it goes on. So it goes on and on until it reaches a stage where it becomes 1. That is, how does it actually become 1? N minus 1, which actually gives me 1. N minus n plus 1, which gives me 1. So the last item that has to be there is 1. As I got the example, 3 into 2 into 1. Even let's say I give you another example, 4 factorial will be 4 factorial will be 4 into 3 into 2 into 1. Got it? So this is how we do. Again, 4 factorial can also be written in the form, if you see this part, 3 into 1, 2 into 1 is equal to 3 factorial. So 4 factorial can also be written as 4 into 3 factorial. In short, n factorial can also be written as n into n minus 1 factorial. This is the entire concept of factorial, right? And that is what I have actually visualized over here. N factorial is equal to n into n minus 1 into n minus 2 and so on. Or n into n minus 1 factorial, or n into n minus 1 into n minus 2 factorial. And so on it can go, right? Even one thing you should note over here, when we are writing 1, it is basically 1 factorial. And as we know, 1 factorial is equal to 1. As I said, the last term should be 1. So 1 factorial is equal to 1 into 1 minus 1 gives me 0. So no other factorial, therefore 1 factorial is 1. And that is the case, right? So if you see this problem over here, how do we use recursion? So our problem statement was find the factorial of a number using recursion. So I've taken a function, def factorial is the name of the function. You can give anything. Again, you can give any abrupt name as well. Let's say you can give def, pizza. You can give anything. So this is the name, but to make it realistic, I've given the name factorial. So yeah, def factorial, and the argument I've taken num, right? So def factorial of num. So while calling, I would be calling factorial of any number, and this function should give me the factorial of that particular number, right? Now let's understand what is happening over here. So if num equal to 1, that is, so let's take the example of 3 factorial, right? 3 factorial is equal to 3 into 2 factorial, right? Which is again equals to 3 into 2 into 1. So if num equal to 1, that is when it becomes 1, return 1. All right. Else, that is, if num is not equal to 1, till rather, num is not equal to 1, return num into factorial of num minus 1. So what does this mean? Let us work this through. Factorial of 5. So what it would do is, factorial of 5, it would check if num, that is 5, equal to 1. It is not equal to 1. So it would not return 1. It would go to else, right? So else, return num into factorial of num minus 1. So what it would do is, it would say, okay, so I give 5, that is num, into factorial of num minus 1. That is, I again call the function factorial. Here factorial means the function factorial, right? So it says 5 into, again it calls the function, but this time num minus 1, that is factorial of 4. So if num equals to 1, now this is 4, but 4 is again not equal to 1, therefore it goes to the else part, right? And else it prints num into, now num is 4, into factorial of num minus 1. Now again it goes here, 4 minus 1 is 3 right now. First it went with 4, then 3 is going there. Now is 3 equal to 1? Not really. Then again it prints 3 into factorial of num minus 1. Num minus 1 becomes now 2. So if 2 equals to 1, is 2 1? No. It again goes over here and num is printed into factorial of num minus 1, that is 1. So 1 goes over here. Now if num, that is 1, equal to 1, is num 1? Yes, num is 1. So return 1. So this is what it returns, right? And let's calculate the value. 5 into 4 gives us 20, into 3 gives us, 5 into 3 gives us 20, and into 3 it gives us 60. 60 into 2 gives us 120, and 120 into 1 gives us 120. The answer should be 120. And that is exactly what we get. So this was all about recursion and how it works. Now let us move to the lab session to learn a bit more about recursion. But before we move there, let us also understand another problem using recursion itself, which is the Fibonacci series. So for people who are not acquainted with the Fibonacci series, it is nothing but a sequence wherein each number is the sum of the two preceding one. So what does it mean? The first two numbers are taken as 0 and 1, right? The next number should be the sum of the first two. So what is the sum of 0 and 1? 1. The third number becomes 1. The next number is the sum of the preceding two. So this number should be the sum of this two, which is 2. Now the next number should be the sum of this two, that is 3. So the next number should be the sum of this two, which is 5. Similarly, this becomes 8. Now it becomes 13. Now it becomes 21. Now it becomes 34. And so on. It goes like this, right? The next number should be the sum of this particular two. This is exactly what Fibonacci series does. So let's take an example over here. So Fibonacci series, that is f of 5 equals to f of 4 plus f of 3, which is equal to 2 plus 1. How do I get it? This is 0, this is 1, this is 2. Like that this moves. So f of 4 is basically 0, 1, 2, 3, 4. Sorry, for Fibonacci series, it starts from 1. I just confused with the indexing. This is not about indexing. This is the first number, right? First, second, third, fourth, fifth, sixth, and so on. So f of 4 is 1, 2, 3, and 4. This. F of 3 is this. So f of 5 will be f of 4 plus f of 3, that is 3. And this is f of 5. Similarly, f of 4 equals to f of 3 plus f of 2, which is 1 plus 1, which is 2. Similarly, f of 3 is f of 2 plus f of 1, that is 0 plus 1 is 1. And that is how Fibonacci series goes on. So in general, how we can define a Fibonacci series? This is basically f of n equals to f of n minus 1 plus f of n minus 2, right? That is exactly what I have done. F of n, if this you want to call it as n, then this is n minus 1 and this is n minus 2. So what we can write is f of n equals to f of n minus 1 plus f of n minus 2. And that is exactly what a Fibonacci series is. So this is how a Fibonacci series looks like, right? One important aspect of Fibonacci series is f of 0 should be equals to 0 and f of 1 should be equals to 1. So these are the base cases, because if we do not take any base case, how will n move? Because for n to be defined, n minus 1 and n minus 2 needs to be defined, correct? And if n minus 2 is defined, then n minus 2 should be at least the least number, which in this case is 0. Therefore, this becomes 1. And f of n can take the value to start with 1. And so on it moves. So basically f of 0 and f of 1 should be defined, which should take f of n minus 2 and f of n minus 1 respectively. Now coming to the problem statement, which says, okay, let me just rub everything off. Yeah. So it says, find the Fibonacci series using recursion. Now, I've taken again the name as Fibonacci and given a number, num as the parameter or argument, whatever you want to call it. If num less than equal to 1, which means num can be 0 or 1. If num is less than equal to 1, that is if num equal to 0 or num equals to 1, return num. So please, if the digit is 0 or 1, please return them. Else, if they are not equal to 0, if they are greater than 0 and 1, that is if they are greater than 1, return the function Fibonacci of num minus 1 plus Fibonacci of num minus 2. Precisely before moving forward, one important thing that we should realize is this is exactly what the formula has been derived, right? So Fibonacci of n of num is equal to Fibonacci of n minus 1. Fibonacci of n minus 1 plus Fibonacci of n minus 2. Fibonacci of n minus 2. That is exactly what we have defined, and this is how recursion works. Why this cases has also been defined? These are the base cases, that if f of 0 or f of 1 occurs, you should return 0 and 1 respectively. So due to this, we have actually defined this if condition. Other than that, this is exactly as the formula we have derived. So do you understand how easy the code becomes, or how easy the code looks? As I said, it looks elegant. The term elegant aptly comes over here, right? Now, if people wants to understand how it is working, so let us take an example. Let's say Fibonacci of 5, right? So what it would do is 5 less than equal to 1? No. Then please return f of n minus 1, num minus 1 plus Fibonacci of num minus 2. That is Fibonacci of 4. That means Fibonacci of 5 equals to Fibonacci of 4 plus Fibonacci of 3. Right? Now, Fibonacci of 4, what would it become? Okay, I will need some free space over here. So let me write it over here. So f of 5 equals to f of 4 plus f of 3, which is equal to f of 4 is equal to f of 3 plus f of 2, right? And f of 3 will become f of 2 plus f of 1. And so on and so forth will it keep on going, right? So this is exactly how Fibonacci series is defined. If we keep on breaking it, there will be coming a stage wherein we will only get f of 0 and f of 1. And by adding all the 1, we will get the required number, f of 5. If you want to see this, let me complete this, what I have started. So f of 3 would be f of 2 plus f of 1, right? Or let me do a simplification, if that helps. So there is f of 3, there is 2 f of 2, and there is f of 1. And f of 1, we know that when num becomes less than equal to 1, we return num, right? I hope you're understanding. If you're not, let me quickly make this clear once more. When we are taking Fibonacci of num, let's say we are taking Fibonacci of 5, right? So by the program, num is less than equal to 1, is it? No. Then it goes to the else part. Fibonacci equals to Fibonacci of num minus 1 plus Fibonacci of num minus 2. That is Fibonacci of num minus 1, which is f of 4 plus f of 3. Now f of 4 will again Fibonacci of 4. This is not equal to 1. So it would return Fibonacci of num minus 1 plus Fibonacci of num minus 2, which is f of 3 plus f of 2. And let me keep f of 3 as it is, although it would also break, but I just want to simplify things. So I'll work it on the next step. So now what do we get? We get 2f of 3 plus f of 2, right? Now f of 3, is it equal to 1 or less than 1? No. So it goes to the next step, that is Fibonacci of num minus 1 plus Fibonacci of num minus 2, which is 2 into, right, Fibonacci of 2 plus Fibonacci of 1. Correct? Plus this Fibonacci of 2 also comes into place. So what do we get? On simplifying, we get 2f of 2 plus 1f of 2, that is 3f of 2 plus 2f of 1. Now, this is something we will be simplifying, but before that, let's talk about f of 1. What is f of 1? So num, is it less than equal to 1? Yes, it is equal to 1. So return num. That is, f of 1 becomes 1. So this translates to 2. 2 into 1, right? Which is 2. So we get 2. Now we need to work with 3 into f of 2. So what is f of 2? F of 2, it is obviously not less than equal to 1. So it takes f of num minus 1, that is f of 1 plus f of num minus 2, that is f of 0. Now working with f of 1, we know that f of 1 is num here is equal to 1, therefore return num, that is it is equal to 1. Also, when it is less than 1, still it returns num. So num here is 0, it will become 0. That is f of 2 is basically 1. So for 3 into f of 2, we get 3 into f of 2 is basically 1. So 3 into 1, that is 3. So this gives us 3. So this gives us 3, this gives us 2. 3 plus 2 is 5. So Fibonacci of 5 should be 5. Let us check. This is 1, this is 2, this is 3, this is 4, this is 5. So there has been some discrepancy over here. Okay, no. Again, I made some mistake. So when I said f of 0, so 0 is the 0th term, right? This is the 0th term. This is the first term. This is the second term. This is the third term. This is the fourth term. And this is exactly the fifth term. Therefore, f of 5 is equal to 5, which makes perfect sense. And that is exactly what is said over here. Fibonacci of 5 is 5. So that is exactly what we get. So behind this recursion, behind this return Fibonacci of num minus 1 plus num minus 2, all these particular operations take place. And this is the last part where I have taken a range to print all the Fibonacci series up to 9. We have taken 10 terms, so it starts from 0 to 10. We'll be seeing this in the lab session as well. So I hope the working of recursion is a bit clear now. So now let's head on to the lab. So before moving to the inbuilt functions, let us first work with the recursive functions. And then we'll head back and move to the analytical, the inbuilt functions. So these are exactly what we have learned. What is recursion? What are their advantages and disadvantages? Now, this particular problem, when we say factorial, so if num equal to, this is what we have actually learned. We have set the boundary condition, return 1, else return num into factorial of num minus 1. We have exactly gone through this problem, how it works, and this is just the lab. So let us take a different number now. So let's, for example, we take factorial of, let's say, 6, right? Or let's say we take the factorial of 4. So it gives me 24. Now let us check, is it correct? So factorial of 4 is 4 into 3 into 2 into 1, which gives us 12 into 2, that is 24, which is what it gives. So therefore exactly correct. Now moving to the Fibonacci series. I hope up to this was clear. This is how the Fibonacci was exactly operating. Now, in order to get the series for 10 terms, what I have done here is I have taken a variable with 10 as the number, included in it. And now what I've done is for I in range of terms. So basically for I in range of 10, that is, it should take from 0 to 9 terms, print Fibonacci of I is. So I, okay, let us understand this again from step by step. So for I in range 10, print I. What do we get? From 0 to 9. So exactly that is what we are getting. Fibonacci of I is. Fibonacci of 0 is, Fibonacci of 1 is, Fibonacci of 2 is, up to Fibonacci of 9 is. That is Fibonacci of I. Now Fibonacci here is the function name. And Fibonacci of I will always compute the Fibonacci of ith element. So Fibonacci of 0 is 0, 1 is 1, 2 is 1, and so on. As we learned, for 5 it was 5. So let me quickly compute up to 9 terms, right? So this is the 0th term, this is the first term, this is the second term, this is the third term, 0, 1. Let me again do it. This is the 0th term, this is the first term. The second term would be sum, that is 1. The next term would be 2. The next term should be 3. The next term should be 5. Next term 8. Next term 13. Next term 21. Next term 21 plus 13 gives me 34, right? And next term should be 55. So let's check how many terms have we done. This is the first term, second term, third term, fourth term, fifth term, sixth. Again, I'm making the same error. This will be the first 0th term. This is the first term. This is the second term. This is the third term. This is the fourth, fifth, sixth, seventh, eighth, ninth, and the 10th term. So the factorial of 0th term is 0, correct. First term is 1, correct. Second term is also 1, that's what we have got. Third term is 2. Fourth term is 3, yes. Fifth term is 5, yes. Sixth term is 8. The next is 13, next is 21. The next is 34. We have taken the range to be 10, so it gives us up to 9 terms. And 34 was the last term. So this is exactly how it goes. I hope the working of recursion and Fibonacci series is clear to you guys. Now this, if clear, we'll just move to the inbuilt functions in Python. So there are basically two types of inbuilt functions that Python contains. One is the aggregate functions and another is the analytical functions. So aggregate functions consist of max, mean, sum, mean, median, and mode. All right. So let us see their working. So I've taken a list and I've added these functions. So when I'm taking the max function, print max of list 1. What it does is it searches for the maximum digit amongst this list, which is 9 in this case. So that's what it has printed. The main function prints the minimum. So 1 was the minimum over here, right? There were 2 ones. Sum computes the sum and returns them. So the sum is 3 plus 5, 8, plus 7, 15, plus 9, 24, 2, 26, plus 1, 27, plus 1, 28. And that is exactly what we have got. What is the mean? So for mean, median, and mode, we need to import another function, another library. This is statistics library. So what I've done is import statistics as S. Now instead of writing statistics all the time, I can just write S dot something. So mean is S dot mean of list 1. So what is mean? Mean is the average. We already found the sum to be 28. How many terms are there? 1, 2, 3, 4, 5, 6, 7. So 28 by 7 gives us 4. So mean should be 4. That is exactly what we have got. What is median? Median is when you arrange this list in ascending order. So it would be 1, 1, 2, 3. Let me also cut when I'm writing 1, 1, 2, 3, 5, 7, 9, right? So 5, 7, and 9. Now median, when you arrange this list in an ascending order, median would be the middlemost element. So in this case, there are 7 elements, 1, 2, 3, 4, 5, 6, 7. So this is the middle element. And this should be the median. The median is 3. That is exactly what we needed to get. Now, one quick understanding that you should have for people from non-mathematical background, what should be the median if the number of digits is even. Here, since it was odd, we found the middlemost element. Let's say we had, let's say 7 over here. It cannot take 7. Okay, let's take be a 11 over here. In that case, what is the middle term? Both 3 and 5 are middle, right? So in that case, what we do is, we take the average of the two middle elements. That is 3 plus 5 by 2. So it should be 4. So that's how median is computed. Now what about mode? Mode function, the function mode, gives you the element that occurs the maximum number of times. Here all the elements occurs only once. Only one has its occurrence twice. Therefore, mode is 1. So these were all the aggregate functions. Now coming to the analytical functions, there are basically 3 analytical functions. First is the eval. So what is an eval function? The eval function is basically evaluation function. It evaluates the string like a Python expression and returns the result as an integer. So what we have done over here is, I've taken x is equal to 3, and now when I'm writing eval, I'm giving a string, right? Since if you check it, I've given an apostrophe, which means it's a string, but still it would evaluate it as an integer. So x square, that is 3 square, gives us 9 plus 2 into x, that is 2 into 3 minus 2. So our answer should be 9 plus 6 minus 2, which is 13. And that is what eval function does. Now coming to the len function, we have come across this particular function a lot many times. It finds the number of elements there are. So in this list, how many elements are there? 1, 2, 3, 4, 5 and 6. So the length is 6. Again, we also have a factorial function. Factorial is what we did using recursion. But we already have an inbuilt factorial function. For that, we need to import the library called math. So what we do is import math and f equals to math.factorial of 5. So now f would give me factorial of 5, which is 120. If you quite did not understand this, think of it like this. So when I first need to import math, right? Next, what I need to do is math dot factorial of, let's say 5. So it gives me 120. So instead of using recursion, we could have also used the inbuilt factorial function. But that doesn't really mean that recursion is not important. Recursion, we only saw the Fibonacci series, and there are tons and tons of usage of recursion function, which we'll be understanding as we move ahead with the course. So that was all about functions. We learned about all the sort of functions, both user-defined functions, inbuilt functions, and the special functions, anonymous functions, and recursion as well. So yeah, that was the end of functions. The next topic would be object-oriented programming, the introduction to classes. All right. So hope to see you in the next lecture. Hi everyone. Welcome to this lecture on OOPS, or object-oriented programming. So OOPS stands for object-oriented programming. Now there is a lot of buzz surrounding this particular terminology, So let us understand what it exactly means through some easy examples. So let's assume there is a company wherein a lot of employees work. So let's say the name of the employees be A, B, and C. And there would be hundreds of more. Now, each of them should possess some attributes. Let's say educational qualification, right? Their skill sets. Let's say their demographics or expected salary, right? Or just the salary they are deriving from the company, and there might be hundreds of more. Now, each and every time employees entering this particular firm, it becomes really difficult to enter all their details manually, right? Because there might be hundreds and thousands of employees in a big firm. So creating all this, and there might be hundreds and thousands of attributes or parameters as well, right? So creating all these parameters in a manual manner, like A. So A has educational qualification, this, skill sets, this, salary, this. Even if there are only 3 parameters, creating these 3 parameters for all the employees, where the employee count might be at least 10,000 to, let's say, 1 lakh. It's really difficult, right, for a big MNC. So what we usually do is we create a class. Class is the outcome of an OOPS programming, right? So what we do here is, so don't worry, we'll learn about classes and instances, everything. So what we do is we create this class, which is basically a blueprint or a framework, wherein A would have a matrix-like thing, wherein all the parameters, let's say education qualification, skill set, and everything would be pre-filled. Only the values needs to be filled. So now this can be filled manually if you want. Again, manual tasks are a bit difficult. So this can be automated as well. So what happens is, whenever, let's say, D joins, so let's say the company contains 3 employees, and now D joins. So while joining, D would be asked to provide the following informations, let's say his educational qualification, skill set, and the expected salary, right? And a matrix would be created for D, wherein all the parameters are pre-filled, and based on the values that he has entered, the values here will be pre-filled. Sorry, it will be post-filled once the function is run, right? So this is how class works. So instead of manually doing everything for hundreds and thousands of employees or persons, it can be done in a whisk of an eye through the help of machines. So this is the power of object-oriented programming. So now let's understand the parts and parcels of an OOP. So the first thing that we learn about OOPs is classes. So what are classes? Classes are basically logical entities that acts as a prototype or a blueprint of objects. We'll understand how the structure of class is, how do we do that in the next couple of slides. But as of now, just understand class is nothing but a blueprint of objects. Now, what are objects in a class? These are nothing but collection of variables and functions. They are also called as instances. And this particular process of creating instances is also called as instantiation. Right? Now coming to the advantages of classes, as I already mentioned, it helps us to maintain an organized data keeping structure. And again, reusability of code is maintained. So we do not need to create the codes again and again for each and every individual. we need to create a blueprint and add all the details of the next couple of employees or whatever it is in that particular blueprint. In this way, there is a high reusability of the code, and the code structure, the space is shortened as well. Now the rules or the process that how we create a class, right? So the first thing that we do is we define a class by this particular word or the keyword as class. So here what I've done is class and then followed by the name of the class. So here the name of the class is person, followed by an inverted comma. So that is what we do. After that, this inverted comma, I'm sorry, this is not an inverted comma, this is a colon, and this colon marks the end of the class header. So now we have already created the class header. Class person or class your name, the whatever name you want to put, followed by a colon. Then give the class body. So here what I've done is I've given a variable age equals to 25. That's all. You can write functions, you can give other variables, whatever you want. So this is how class is done. Nothing but the word class followed by the name you want. So let's say I give the name as, let's say anything. Let's say I take the name as name, followed by colon, which marks the end of the header, and then give the body. Here lies the body. So this is what a class is. After that, we call the class. But before calling, we also need to create an object. So here what I've done is I've created an object called Nikhil. Nikhil is equal to name of the class followed by a braces. So here for this particular class, let's say the object that I called is, let's say Harry. So Harry equals to name followed by braces. So now Harry would have all the features that you have declared for this particular class called name. And this is how the things actually work. Now also understand how we call the class. Now while calling the class, what we need to do is we just need to write Harry dot the object that we want to print. So here what we have done is we have called an object called age equals to 25. Now what we do is we write print Nikhil dot age, which gives me the age 25. Now if we also write person dot age, person was the name of the class, we also get the same output 25. So how do we call the object? Either call the name of the class dot the name of the parameter that you have given, here age, or you instantiate an object with the class and call it by the parameter. Now one big question that might arise is, why do we even need to declare this Nikhil equals to person? We can easily call person dot age. So why do we need to do that is, here I have not declared any argument, right? As I said, the employees, as the example that I gave, the employees might have their own skills parameters. Say for example, education qualification, skill set, and salary. And in that case, you cannot define them. This would be different for all the employees, right? A would have some different educational qualification, B would have something else, C would have something else. So in that case, you need to write A equals to person and give the details, B equals to person and give the details. And that is how you need to do. And now when you want to call A's details, what you write is A dot age, B dot age, and like that, it works. So don't worry, we'll see examples of that too. All right. Now, one important thing is the init method. Yeah. So the init method is nothing, but it's used for initiation. So in the previous example, we never used any arguments with the function itself, right? Now, as I said, let there be a class called employee. And I need to call, so there are two employees. The first one is Nikhil Dubey and the second one is Yatharth Raman. Now, this is how a real life class looks like. You will have different employees for the class employee, each having different arguments. And how do we define that? So we create the blueprint as a function def followed by underscore underscore init underscore underscore, and then we write the name of the arguments that we want, right? So here what I have used is first, comma, last. But if you see closely, there is another word called self before first. So what is self? Self is nothing, and mind you, you can use any other word that you want, but for simplicity and for the understandability of everyone, like args and quirks that we have done in functions, we use the word self over here. So self is nothing, but it tells the program that this is used for this particular function. So whatever arguments you want to give, just understand in this way, whatever arguments you want to give, use this particular keyword called self at the beginning. Again, this is not a keyword, but this is something to make the code realize that this is for this particular class. So if you see, I've also mentioned self.first is equal to first, self.last is equal to last. So this is something we have to do all the time while explicitly describing what the arguments are. Now, how have we defined it? Init, self, first and last. Now we need to describe what first means. So self.first, which actually makes the program understand that first for this particular class should you take from this particular argument. Self.first is equal to first. Self.last is equal to this argument, last. And self.email, this is a custom made thing. So I've used an F string, first dot last @company.com. So this is self.email. Now what I've done is I've taken objects. So emp1 equals to employee Nikhil, Dubey. emp2 equals to employee Yatharth, Raman. Now what I've done is print email employee1.email. So employee1.email. So what now it would do is, as I said, self.first. It is taking this Nikhil here, the first argument that you have given, Nikhil. Now Nikhil.last. So last is Dubey over here. So Nikhil.Dubey @company.com. And that is the exact output that you have got. Same goes for employee2, Yatharth.Raman @company.com. So this is exactly how the init method works. It might be a little overwhelming at this point of time. Trust me, while practicing, you would understand. And we'll also have some practice sessions as we move to the lab session. So you would have a genuine overview of what it is. Now, the self parameter, right? The self parameter is used inside the init method, and it is a reference of the current object. As I said, it is the reference of the current object, current class, and is used to access the variables of the class. So self is used to access the current variables of the class. As I said, self.first is equal to first. All right. Now coming to one last important type thing is variables. Although I have already made you understand what variables are, we should also understand how many types of them are there. So there are mainly two types of variables: the objects or instances that we call, and the class variables. So object variables are nothing. These are unique for different instances. We'll come to that in the lab sessions. You will have a genuine and bigger understanding when we do things live. And class variables are nothing but same for all the instances that are described. So let's, for example, understand over here. These are basically this emp1 and emp2 are basically object variables. And class variables is something that is true for all the variables that are declared. We'll come to that. So let's now move to the lab session to understand things. So as we have already mentioned what class is and objects are. Now starting with the basic things of a class. This is the example that we used. So I hope you understood this particular example. I've taken a class person, his age to be 25, given the object as Nikhil equals to person. And now when I print person.age, that is person.age, I get 25. Also when I print Nikhil.age, I get 25. This Nikhil is nothing but an understanding of what the person class is. It's just an object calling this particular class. Now coming to the main thing, which is init method. And mind you, when you start using classes, it's fairly all the time you'll be using this particular init method. So we have understood this example as well, right? Now let's deep dive into what it actually entails. The first thing is creating a class. So here we'll understand how to delete an object that we have already used, an object property, right? So what I've done is I've created this particular class. Let me grab my pen real quick. Yeah. So this is basically the object class, the employee class, and I've declared the same things, the first name, last name, along with the email. Now I've also created the two classes, Nikhil Dubey and Yatharth Raman. So this is the structure that we do. Now one important thing is employee1 dot underscore underscore dict underscore underscore. So what does this do? Dict tells you what are the what are the contents present inside this particular object, employee1. So when you've declared employee1, what are the contents present inside this is what dict function does. Mind you, you use the dict function as object name, right? Dot underscore underscore dict underscore underscore. So that's what I have done. So let's see what is the output that we are getting, right? First is Nikhil, last is Dubey, and email is nikhil.dubey@company.com. So these are the exact outputs that we are getting. Same for the second employee. So same for the second employee. First is Yatharth, second is last, and next is, first is Yatharth, last is Raman, and email is yatharth.raman@company.com. Now let's think this way, that we want to delete the email ID for the employee1. So what do? You write the keyword del followed by employee1 dot the parameter that you want to delete, and here it's email that I want to delete. So del employee1 dot email. Now when I print employee1 dot dict, see the difference. This email part has been removed. It's no longer there. While the second employee2 dot dict, it has the email part, since no change has been done. So when you have declared something in a class, right? When you've declared something in a class, it might be so that you want to include all the different parameters that you want. But it might be again that for a particular employee, you do not want certain parameters to be shown. And in that case, what you do is delete them. So that's exactly what I've done. Since I do not want the email ID of employee 1 to be shown, I've deleted that. But for employee 2, it is now still visible. And let's say there are 100 more employees. For them too, the email ID would be shown. Only for employee 1, it has been deleted. That is how we delete something. Now, one important aspect of classes is that the init method is called every time an object is created. What do we mean by that? So every time this object has been created, right, it goes through the entire loop of class to create this particular dictionary. Again, when employee 2 is created, it undergoes the entire class to create this particular dictionary. Now I've said this something. How do we prove that? So what I've done is a simple thing. I've created a variable called number of employees, which initially I've given 0 because there is no employee present. And after this function, as I said, when I create this employee, it undergoes the entire class. So after it undergoes the last function, I've also written employee.number of employees, this particular element, to be plus equal to 1. That is, it should be increased by 1 each time this class is called, right? More so, this function is called. Now we see when I've printed the employee.num of employees at the first, it gives me 0, which makes sense because no employees had been declared before this, right? Now at the last, after creating 2 employees, when I do this, I see the count has increased to 2, which gives me the idea that each time an employee is created, it actually goes through the entire class, all the functions included inside it. So let's check it once more. What we do is I create another employee. So let's say employee 3 equals to, let us give the same name itself, or if you want to change it, let's say Yash Goel. And now, as we see, the employee count has changed to 3. And this is how it goes. So in general, the theory is each time an object is created, it undergoes the entire class through all the variables that has been declared, and then moves to the creation of next object. And that is the reason it keeps on increasing. Now, what if you want to create multiple functions, right, in a class? So the first function that we do is we use the full name. For the second functions, we use this particular keyword self that we had already declared. So as I said, self is what? Self helps you to make the code understand that this is an inclusivity of the class employee. So the next time that we print any functions as such, we use the keyword only self, unless any other value or variable is to be declared. Let's say here we had to declare another variable, then self comma that particular variable. Otherwise, self would suffice. Self is just to maintain that this is a part of this particular class employee. So let's understand what we have done over here. This is the common thing that we have already done. Now, the second function that I have done is full name. So for full name, I have done self and self.first, self.last. So it would give me the entire name, Nikhil Dubey. The next thing that I have done is apply raise. This is a function wherein what I have done is self.pay. So there is another variable that I have included pay. So self.pay equals to self.pay into 1.05, which means an increase of 5% in the pay. Now, so each time this apply raise is called, the self.pay, the pay value would be increased by 5%. So what it happens over here is, employee 1 is equal to employee Nikhil Dubey, 60,000. And employee 2 has the value of 50,000. Now at first, when we called, okay, this is something we are calling the first full name. So we are getting employee 1 dot full name is Nikhil Dubey. I think it's self-explanatory. But when I'm calling its initial salary, right? I'm calling employee 1 dot pay. So I'm getting the initial salary that has been declared over here, 60,000. Now when I'm calling apply raise, I'm getting the employee 1 dot pay to be 63,000, which is a 5% increase from the previous salary, right? What if I called it again? Let's say I called it again. What do you think would happen? See, it has increased by another 5%. And this would keep on happening as we apply raise. Because apply raise, so let me break it down step by step. Employee 1 dot pay initially was 60,000. Now, when we use the function apply raise, it comes over here. It sees self dot pay, which is the value right now is 60,000, right? So right now, the value is 60,000. And 60,000 into 1.5 gives me 63K. So that is what it has given me. Now when I again use the cell apply dot raise, it would come to this particular function and check for the self dot pay. Now the self dot pay value was 63K, and it needed to increase it by 5%, which is approximately 3,000 something, which gives me 3,150. So 63,000 plus 3,150 is 66,150. That is how the entire thing works. I hope I was able to make you understand, right? Now variables. The last thing that I wanted to make you understand was variables. So there are basically two types of variables, as I said, instant variables and class variables. So let's understand this. So the first thing that we do over here is, I've created a class employee, given a variable pay raise equals to 1.05, right? And then written the function wherein first, last and pay has been defined. Then, so mind you, in the previous example, I had explicitly mentioned the self.pay equals to the apply raise function to be self.pay into 1.05. This is something I had kept constant. Not necessarily it has to be constant. It can be variable as well. So this is what I have exactly done over here. I've taken a variable. And now each time I want to change the pay raise, I can change the variable over here and do not need to go inside the code to change wherever I want. So I've used the keyword over here, the function apply raise. So self.pay equals to self.pay into self.pay raise, which is 1.05, same. But now, since the code with time, with application in real world, it would be really big. So I need to create a variable so that the variable can be used, and changing is pretty easy. Just you need to change the variable. Now what happens is, so understand this particular part. I've created the three names as well, 3 objects. Now I move to the class variable. So class variable is what I do. The name of the class was employee. Now what I do is employee.pay raise. Pay raise here was 1.05. Now what I need to do is I want to change the pay raise. There are 2 ways. I can change it from here only. But this is not something that I want to do. Why? Because, this is a very short code and you can check by looking, you can change it. But when you move to practical real world examples, you get really lost. Where is this particular variable located? And necessarily you do not want to change any code as such. That is considered as a bad practice. So what you do is you update the code, and that is exactly what I have done. I've updated the pay raise. So what I've done is employee.pay raise equals to 1.1. That is a 10%. Instead of 5%, let's say the company was doing well and it wanted to pay all its employee a 10% raise. So it has done an updation to be 1.1. That is a 10% raise. Now understand, I have used, instead of self, I've used employee.pay raise. What it means is the entire 3 objects, right, would get the particular pay raise of 10%. But what are instant variables then? This was a class variable. So what are instance variables then? Instance variables are only when you want to change, you want to have different pay raise for different employees. And in that case, you use employee1.pay raise or employee2.pay raise or like that. And what I've done is employee2.pay raise equals to 1.2. Now when I print, so when I print for the employee.pay raise, I get 1.1, which is evident. Now when I print for employee1.pay raise, I get 1.2. Again, which is evident because I had explicitly mentioned that employee1.pay raise should be 1.2. But for employee 2 or employee 3, I get the same pay raise, 1.1, which has been declared by the class variable. So in short, when you declare a class variable, it follows for all the objects that are created. Had I not created this employee1.pay raise, I would have got the same output all throughout. But since I created this particular employee1.pay raise to be 1.2, I'm getting this particular change. What if I also wanted to change this thing for employee, let's say employee 2, and let it be 1.5, a 50% pay raise. So I would get for employee 2, I'm getting 1.5. So this is the basic difference of class variables and instant variables. For class variables, it's a generic thing that applies to all the objects until you have declared something explicitly for any of the given objects. So hope you understand. This is exactly what I've explained over here. Now, this particular thing have been applied to a real world example. So what if you wanted to give an increment by the, this is the same code that I've already explained over here. The only change over here is this, instead of self.pay raise, what I've done is I've used employee.pay raise, nothing else. So what it does is the pay raise would be increased by 1.05, right? For all the given employees, When it's changed to 1.1, it would change for all the employees again. So see, that is what is happening. Initially, their salary was 50,000 for all. That's what has been printed. And now, when I called the function apply raise for all the employees, the next salary that I get is 55,000 for all, a 5% increase. A 10% increase, sorry, since apply raise has been increased. Here also I have used that employee1.pay raise to be 1.2. However, it is having no effect. Why? Because in this particular apply raise function, I had used employee.pay raise. Had I used, now the next example entails how can we change this particular thing. So I hope you understood. What I did was, for the apply raise, instead of using a constant, I have used a variable And that variable is not self, but employee.payRaise. Thereby, the result that we are getting is same for all the employees, even though I have explicitly declared employee1.payRaise to be 1.2. So let's understand if I print employee1.payRaise, I get the value 1.2. Still, it's not giving me a 20% pay raise, it's giving me a 10% pay raise. The reason is this particular function has employee.payRaise as the factor. Now, what if I really want a 20% pay raise for the employee one? What I do, the only change that I need to do is self.payRaise, nothing else. When I do a self.payRaise, although my employee.payRaise is 1.1, employee1.payRaise is 1.2, I get the distinct difference. See. Other than that, the code is same. I'll give you the code snippets for you to understand, for you to work through, for you to play around. But just as of now, understand what is the change that is occurring. For this particular example, for this particular function, I've used the factor employee.payRaise. Thereby, it's taking into account the employee.payRaise, which is 1.1, although I have mentioned employee1.payRaise to be 1.2. But in this particular case, when I'm mentioning the apply.raise by giving the factor self.payRaise, although I have mentioned employee.payRaise to be 1.1, and it is giving me 1.1, that is a 10% for the other employees. But since I have also explicitly mentioned that employee 1 should get a pay raise of 1.2, that is 20%, it's giving me the same thing, a 20% pay raise. So this was all about class variables and instant variables. It's, of course, a bit overwhelming. I'll hand you over the code snippets so that you play around with it, see the lectures and play around with it, and you'll get through practice, you'll get hands-on in this particular topic. So yeah, that was all about it. I hope everything was clear. Hope to see you in the next lecture where we will be going deep dive into classes. We'll be learning about inheritance, encapsulation, and everything. So yeah, bye. Hello everyone, welcome to the second part of object-oriented programming. Here we'll be learning some advanced topics like inheritance, encapsulation, and polymorphism. So what is inheritance? Inheritance, as we all know from the English term, is inheriting some properties from parents, right? Now, in respect to classes, what it does is it allows us to define a class that can inherit all the properties, all the methods and properties from another class. This another class from which the properties are being inherited are called as parent class. And this class that inherits is called as child class. So there are basically two classes, the parent class, the class being inherited from, and the child class, the class that inherits. All right. Now, let us create the basic parent class to begin with. So what I've done over here is I've created a class called employee, given the first name and last name, and its email address as well. Now created two objects, Nikhil and Yathar. And just for the simplicity, I've just printed the employee one name, the email address of employee one, and I've got the desired result. So this is the kind of program we have been dealing with from the past few time, So this was all about the parent class. Now, when we need to create the child class, the class that inherits its properties. So let's understand before moving forward. Let's understand. So a company per se might have different groups of employees, right? So there's a company. It might have different employees. Some of them might be administrators. Some of them might be managers, or managers, let's say managers. There might be some technical people or developers or someone. And there might be the people who clean, or let us call them janitors. For lack of better words, let us call them. Now, every single one of them are employees, right? But they might have different attributes to be defined in the company portal. For example, there is no use of defining the skill set, let's say the skill set of an admin in terms of coding languages, right? And for managers, it's not really useful to define they might or might not know any programming. So it doesn't really matter. So managers will have a different level of attributes that should be present in the company portal. Same for admins, same for developers or technical people, and same for the level 1 people. Right? So what we do in that case is we create an employee class, right? An employee class. And we have some basic framework in place. The most basic framework, we have them in place. Now, from employees, so employee now becomes the parent class. Employee will become the parent class. And from employee, we'll have a child, not but several child classes, right? Several child classes. One might be admin, one might be the managers, one might be technical, one might be the level 1 people, and so on. And for each of these child classes, they might have different attributes. Again, one child class might have several other child classes based on certain factors that depends totally on how big the company is and the hierarchy and everything. But the point of discussion over here is, it's very well possible that a company might have a basic or a general parent class followed by some child classes adhering to all the properties that the parent class has. And this child class might itself have some other attributes embedded into it, right? So what I've done over here is I've created a child class called developer. How do we do that? So let's understand. If you see over here, I've created a class employee, that's all. But now when I'm creating the child class, I'm creating class developer, and in braces, I'm giving the name of the super class or the parent class, employee, followed by the init method. This init method is totally dependent on this particular child class. So def init self, first name, last name, and the programming language that I might want to select. Now, here if you see, this init was only one line. But for the child class, it should also have another init class, which is called super. Super followed by braces, dot init, followed by the properties that I want to inherit from the parent class, right? So what exactly did I mean was, I create the child class with class followed by the name that I want to give, followed by the name of the parent class that I want to inherit from. Then I give the init method. This particular init method is everything related to this child class, followed by a super statement, super.init, followed by the attributes that I want to inherit from the super class, which is employee over here. Super class or the parent class, whatever you want to call it. Did I make this thing very clear? So this is a compulsion. This is the very basic thing that you have to do. Now you move to the body of the class and you create everything that is required. So self.email equals to, so the company might have different email IDs structure. For developers, it might have a different email structure, and for managers, it might have different employee structure. So here the email becomes first.last@developer.com. Right? And I've also mentioned the programming language, since this was another parameter that was included only in this particular child class developer. So I've also mentioned self.programming language equals to programming language. Now, these two employees, employee 1 and employee 2. Now, closely observe. The first employee has the employee as the class. That's the reason I've written inherited from employee class. So it would not really have the third parameter, that is programming language. While the second employee, that is employee 2, is taking the parameters from the developer class. That's why I've mentioned developer class followed by first name, last name, and the programming language over here. So this is created in developer class. Now, when I print employee1.email, guess what the email ID would be? This would be the very first email ID @company.com. Why? Because it's the same structure of employee. That's exactly what we get. nikhil.dubey@company.com. But for the second one, right? For the second one, employee 2, I get the second type of email address @developer.com. This is exactly that we get @developer.com. And I've also written employee 2.programming language. So Python was given and Python is what I'm getting. So I hope this difference is clear to you. All about inheritance. The parent class and the child class. The child class only inherits things from the parent class and might have its own other attributes. That is exactly what we saw over here. All right. Now, coming to this next topic, that is encapsulation. So what is encapsulation? Again, encapsulation means enclosing something which should not be visible to the general public. This should be taken private. That is what encapsulation means, right? So what we generally do over here is, let's say I've written this particular code, and we create this particular app wherein this code is the main backbone. Someone comes, so let's say I give this example that salary, and let's assume that based on this particular code, all the salary and everything would be paid. So I have given the salary to be, or let's say the pay raise to be 5%, right? Pay raise I've given to be 5%. Now some notorious person comes in the industry and he fidgets with the code and changes this 5% to 10%. What then? Because this pay raise is obviously accessible at any point. He can change, as I have already mentioned in the previous lecture, that how do you change? You can change it directly from the code itself, or you can create another line and change it. Now, if you create another line to change it, it might be easily visible. But what if you do not do that? If you change it in the base code itself. So what we do here is we use the format of encapsulation. What it does not let anyone to change your particular values. How do we do that? Let's understand through this particular code. Okay. So let me, So what I've done over here is I've taken the same exact code, person with first name and last name, with name and age. Now, let me first, show you what the problem we might face. Okay. So what I've done over here is I've taken a class, given the name and the age. So here, the factor that can be changed is age, right? Now, what I've done is another function which displays the name and the age. So here, I've given the name of the person as Mahesh and age to be 36, right? Now, when I click on display, I get the age to be, the name to be Mahesh and age to be 36, which is understandable because the age given is 36. Now, what if someone comes and change the age to be 26? And then when we press p1.display, we get the age to be 26. So in a real life scenario, this should not be the case, right? You cannot change some private data. So how do we stop the person from changing this particular code? What we do is we use encapsulation. Here, if you see, I've written self.age equals to age. What I really needed to do was self._age, this underscore. This underscore is what is required to make it private. So self._age equals to _age. Also in the framework, the argument, we have taken _age. This makes it to be private. Now what happens when I have set the display to be self.name and self._age? Now see here, P1, person, Mahesh and 36. When I display it, I get 36, right? But now when I also write 26 over here, I get the same age. No change at all. I get the 36 as the age. However, if I really want to change the name, what if I want to change the name? So p1.name equals to, let's say, Eddie, right? In that case, that would be changed. Why? Because now I have not used any privatization or encapsulation. How do I do that? The simple method, use an underscore over here as well, right? Also, I need to change this. Now you see that Eddie is not also changed because I've encapsulated all the variables. So this is what we exactly do in a real life scenario, and this is all about encapsulation. Now a question should be arising in your mind. What if I really want to change the age? Maybe the age is a factor that changes with time. So what if I really want to, one thing we can do is we can create a time series data function wherein with passage of every time the age changes. That is okay. But what if there is a mistake in data? If we really need to change? So in that scenario, what we do is we create another function. So here I've clearly written the only way to modify a private value is to create a function for the same inside the class. So what I've done is, up to this was written earlier. Now I include another extra function, right? Another extra function called modify variable. So the name of the function is anything you want to put. I've taken that to be modify variable, and I've taken new age to be the value, the argument. So now self._age equals to new age, right? Now what happens is, if we go forward, we see that I've taken the same credentials, Mahesh and 36, p1 display, Mahesh.36. But now the second time what I've done is p1.modify variable. So I've used this function modify variable, and for new age I've taken 26. And now self.age becomes new age. So when I press the p1.display, it gives me the new age, that is 26. So this is the only method, that is by creating a new function inside the class, we can change the encapsulation, the value encapsulated, right? This is all about encapsulation. Now we move to another important topic called as polymorphism. What is polymorphism? Polymorphism is nothing but poly means many and morphism means forms. So when a same thing, an object, can coexist in different forms, we call that to be polymorphism. Now how do we link it with classes? So let's understand with this particular example itself. What I've done over here is I've taken 3 classes. The first class is SBI, second is ICICI, and third is HDFC. And I've taken a function to be rate of interest. And the rate of interest is returning the interest rates that are prevalent in this banks. So for SBI, I've taken it to be 6, for ICICI it is 5, and for HDFC it is 7, right? Now what I've also done is I've taken another class called common. You can take any class you want. I'm sorry, not a class, but a function, right? So def common bank. Now what I'm doing is I'm returning bank dot rate of interest. Now understand what this bank means. This bank is written instead of self. You could have written self over here as well. And then here that would have changed by self, nothing else. So def common bank, return bank dot rate of interest. And now I've created the objects. So S for SBI, I for ICICI, H for HDFC. Now when I write common.s, I get 6, for I get 5, and for H I get 7. So what did I do over here? This is a typical case of polymorphism wherein there exist several banks, several classes consisting of several banks with different rate of interest. And instead of going to each classes each and every time, what I do, I create a common interface, a common function, which take into account the rate of interest of every bank. And then I create the objects with, pertaining to each classes, here SBI, ICICI and HDFC. And then I print them each and every time. And I get the return values as 6, 5 and 7, the return values that has been mentioned. So instead of writing HDFC dot rate of interest, HDFC dot ICICI dot rate of interest, I simply write common dot s, because that returns itself the rate of interest. So it makes our code looks easy when similar types of classes coexist. So this was all about inheritance, encapsulation and polymorphism, which are advanced topics inside the OOPS. All right. Bye everyone.